Now we are focusing on customers, partners, and suppliers. In sales, commerce, and economics, a customer, sometimes known as a client, buyer, or purchaser, is a recipient of a good, service, product, or an idea obtained from a seller, vendor, or supplier via a financial transaction or exchange for money or some other valuable consideration. A business partner is a commercial entity with which another commercial entity has some form of alliance. Supplier, a person or company that supplies goods. Here you can see a MuleSoft accelerator for Salesforce B2C Commerce Cloud. This asset is a component of MuleSoft accelerators for Salesforce Cloud, which accelerate implementation of essential integration use cases for Salesforce Commerce Cloud. Modern consumers expect shopping experiences to be relevant, personalized, and seamless across channels. Gone are the days of bulk uploading and updating data on a weekly basis. For retailers, this means consumer products and inventory data needs to be connected in real time across all systems and channels. Here you can see products, and here you can see PIM, and products are connected to Mule here, and B2B Commerce Cloud, and also products are connected to Mule and B2C Commerce Cloud. Here you can see SAP ERP under inventory, and you can see OMS under order sync and order status, and under customer you can see SAP ERP and Service Cloud, and here products inventory, order sync and order status, and customer are connected to Mule, and Mule interact with B2C interacts B2C Commerce Cloud, and here Mule interacts order sync and order status. Here you can see MuleSoft accelerator for Salesforce B2C Commerce Cloud solution overview. Here you can see a customer process API. The customer process API orchestrates the data flow between the experience and system API. The current release supports the following functionality: orchestrate the ordinary history records for a specific customer for a given period between Salesforce Experience API and OMS system API. Orchestrate the customer's data to be sync with SAP from B2C commerce. Orchestrate the contact data to be synced with Salesforce from B2C commerce. Contains AMQ listener for consuming customer profile data from Anypoint MQ, transform and invokes the process API. And Sales Salesforce B2B commerce system API. The B2B commerce system API exposes product data as JSON. The current release supports the following functionality: create a product into B2B commerce, get an existing product from B2B commerce, perform product master updates into B2B commerce. The endpoint expects payloads that use the existing entities: product category, product catalog, product image, price book, and commerce entitlement policy. The entities must have been already set up in B2B commerce Lightning system before using these operations. Salesforce B2C commerce system API. Here you can see here. The B2C commerce API the B2C commerce system API exposes product orders and inventory data as JSON. The current release supports following functionality: perform inventory updates into B2C commerce, perform product master variant master updates into B2C commerce, perform status updates into B2C commerce. B2C commerce experience API. The B2C commerce experience API supports following functionality: new customer profile creations and updates made to existing profile in B2C commerce for storefront users and are posted through this API for further processing by the downstream APIs and implementations. Inventory process API. The inventory process API orchestrates inventory updates between SAP system API and B2C commerce system API. The current release supports the following functionality: fetch inventory updates from SAP system API and publish the records to Anypoint MQ. Point 2, next point, subscribes to inventory updates from Anypoint MQ and propagate updates to B2C commerce. PIM product information management system API. This product information management PIM system API is intended to provide the means to access products data. It supports following functionality: point 1, fetch product details based on product ID, and next point, get products and filtered by last modified date. The results are paginated using the query parameters offset and limit. Products process API. The products process API syncs PIM products updates into B2C commerce. This API provides a scheduler to trigger the job and orchestrate products from product information management system to B2C commerce. This API invokes the PIM system API and B2C commerce system API. It supports following functionality: creates or updates the products in B2C commerce using the B2C commerce system API, get products from PIM using system API using the system API. Salesforce system API. The Salesforce system API provides a means to access Salesforce Service Cloud application data. It supports the following functionality: query case information from Service Cloud, update case information into Service Cloud, upsert contact information into Service Cloud. SAP system API. The SAP system API fetches inventory updates from SAP. The current release supports the following functionality: fetch inventory updates from SAP to SAP for a given period, customer data sync from B2C commerce to SAP. Order management system OMS system API. The OMS system API supports the following functionality: create a new order in Apache of biz, query the status of an order from Apache of biz, fetch order history records from Apache of biz for a specific customer for a given period. The order process API, new orders. This application polls the configured SFTP location for files with the name pattern orders underscore YYY mmdd-hhmmss.xml containing B2C commerce exported orders and publishes the content to Anypoint MQ. All orders go into one message. The order process listener extracts each order from Anypoint MQ and calls the order process API, which then calls OMS system API to create orders in the backend OMS. Order process API order status update. The poll order status underscore fetch order status published to AMQ. Order status values for OMS, whichever it is, will not match the B2C commerce values. So values are translated as needed before updates are made. Below are the values for OF BIS reference implementation, OMS, order approved, order created, order cancelled, order completed, order hold, order payment settled, payment not received. In CC, created, new, completed, cancelled, failed. The values are mapped as shown now. In OMS, order underscore approved is matched with B2C commerce completed, and in OMS, order cancelled is matched with B2C commerce cancelled. Order completed is matching with completed. Order underscore hold is matching with failed. MuleSoft accelerators common services, the common components. The MuleSoft accelerate leverage a number of common components refers to as common services. These services include following: common scheduler, unified scheduling, notification services, send notification, security services, API security policies, API template, generic implementation template. The notification and scheduler services can be configured and is installed as independent applications. Notification services consist of multiple applications. Depending on which notification targets are selected, one or more security policies can be applied using API Manager. The API template project can be used to quickly create implementations for new API specifications. Here you can see B2C commerce is here, and here you can see customer in the experience layer. Here you can see custom API in the process layer, and you can see inventory, products and orders in process layer. And here you can see OMS, PIM and B2B and B2B commerce system API and SAP and contacts system layer in system layer. Here B2C commerce is connected to customer in experience layer, and a customer in experience layer is connected to customer in process layer, and it is connected to Mule in system layer, and here it is connected to Mule in system layer, and Mule is passed from this API is passed from the contact is passed from Mule to Service Cloud. Here you can see Mule in orders in process layer. Order status is passed from order status is passed from OMS to Mule, and order status is passed from Mule to Mule in process layer. And B2C commerce orders are passed from B2C commerce production to Mule API in process layer. And orders are passed from Mule to Mule in system layer, and Mule in system and orders are passed from Mule to OMS. Products are passed. Orders are order status is passed from Mule to Mule in system layer, and order status is passed from Mule to B2C commerce production. Here you can see products in API in products layer. Product in process layer. Here the products information. Products are passed from PIM to Mule in system layer, and products are passed from Mule to Mule in process layer. Here Mule products are passed from Mule to Mule in system layer, Mule in system layers, and here the Mule is connected to B2B commerce, and products are passed from Mule to B2B commerce, and here the products are passed from Mule to B2C commerce staging. Here you can see inventory in process layer. From SAP EAP is connected to Mule in system layer, and inventory is passed from SAP EAP to Mule. And here's the Mule is connected to Mule in process layer. And here the inventory is connected to Mule in system layer. It's here inventory passed from system layer to Mule in system layer to B2C commerce production. MuleSoft accelerator for retail. MuleSoft accelerator for retail includes pre-built APIs, connectors, integration templates, and reference architecture to enable retail IT teams to jumpstart digital transformation initiatives. The MuleSoft accelerator for retail empowers retail IT teams to unlock data from system including ERP, CRM, MDM, commerce, and marketing to activate digital project faster. Retail IT teams can take advantage of pre-built APIs, connectors, and implementation templates and reference architecture to create customers' 360 profiles. Shoppers expect seamless and personalized experience across retail channels. Retailers have the data, but disconnected system prevent them from effectively leveraging the information. This portfolio of solutions helps retail IT teams to ramp up faster without needing to start from scratch. So here you can see MuleSoft accelerator for retail systems interact with MuleSoft accelerator for retail. Here you can see under systems commerce, sales, service, marketing, MDMDB, OMS, PIM, ERP in SAP, Azure, CDP, Marketo, and Snowflake. Outcomes interacts with MuleSoft accelerator for retail. Here you can see under outcomes customer profile sync, sales order sync, product syncs, real-time inventory management, and deliver relevancy with CDP. Here you can see MuleSoft accelerator for retail API-led diagram. RGB B2B commerce system API. Accelerator B2C commerce API. B2C commerce system API supports the following functionality: perform inventory updates into B2C commerce, perform product item master and variant creation into B2C commerce. Product inventory and category values can be assigned. Price book through OC API cannot be added. Perform product item master and variant updates into B2C commerce. Retrieves products list using search criteria from B2C commerce. Perform order updates or perform order status updates into B2C commerce. B2C customers system API supports the following functionality: create a customer in B2C commerce, updating an existing customer in B2C commerce, get a specific customer from B2C commerce by customer number, search customers in B2C commerce by global customer identifier, external customer identifier or email address. RCG MDM System API. This integration templates implements MDM system is API, a system API specification. This is a system API for a master data management system, MDM, to manage parties, partly roles, contact points, and externals. A scaled down version of MDM has been implemented using a MySQL database. This API follows the Cloud Information Model CIM, which is also used for the MDM DB schema. This parties resource has endpoints to search parties, for example, individuals, associate contact points to a party, associate external IDs of other system to a party, and also relate a party with another party. A party can be of type individual, organization, or households. The only types of contact points that can be associated at this time are contact point email, contact point address, and contact point phone. There can also be a single instance of each type. A party can be related with other party using a relation type and can have one or more parties as part of the relation. The current implementation do not support relating households to other parties. The accelerator of-biz customer system API. Of-biz customer system API provides a means to access customer person data from of-biz. This supports following functionality: queries customer person organization from of-biz, create customer person organization in of-biz, updates customer person organization in of-biz. Accelerate of-biz product system API. The of-biz product system API used to manage the product's data. The current release supports the following functionality: create, updates products from of-biz, searches products by product ID, master ID, retrieve a list of existing products, accelerator OMS system API. The OMS system API supports following functionality: creates, updates order in Apache of-biz, searches order by customer ID, external ID, order ID, and last modified date, retrieve list of existing orders. RCG's Salsify product system API. The Salsify product system API is used to manage the product data. The current release supports the following functionality: create, updates products in PIM, Salsify, searches products by product ID, retrieve list of existing products. RCG Azure Cosmos database system API. The RCG Azure system API can be used to manage web, email engagement, loyalty, and subscription data in Azure DB. Create web engagement, email engagement, loyalty subscription in Azure system. Searches web engagement, email engagement, loyalty subscription by customer ID and last modified date. B2C commerce system API supports following perform inventory updates into B2C commerce. Perform product item master and variant creation into B2C commerce. Product inventory and category values can be assigned. Price book through OC API cannot be added. Perform product item master and variant upset into B2C commerce. Perform order status updates into B2C commerce. Retrieve promotions by promotion ID. Retrieve a list of existing promotions. RPG Marketo System API. The RPG Marketo System API can be used to send promotional marketing emails to customers, create campaigns and schedule campaign emails to Adobe Marketo. Searches campaign by campaign ID and campaign names. RPG Salesforce CPD system API. The Salesforce CPD system API supports the following functionality. Retrieve records from CPD by matching the criteria supplied for following object: loyalty, subscription, email engagement, and web engagement. Create or updates records into CPD through bulk or streaming mode for the following object: loyalty, subscription, email engagement, and web engagement. RCG Snowflake System API. RCG Snowflake System API can be used to manage loyalty, subscription, web engagement, and email engagement data in Snowflake DB. Create loyalty, subscription, web engagement, and email engagement records in Snowflake system. Searches royalty, subscription, web engagement, and email engagement by customer ID, create date, and last modified date. Salesforce Customer System API. Salesforce Customer System API provides a mean to access account and contact data from Salesforce. It supports following functionality: queries customer, person account, and account information from Salesforce. Create customer, person account, and account in Salesforce. Update customer, person account, and account in Salesforce. Queries contact information from Salesforce. create contacts in Salesforce, updates contacts in Salesforce, queries related contacts of the given account from Salesforce, updates account and contact relationships in Salesforce. Accelerated Salesforce Marketing API. The Salesforce Marketing System API provides a mean to access subscriber data from Salesforce Marketing Cloud, subscriber and individual data extension. It supports the following functionality: queries subscriber individual information from Salesforce Marketing, create a subscriber individual information in Salesforce Marketing, updates subscriber individual information in Salesforce Marketing. Salesforce Accelerator Salesforce Order System API. The Accelerator Salesforce Order System API fetches orders from Salesforce system, fetch list of orders, fetch individual order, create order, patch individual order. Accelerator SAP ECG Accelerator SAP ECC System API, ECC Customer System API. The SAP ECC Customer System API can be used to manage customer data in SAP ECC. The current release supports the following functionality: creates updates customer in SAP ECC, searches customer by email, master ID, customer ID and last modified date, retrieve list of existing customers. Accelerator SAP S/4HANA Customer System API. SAP S/4HANA Customer System API provides a means to access customer, person, organization account data from SAP S/4HANA. It supports the following functionality: queries customer, person, organization account information from SAP S/4HANA, create customer, person, organization information account in SAP S/4HANA, updates customer, person, organization account in SAP S/4HANA. Accelerator SAP S/4HANA Orders System API. SAP S/4HANA Order System API fetches orders from a SAP S/4HANA system. It allows you to fetch a list of orders, fetch an individual order, create order, patch individual order. Accelerator SAP S/4HANA Product Availability System API. The SAP S/4HANA Product Availability System API fetches product availability from SAP S/4HANA system. It allows you to fetch product availability. SAP S/4HANA Product System API. SAP S/4HANA Product System API fetches products from a SAP S/4HANA system. It allows you to fetch list of products, fetch individual products, create products. Accelerator Customer Process API. The Customer Process API orchestrate The data flow between different systems. The current release supports the following functionality: orchestrates custom profile data to be synchronized from B2C commerce. Salesforce, SAP, Offbis, and to MDM and downstream systems. Orchestrates customer contact data, contact point email address to be synchronized from B2C commerce, Salesforce, and SAP to Salesforce Marketing Cloud. Orchestrate individual data to be synchronized between Salesforce and Marketing Cloud and to MDM. Orchestrates organization data to be synchronized from Salesforce and SAP to MDM and downstream systems, not Salesforce Marketing Cloud. And B2C commerce do not support organization data. The accelerator ERP customer process API. The ERP customer process API is used to manage customer data. Current release supports the following functionality: creates, updates customer individual in SAP ECC and individual organization customer in SAP S4HANA, searches customer individual by email, master ID, customer ID, and last modified date, retrieve list of existing customers, polls the recently updated or created customer individual in SAP ECC and publishes to the queue to sync across all systems. ERP order process API updates order. ERP order process API is used to manage the order data. Currently supports the following functionality: updates order in SAP S4HANA, searches order by order ID, external ID, and customer ID, retrieve list of existing orders. The inventory process API supports the following functionality: get inventory availability from SAP S4HANA to B2C Commerce Cloud or B2B Sales Cloud Service. Also asynchronously update inventory in B2C. The accelerator order process API. The order process API orchestrates the data flow between different systems. The current release supports the following functionality: orchestrates orders data to be synced from B2C commerce or Salesforce core to MD and downstream system like Salesforce, SAP S4HANA, and Offbis. Orchestrates orders created in B2C commerce or Salesforce core status sync from SAP S4HANA to MDM, B2C commerce, Salesforce, and Offbis. Accelerator PIM sync process API. PIM sync process API loads products from the system of records to the PIM database. It also pulls products modified using last updated time and pushes the updated data to the queue for downstream systems. It supports following functionality: loads all products from system of records to the PIM database, gets updated products from the PIM database, publishes the updated products to the queue, RPG product process API. This integration template implements RCG product process API specification. It can be used to retrieve, create, and update products. RCG customer data platform process API. The RCG CDP process API can be used to sync data of Snowflake, loyalties, and subscription, and assure email engagement and web engagement with Salesforce CDP. The implementation supports AMQs to push the data to RCG Salesforce CDP system API. Send customer profiles for loyalty, subscription, web engagement, email engagement to RCG Salesforce CDP system API. RCG Data Lake Process API. The RCG Data Lake Process API can be used to sync data from Snowflake and Azure data lakes. The implementation supports schedules batch jobs as well as manually triggered batch jobs. This API also receives published CDP segments from AWS S3, publish customer profiles for loyalty, subscription, web engagement, email engagement to RCG Data Lake Exchange, Anypoint Queue Exchange, retrieves and publishes CDP segments to RCG Marketing Exchange, Anypoint Queue Exchange. The RCG Marketing Process API. The Marketing Process API listens to the campaign creation and updates events from Anypoint MQ and orchestrates the creation and updates to B2C and B2C system. This API uses the MDM system API to retrieve the current customer information, customer ID of respective system to create a campaign for that particular customer in B2C and Marketo. Creates or updates the campaign in Marketo and B2C. Searches the campaign for campaign ID, customer ID. Retrieve a list of existing campaigns. B2C Accelerate the B2C Commerce Experience API. This the B2C Commerce Experience API supports the following functionality: the new customer profile creation and updates made to existing profile in B2C commerce for storefront users are posted through this API for further processing by the downstream APIs and implementations. A new customer orders created in B2C commerce are posted through this API for further processing by downstream APIs and implementation. Get real-time inventory products per store in B2C commerce from SAP S4 HANA. Accelerator Salesforce Experience API. The Salesforce Experience API displays OMS data as JSON. The current release supports the following functionality: displays order history records for a specific customer in a given period of feeder from OMS system API, displays inventory of the product in the associated stores. Salesforce marketing accelerator Salesforce marketing listener. The solution includes pre-built APIs, connectors, and integration systems to help unlock business critical data from external systems. These templates provide details of how Salesforce marketing system API handles events, and in case of creation new subscribers, and how those events are processed in to message exchange. The message posted to exchange will be in a cloud information model CIM format, which will be processed by customer process API. Salesforce accelerator Salesforce topic listener. The Salesforce topic listener application supports the following functionality. Listeners for case event from Salesforce push topic converts events payloads to CIM and publishes it to Anypoint MQ. Listen the customer person account and account events from Salesforce push topic converts the event payloads to CIM and publishes it to Anypoint MQ. Listen for contacts events from Salesforce push event converts the event payload to CIM and publishes it to Anypoint MQ. Listen for opportunity events from Salesforce push topic converts the event payload to order CIM, creates an order in SAP HANA and publishes the order CIM to Anypoint MQ. Listen for order from Salesforce platform event created by the order trigger, converts the event payload to order CIM, publishes the order CIM to Anypoint MQ, which then creates the order in SAP S4 HANA. RCG SAP S4 HANA event listener. The SAP event listener application supports the following functionality. Listen for order events from SAP HANA. SAP S4 HANA converts the event payload to CIM and publishes it to Anypoint MQ. Listen for customer person account events from SAP S4 HANA, converts the event payload to CIM and publishes it to Anypoint MQ. Listen for the product events from SAP S4 HANA, converts the event payload to CIM and publishes it to Anypoint MQ. Listen for purchase order acknowledgement events from SAP S4 HANA, converts the event payload to JSON. And send it to Anypoint Partner Manager. Listen for shipping notification event from SAP S4 HANA, converts the event payload to JSON and send it to Anypoint Partner Manager. Listen for invoice events from SAP S4 HANA, converts the event payload to JSON and send it to Anypoint Partner Manager. RCG Salsify Channel Listener. The Salsify Channel Listener application supports the following functionality. Listen for products events from Salsify, converts the event payload to CIM and publishes it to Anypoint MQ. There are custom component. The Accelerator B2C plugin install pickup cartridge. This plugin enhances the app storefront base cartridge by providing buy online pickup in store functionality, including following capabilities. Shoppers can search for stores by geographical radius. Shoppers can check the real-time inventory from SAP S4 HANA system by providing the zip code and within radius. Shoppers can select a store for pickup. Shoppers can change the selected store by inhabiting initiating another search. Shoppers can purchase multiple products and have different products delivered to different addresses, including to a store. Shoppers can review their order histories to see where orders are delivered. Shoppers can review order receipts and summaries to see where products were delivered. Accelerator B2C commerce sync cartridge. The customer profile sync cartridge is used to detect when customer profile is created and updated in Salesforce B2C commerce, and invoke an API for further processing for customer profile data in real time. Accelerate ID graph LWC. The Lightning Web Component LWC can be used as the front end for displaying data from API delivered with Mule. This LWC displays a networking graph related to a source record in Salesforce as a root node to n number of systems as child edge nodes. This LWC is written generically to support any parent-child relationship as a network graph. Accelerator POM parent. The Accelerator POM parent project is used for storing common configurations, constant common dependencies, and resources used across all child projects. It provides a single Maven configuration file, POM, which is used as a parent by most other Accelerator projects. Accelerator product availability LWC. Lightning Web Component LWC can be used as a UI for displaying data from APIs delivering with Mule, which displays an inventory check button to perform an available to promise check against ASAP. Is written generically to support inventory check and update available quantity, product ID, and location. And there are common services can be used across any use case. MuleSoft accelerators common services. The Mule accelerator leverage a number of common components refers to as common services. These services include following: common scheduler, unified scheduling, notification services, send notifications, security services, API security policies. The notification and scheduler services can be configured and installed as independent applications. The notification services consist of multiple applications depending on which notification targets are selected. One or more security policies can be applied using API Manager. Here you can see system API. Under system API you can see SAP custom API, sales service custom API, marketing API, B2C commerce API, MDM DB API, OMS API, sales service order API, IRP order API, sales service product API, PIM API, SAP inventory API. In process APIs, you can see Salesforce topic listener, Salesforce marketing listener, customer API, order process API, SAP S4 event listener, ERP order process API, product process API, PIM sync process API, real-time inventory API. In experience API, you can see B2C commerce API and B2B commerce API. Here you can see CRM, marketing, B2C, B2B commerce, ERP order update service, and here you can see MDB, OMS, PIM. Here you can see SAP customer API. is connected to customer API and sales customer API and marketing API, B2C commerce API, and MDM DB API are connected to IPS interacts with customer API. Customer API in process APIs interact with Salesforce topic listener and B2C commerce API in experience API, and Salesforce topic listener is connected to CRM here, Salesforce. Here MDM DB API and B2C commerce API and OMS API and sales service order API APIs interact with order process API. Order process API interacts with ERP orders process API, SAP S4 event listener, and B2C commerce API in experience API and B2B commerce API and B2C commerce API, and B2B commerce API is connected to API interacts with B2C commerce, and here B2B commerce API interacts with B2B commerce. Here ERP order API interacts with ERP orders process API, and ERP orders process API interacts with order process API. Here Salesforce marketing listener interacts with marketing, and SAP S4 event listener interacts with order process API and SAP and ERP order updates. Here ERP order API and OMS API and MDM DB API and B2C commerce API and sales service product API interacts with product process API, and product process API interacts with PIM sync process API. Here PIM API interacts with PMI sync process API, and PIM sync process API interacts with product process API, and SAP inventory API interacts with SAP inventory API, and B2C commerce API interacts with real-time inventory API. Real-time inventory API interacts with service, B2C commerce, and CRM. Here you can see a partner manager architecture. With Anypoint Partner Manager, you can deploy B2B integration message flows to a MuleSoft hosted Cloud Hub IPaaS platform or an Anypoint Runtime Fabric instance. The functional features and user experience in configuring B2B integrations with Partner Manager are deployment target agnostic. However, differences in underlying architecture when implemented the functionality in the runtime occur. When you deploy a configured message flow, Partner Manager automatically transforms the configuration used in the message flow. It then deploys and updates a set of applications necessary to orchestrate end-to-end B2B processing to the Mule instance. These applications include receive endpoint services, document processing service, replication service, send endpoint services, Here the the partner manager. MuleSoft hosted the cloud control plane, enabling users to configure partner profiles, build and deploy B2B integration message flows, and monitor B2B transaction activity. To receive endpoint services, services to receive inbound B2B or EDI messages from partner transport protocols such as AS2 and SFTP, or outbound application messages from your organization backend via HTTP, HTTPS or SFTP. 3. Document processing service, core B2B processing engine responsible for parsing, validating and translating received B2B messages based on the configurations and mapping in Partner Manager. 4. API replication service, tracking service responsible for updating transmissions and transaction activities to the control plane and the payload storage API. 5. Send endpoint services, services to deliver transformed inbound application messages to internal applications such as ERP, billing, order management via transport protocols like HTTP, HTTPS, SFTP, or outbound B2B EDI payloads to your partner via AS2, HTTP, HTTPS, or SFTP. 6. Payload storage API to store B2B payload data in your storage solution. Here configurations and activity are in Partner Manager. Partner Manager interacts with the replication service. Replication service is in runtime plane, and replication service is connected to payload API. API is connected to payload storage. Here one configurations and activity are in Partner Manager. In the 2 here, trading partners interacts with AS2 receiver, and trading partners are connected to AS2 receiver, SFTP receiver, and FTP receiver as inbound. And AS2 receiver here and SFTP receiver, FTP receiver, and SFTP receiver is connected to document processing service as inbound. And the document processing service is connected to HTTPS sender. It's document processing. Here the 2 here the backend systems and application network is connected to HTTPS receiver as and FTP receiver and SFTP receiver as outbound, and HTTP receiver, FTP receiver, and SFTP receiver is connected to document processing service as outbound. And here 5 document processing service is connected to HTTPS sender, SFTP sender, and FTP sender as outbound, and HTTPS sender, SFTP sender, and FTP sender are connected to backend system or application network as outbound. And here the document processing service is connected to SFTP sender, AS2 sender, and HTTPS sender as sorry, this one is as inbound, and this one is outbound. You can see the color. And document processing system service is connected to SFTP sender and AS2 sender and HTTPS sender as outbound, and FTP sender and SFTP sender and S2 sender and HTTPS sender are connected to trading partners as outbound. And here you can see document processing service here, and here the replication service, and here the payload storage API, and here the payload storage. Here you can see the partner manager for CloudHub. When deploying B2B integration message flows to CloudHub, Anypoint MQ uses queues between processing stages to add additional reliability to B2B message processing. As of the first deployment from the partner manager, runtime applications deployed to the CloudHub region specified in the business group's default settings in runtime manager default. Anypoint MQ queues automatically generate during the deployment process in the same or nearest available region. Any new runtime application deploys to the same region as the first deployment. Here you can see source is connected to receive endpoint, replication service, receive endpoint, document processing service, and send endpoint, and MQs are in CloudHub here. The receive endpoint is connected to Anypoint MQ, and Anypoint MQ is connected to document processing service. And the document processing service is connected to MQ, and MQ is connected to send endpoint. Here the receive endpoint, document processing service, and send endpoints are connected to Anypoint MQ. Anypoint MQ is connected to replication service. Replication service connected to partner manager and payload storage API. In configurations and activity are in partner manager. Anypoint's replication service is connected to payload storage API. Payload storage API is connected to payload storage. Here the send endpoint is connected to target. Here you can see in parallel you can see the receive here, and identity, validate, and transform. Here the deliver. MuleSoft hosted control plane is here the partner manager. The partner manager deployed CloudHub workers are receive endpoint, document processing service, send endpoint, and replication service. Here you can see Anypoint MQs, and customer implemented apps are here a payload storage API and payload storage. Here the payload storage API here, customer implemented apps. Here you can see a partner manager runtime, partner manager for runtime fabric. When deploying message flows to runtime fabrics, partner manager uses the active MQ set up and configured by the user between processing stages to add additional reliability to B2B message processing. Active MQ destinations queues are automatically created when the first transaction is processed through the runtime applications. Here you can see source is connected to receive endpoint, document processing service, send endpoint, and replication services, and customer hosted JMS active MQs are in runtime fabric. Here receive endpoint is connected to runtime customer hosted JMS, and it is connected to document processing service, and it is connected to customer hosted JMS, and it is connected to send endpoint. Receive endpoint, document processing service, and send endpoints are connected to customer hosted JMS, and it is connected to replication service. Replication service is connected to partner manager and payload storage API. Configurations and activities are in partner manager. Replication service is connected to here payload storage API. Payload storage API is connected to payload storage, and here you can see the in parallel receive and identity identify, validate, and transform, and here deliver. Here the Mule hosted control plane is partner manager here. Partner manager deployed Mule apps are in receive endpoint, document processing service, send endpoint, and replication service. Here the customer hosted JMS are here, and the customer implemented apps are in payload storage API. Here you can see the partner manager's message framework orchestrate the processing of your business transaction from source to target using the configuration object shown in this diagram. A message flow is a path from path along with which message travels from its source through the through a data view translation map to its target. You can set up message flows and to send and to receive between your system and your partner. Anypoint partner manager message flows consist of objects such as endpoint, message types, identifiers, and mappings. Partner manager's message framework orchestrates processing of your business translation from source to target using the configuration objects shown in this diagram. You can create message flows in one of the following contexts. Inbound message flows receive the message from your partners and transform them into internal application message formats, and then send the transform messages to your backend systems. Outbound messages flows receives messages from your backend application and transform the messages to your partner message format, and then send the EDI part message to your partner. And the here you can see source is connected to receive via configured source endpoint. Receive via configured source endpoint, pass and validate, transform, validate schema, and send to configured target endpoints are in runtime here. Here the receive via configured source endpoint is connected to the source endpoint. Here the source endpoint, source message type, map, target message type, and target endpoints are in message flow configuration. And here message via configured source endpoint is connected to pass and validate, and it's connected to source message type, and it's connected to transform. Transform is connected to the map, and transform is connected to the validate schema. Then validate schema is connected to a target message type, and validate schema is connected to send to configured target endpoint, and it is connected to target endpoint, and it's then send to configured target endpoint is connected to target. Here you can see the components of an inbound message flow. The inbound message flow does the following: receive application messages from your partner either directly or through a third-party connection, to the transform the message to the format used by your backend application, and 3, the forward the messages to those applications. The following diagram shows the component of an inbound message flow. Here one receiving endpoint at which the host receive the transmission from the partner AS2, FTP, HTTP, HTTPS, SFTP. 2 message source message type of the received message payload, CSV, EDI fact, JSON, X12, XML. 3 map, data view map used to transform the source message type to the target message type. 4 target message type format into which the data view map transforms receive messages, JSON, XML. 5 target endpoint to which the transform message is sent, typically as process API, FTP, HTTP, HTTPS, SFTP. Here the partner is going to do receive via configured partner endpoint, receive via configured partner endpoint, pass and validate, transform, validate schema, and send to configured target endpoint are in runtime. And the receive via configured partner endpoint interacts with receive from the partner endpoint, and receive from the partner endpoint, receive from partners type, message type, data view map, target at host message type, and target at host endpoint sign inbound message flow configuration. Here the receive from the partners endpoint, AS2, STP, HTTP, HTTPS, and SFTP. Here received via configured partner endpoint is going to pass and validate. It interacts with receive from partner messages, partners message type, identifiers, schema, validation, rules, CSV, EDI-fact, JSON, X2L, and XML. Pass and validate is connected to transform. It interacts with data view map. Transform is connected to validate schema. It interacts with target at host message type schema, CSV, JSON, XML. Validate schema is connected to send to the configured target endpoint. It interacts with the target at endpoint, FTP, HTTP, HTTPS, SFTP. Send to the configured target endpoint is connected to enterprise applications. Here you can see the component of an outbound message flow. An outbound message flow receives the application messages from the backend, transform the message to the format your partner supports, and then forward the message to a partner. The following diagram shows the component of an outbound message flow. One, here the receiving endpoint where the host receives the transmission from the backend, FTP, HTTP, HTTPS, SFTP. Source message type, message type of the message received from the backend, CSV, JSON, XML. And 3, transform data view map used to transform JSON or XML format or to EDI-fact or X2L map. You must have Java output, application or Java to transform JSON to JSON or XML formats to EDI-fact. Fourth, target message type to which to transform the input message, CSV, EDI-fact, JSON, X2L, and XML. Target endpoint, partner endpoint to which to send the transform message, AS2, STP, HTTP, HTTPS, and SFTP. Here the endpoint application is continued to receive via configured source endpoint, receive via configured source endpoint, validate schema, transform, validate, and send to configured endpoint in runtime. Source at host endpoint, source at host message type, data view map, send to partners message type, and send to partners endpoint are in outbound message flow configuration. Receive via configured source endpoint is connected to source at host endpoint, FTP, HTTP, HTTPS, SFTP, and receive via configured source endpoint is connected to validate schema. It interacts with source at host message type, identifiers, and schema, CSV, JSON, XML. Validate schema is connected to transform. It interacts with data view map. Transform is connected to validate. Validate interacts with send to partners message type, identifier, schema, validation rules, CSV, EDI-fact, JSON, X2L, XML. Validate is connected to send to configured partner endpoint, and it interacts with the send to partners endpoint. AS2, FTP, HTTP, HTTPS, SFTP. Send to configured partner endpoint is connected to partners. Here you can see outbound message routing. Anypoint Partner Manager outbound message routing frameworks enable you to implement receiving endpoint in a variety of ways. You can use single endpoint to receive the different types of application messages such as advanced shipment notices and invoices from your backend systems. Use dedicated endpoint for each message type from the backend systems. Follow balanced approach by implementing a mixed set of receive endpoint to receive application messages from the backend systems. When messages are received by the endpoint, partner messenger routes the payload to the appropriate message flow based on the message type, partner reference ID, and host reference ID configurations. One, identify the message type using the following criteria: relative path for HTTP, HTTPS endpoint, file name for SFTP endpoint, which follow this convention, message type underscore endpoint information dot file type. For example, if your message type ID is an AR invoice, then the file name is AR-invoice underscore 2021-02-17 underscore 1055 underscore 000 dot JSON. To validate the payload against the schema supplied during the message type definition, three uses the supplied data view map to obtain the partner reference IDs, optional host reference IDs, and business keys. The partner reference ID and host reference ID specify the message flow through which the transaction is processed. Here you can see a receive application message JSON or XML from backend systems, and it is connected to identify message type HTTPS relative path or an SFTP file name pattern. It is connected to extract partner and host references identifiers using the reference ID mapping in the message type by definition. It is connected to determining partner name associated with to reference ID. It is connected to host reference identifier is defined for the message type and is present in the payload, and it is connected to look for an outbound message flow for the trading partner with extract match for partner and host reference identifier. If it is yes, route to the message flow. If it is no, look for the outbound message flow for the trading partner with extract match for partner reference ID and host reference ID set to ignore, and if it is yes, route to the message flow. And if it is no, look for an outbound message flow for the trading partner with extract match for host reference ID and partner reference ID set to all identifiers. If it is yes, route to the message flow, and if it is no, look for an outbound message flow for the trading partner with host reference ID set to ignore and partner reference ID set to all identifiers. If it is yes, route to the message flow, and if it is no, transaction is marked as failed. Here you can see trading partner relationships. By extending MuleSoft core capabilities to B2B, our customer archive API-led connectivity approach to B2B, this enables them to create a decoupled architecture that abstract the underlying complexities to focus on building partner relationships. Here's the diagram how API-led connectivity can coexist with EDI. In this example, we show the following APIs. System API. This layer takes the core domain object in an enterprise and shield consumers of these domains from complexities such as dealing with multiple backend systems, working through different connectivity protocols, and abiding by specified security protocols. Process APIs. This layer takes the core assets and combine them with the business logic to create more value. By aggregating data from product order and partner APIs, the sales order, invoice, and shipping notice APIs are created. Experience APIs. This layer is designed for consumption by a specific end user app or device that will be exposed to partners. Enterprise can now receive purchase orders from partners via EDI or apps. APIs. Anypoint Partner Manager create a partner profile that can be templatized and reused between partners if new partner requires similar B2B or EDI format. For example, EDI 850 via AS2. This will be exposed to partners via a web channel or portal to allow visibility of B2B transaction status and associated payload to be viewed or downloaded. Here you can see the partner 1, partner 2, partner 3, and it interacts with partner 1. Partner 1 interacts with partner API partner 1. Here the partner 2 is interact with partner 2 here. EDI 850, EDI 810, EDI 856, and partner 3 interacts with the partner 3 here. EDI 858, EDI 810, EDI 856, and here the service app API. partners, partner APIs and service app APIs, and these are in experience layer. Here the partner 1, partner 2, partner 3 and service API is interacts with sales order API, invoice API and shipping notice API. Sales order API, invoice API and shipping notice APIs are in process layer. Here the sales order API, invoice API and shipping notice API interacts with product API, order API and partner API. Product API, order API and partner API in system layer, and here you can see product API interact with the database, and the order API interact with the SAP, and partner API interact with the Salesforce. Here you can see B2B integration, and as organizations embrace digital transformation, partners are tunneling to the web. New technologies are leading to an increase in partner customer expectations. New technologies are leading to an paper communications is no longer the norm, and support for legacy technologies is the key. Business must be flexible in working with variety of partners using different technologies. Automations are also replacing manual data entry processes. Amid this comes to the need for a system that communicates with all partners more consistently. This system must take into account the many different formats used in business communication today, and many different protocols that partners may be using to connect. Enterprise application network is to simplify this task, business must look at B2B integration platforms. The goal here is twofold. First, you want to digitize your manual paper-based processes and modernize your legacy digital formats. This is usually done by creating APIs that allow you to send and receive data with partners in their preferred formats. Second, you want to do it a consistent and expandable way. This requires using a tool that can be easily onboard new partners, monitor all integrations, and track all communications, ensuring consistency across partners. Communications allow business to unlock the true potential of B2B integration. Here you can see business partners here, and here it's interacts with EDI, X12, EDI, fact, XML, JSON. Here business then here those interacts with business partners via AS2, SFTP, FTP, HTTPS, and here the HTTPS interacts with API is connected to API Manager, and API Manager is connected to Partner Manager. Partner Manager interacts with the Enterprise. Partner Manager is in the Enterprise Application Network. And there are interactions here. Here you can see retailer supplier purchase order integration and sample a demo. It's a purchase order integration between fictional retailer NTO and supplier mythical supplier, and as part of the larger order to cash workflow, leveraging Anypoint Partner Manager. This demo covers the following functional aspects. At NTO retailer, translate purchase order XML messages from the backend system to the outbound EDI X12 here step 1 here at the NTO retailer, the translate purchase order XML messages from the backend system to outbound EDI X12 850 and send them to the mythical supplier via AS2. At the mythical supplier, translate the inbound EDI 850 transaction to enterprise PO JSON message and send to the process API. Orchestrating order captured in the backend. 3 at the mythical supplier, generate 997 functional acknowledgement accepting or rejecting the received EDI message and send it back to the NTO retailer via AS2. 4 at the NTO retailer, reconcile the received 997 acknowledgement and update the corresponding outbound PO transactions into the mythical in step 1. At mythical, translating purchase order acknowledgement JSON message from the backend system after PO is processed into the outbound EDI 8850 PO transaction and send into the NTO retailer via AS2. At the NTO retailer, translate the inbound EDI 855 transaction to the Enterprise PO Act XML message structure and send to the process API updating the status of the purchase order in the backend. Here you can see here the ERP, here the outbound PO process APIs and inbound PO process APIs and partner managers and in NTO retailer, and here the partner manager, outbound PO process API, ERP order system API and ERP in mythical supplier. Here the ERP is connected to outbound PO process API and it is connected to partner manager via PO XML. Partner manager is connected to partner manager mythical supplier via EDI 850 partner order via AS2. Partner manager is connected to inbound PO process ID via PO JSON and inbound process inbound PO process API is connected to ERP order system API via JSON and it is connected to ERP is connected to ERP order system API and ERP order system API is connected to outbound PO process API via JSON and it is connected to partner manager via PO JSON and partner manager is connected to partner manager via 997 and also EDI and also via EDI 855 PO via AS2 and partner manager is connected to inbound PO process API via PO XML and it is connected to ERP. You can see here the HTTPS. Example, you can see BAPI custom object structure BAPI str inventory data in here, inbound inventory data, short description, and you can see the other information here. As an example 2, we can consider MuleSoft accelerator for retail API client ID settings. OpenID connect allowed scopes. You can see here sfcc.orders, sfcc.customerlists.rw, etc. As an example 3, we can consider interface local repository supplier factory in org.mule.my1.client.api. This provides a set of suppliers to be used to resolve Maven repository fault. Here you can see now as an example we can consider use partner manager use partner manager to these things in Anypoint Partner Manager overview. Anypoint Partner Manager enables you to perform bidirectional business to business B2B message exchanges using API and electronic data interchange EDI formats, and to conduct business transactions such as buying and selling products with your partners. Transactions are typically transmitted over transport such as HTTP, SFTP, and exchanges such as AS2. Partner Manager supports X2L, JSON, and XML message formats. Use partner managers to perform technical onboarding of your partner, set up, manage, and monitor business message flows between your systems and your partner systems. Track and report on business transaction to achieve greater operational efficiently in B2B transaction. View meta information, validation errors, and all messages included with each transaction payload. Transmission payload contain one or more business messages. Members of your organization can use partner managers to perform a variety of functions, including designing and testing message flows, managing the activity of business transaction with your partners, optimizing backend services and performance. As an example 5, we can consider the other enhancement in 2.18.0 in Anypoint Partner Manager release notes. Here the deployment of each environment is now shown in the Partner Manager host page. You can now remove schema files that are attached to the previously configured JSON and XML messages type if you don't need the schema validation on payload. To use the now we are considering getting started with Partner Manager. To use the Partner Manager, follow these steps. Partner Manager provides simplified configuration-driven B2B integration solution to manage B2B partner ecosystem. To use the Partner Manager, follow these steps. Assign permission to Partner Manager users. Configure Partner Manager deployment settings to set up the payload storage API. Configure a host profile. Configure a profile for each of your partners. Optionally configure third-party connections. Configure message flows. Deploy and test configured message flows. Monitor transmissions and individual messages. Troubleshoot rejected or overdue acknowledgements. Now we are considering deploy Partner Manager runtime apps to a new environment. In deploying Partner Manager runtime apps in setting up the Partner Manager environment, you must configure Partner Manager settings for new environment if there's no Partner Manager configuration for any environment in particular business group. One, here the logon to Anypoint platform using an account that has organization administration permissions. 2, in the navigation bar or main Anypoint platform page, click Access Management. 3, in the Access Management navigation menu, click Business Groups. Click the Partner Manager and click the Configure New Environment. Select the environment and deploy the target types. 6, in the configuration, configure a Partner Manager environment window. Configure either Cloud Hub deployment settings or Runtime Fabric deployment settings. Here now we are considering configuring global AS2 endpoints in configuring and managing a host profile in Anypoint Partner Manager to prevent inbound requests with expired certificates from being processed by Anypoint Partner Manager. Access the host page in the global endpoint settings section. Click AS2 in the inbound endpoint settings column. 3, select enforce AS2 certificate expiration date and click save. Now we are considering configuring and managing partners in Anypoint Partner Manager. Create new partner by using partners page to specify partner specific information such as name, identifiers, endpoint, and validation rules. Before you create your first partner, make sure that you have configured your payload storage API and that you have the following information. Partner's name, usually the name of the company. One or more partner identifiers such as the AS2 ID, X2L ISA, X12GS, and so on. To create partner, first one in partner manager, select partners in the navigation menu. 2, click create partner, then partner. 3, enter the following information here. A name, text string that uniquely identify your partner, type, identifier type, qualifier, value that appears in if you selected X12 ISA or ADFAC UNB as the type, identifier value that uniquely identify your partner in the EDS stream. For click create partner. Now we are considering configuring and managing third-party connections in Anypoint Partner Manager. Creating a new third-party connection by using partners page to specify a connection name, identifiers, connection specific endpoints if needed, and other settings. Before you create your first third-party connection, make sure you have configured the payload storage API and that you obtain the following information: connection name, usually the name of the company, and the one or more AS2 identifiers for the connection. To create third-party connection, in the partner manager, select partners in the organization navigation menu and then create partners and then third-party connection. Enter the following information here: the name, text string that uniquely identified the connection, type, identifier value, either a value uniquely identified the connection with the EDI stream or the AS2 identifier if the connection uses AS2. For click create third-party connection. Now we are considering configuring and managing message flows and creating inbound message flows in Anypoint Partner Manager. Create inbound message flows to receive messages from partners, including messages that go through third-party connections. When you create an inbound message flow, you can validate and transform the inbound messages and then send them to your backend applications. Anypoint Partner Manager routes the inbound messages based on the matching identifiers configured for partner. Before you create the first message flow, configure your payload storage API to create inbound message flow. One, from the partner manager, now navigate menu, select message flows. 2, click navigate, click new message flow, then receive from partner. 3, either select an existing partner from the list or select new to create a new partner as described in the create a partner in the documentation. 4, configure the receiving endpoint. 5, configure the source message type. Import the translation map. Configure the target message type. Configure the target endpoint. Verify the message flow is complete. Now we are considering add and configure a new identifier in message flow in sender and receive identifiers in message flow components in Anypoint Partner Manager. In Partner Manager, select the name of your host organization in the organization menu. 2, in the identifier section, click new. In the new identifier dialog, select identifier type from the drop-down list: AS2 identifier, EDI fact UNB, reference ID, X12GS, X12 ISA. In the identifier menu, enter the value to the unique name of your identifier. If the selected EDI UNB or X12 ISA as the type value, we must also select a qualifier from the list and then click create identifier. Now we are considering locate the locate the transmission in tracking transmissions in Partner Manager administration. Select the transmission to view its details and view and download the message contents. In the navigation menu, select activity, select transmissions, search for the transmission. Optionally filter the search results based on the following criteria: partner name, message direction, date range within which the message was sent. You can retrieve up to 1 week's worth of messages. Message processing status such as received, acknowledgement status such as overdue, partner message type such as X12 850, host message type such as JSON, host purchase order, transmission ID, whether the transmissions are replaced. Partner Manager returns a list of transmissions that meet your criteria along with the related information such as date of the transmission was received, number of messages in the transmission, message type, control number, and acknowledgement status. Do either of the following. Click the transmission to view the additional information about transmission and to view its message flow, or click the messages to see the information about the messages in the transmission as described in the activity message tracking in the documentation. Now we are considering configuration and deployment related errors in troubleshooting Anypoint Partner Manager. You cannot deploy this message flow because of the payload storage is not properly configured. The cause is you have not configured the payload storage. Solution is if your payload storage is configured, verify that it is active. From within the Anypoint Partner Manager, select your hostname profile, scroll down to payload storage and click edit. Review your payload storage configuration status, and if your payload storage is not configured, configure it as described in the configuring a payload storage API. Now we are focusing on cloud platforms. The hardware and operating environment of a server in an internet-based data center. The system software components, OS, virtual machine monitor, etc. are called the cloud stack. The software infrastructure for a cloud computing service, which includes applications that let users create and manage their own accounts. As an example, we can consider OpenStack. OpenStack is a free open standard cloud computing platform. It is mostly deployed as infrastructure as a service IaaS in both public and private clouds, where virtual servers and other resources are made available to users. The software platform consists of interrelated components that control diverse multi-vendor hardware pools of processing, storage, and networking resources throughout a data center. Users manage it either through a web-based dashboard, through command line tools, or through RESTful web services. As example 2, we can consider here you can say Amazon Web Services. Amazon Web Services Inc. AWS is a subsidiary of Amazon that provides on-demand cloud computing platforms and APIs to individuals, companies, and governments on a metered pay-as-you-go basis. These cloud computing web services provide distributed computing processing capacity and software tools via AWS server farms. One of these services is Amazon Elastic Computing Cloud EC2, which allows users to have at their disposal a virtual cluster of computers available all the time through the internet. AWS's virtual computers emulate most of the attributes of a real computer, including hardware central processing unit CPUs and graphics processing units GPUs for processing, local RAM memory, hard disks, SSD storage, a choice of operating systems, networking, and preloaded application software such as web servers, databases, and customer relationship management CRM. As an example 3, we can consider parameter connection. The connection types to provide this the connection types to provide to this configuration. Azure Service Bus Azure Service Bus Connector 3.2 Mule 4. Anypoint connector to this is a Anypoint connector for Azure Service Bus. Azure Service Bus connector enables message integration with Azure Service Bus on the cloud. Here you can now we are considering Anypoint Platform PCE components in Anypoint Platform PCE overview in Anypoint Platform Private Cloud Edition. The following table provides the component information for Anypoint Platform PCE polymer list. Anypoint Runtime Manager enables you to track and manage your deployed Mule applications. Runtime Fabric Management, including Security Edge and tokenization, automates the deployment and orchestration of corner-hosted Mule applications and API gateways. Anypoint API Manager enables you to manage the registers API. Secrets Manager stores and manages secrets for supported Anypoint platform services. Endpoint Exchange enables your organization to share various assets for reuse across integration projects. Access Management enables you to create Anypoint platform account or configure external federated identity. Anypoint Design Center, excluding Flow Designer, enables you to create API specifications in several modeling languages and to create RML API fragments. Anypoint Analytics Insights provide in-depth visibility into business transactions and events in mobile Mule apps deployed to Cloud Hub and on-premises services. Anypoint Analytics Anypoint Visualizer enables you to explore your application via an application network graph. Anypoint Analytics API provides insight into how your APIs are being used and how they are performing. Anypoint Monitoring provide visibility into integrations, Mule flows, and components in your application network. Object Store version 2 allows Cloud Hub application to store data and state across batch processes, Mule components, and applications either from within an application or by using Object Store REST API. Anypoint MQ, a multi-tenant cloud messaging service that enables you to perform advanced asynchronous messaging scenarios between tenant applications. API Testing provide the testing framework that enables you to easily build automated tests for your integrations and APIs. Now we are considering Anypoint Platform Cloud Edition to 3.2.2 release notes. In Anypoint Platform Private Cloud Edition release notes in Anypoint Platform Private Cloud Edition. Here what's new. This version Anypoint Platform Cloud Edition Anypoint Platform PCE contains security and vulnerability fixes. This release adds support for RHEL 8.7 and 8.8 releases. This release adds support for API console proxy trusted domains. For guidance on how to add new trusted domains, see trusted domains in documentation. This release adds a 30 minutes account locking after 100 failed local user logging attempts. Here you can see Anypoint monitoring in supported configuration for Anypoint Platform PCE in Anypoint Private Cloud Anypoint Platform Cloud Private Cloud Edition. These are the enhanced API analytics monitoring limits. API summary metrics, retention 1 year. API IP address metrics, number of IP addresses per API per minute, limited to 20 unique API IP addresses, retention 1 hour. API endpoint matrices, number of endpoints per API per minute, limited to 100 unique endpoints, retention 1 hour. Here you can see unsupported Anypoint monitoring features in Anypoint monitoring on Anypoint Platform PCE in Anypoint Platform Private Cloud Edition. Anypoint PCE does not support the support of the following Anypoint monitoring features. Support for Mule 3.8.x, log management as alternative to use your server logging capabilities or third-party vendor like Splunk. Increased storage capacity. This capacity is not required because the archive API is not supported. Archive API, this is not applicable because log management is not supported, and API functional monitoring as an alternative use third-party vendors such as Pingdom. The tools option in the left-hand menu is not available. Here you can see supported environments in environment prerequisites in Anypoint Platform PC prerequisite in Anypoint Platform Cloud Edition. The following environments are only the only environment supported by the Anypoint Platform Private Cloud Edition, Anypoint Platform PCE, which VMware Bare Metal Virtualization, Physical Servers, Emission Web Services, AWS. If you are using AWS, perform the steps provided in Provision AWS prerequisite in the documentation. Now we are considering install Anypoint Platform Private Cloud Edition, Anypoint PCE in installation workflow in Anypoint Platform Private Cloud Edition. To install Anypoint Platform PCE, my MuleSoft professional services must be involved throughout the installation process. Prior to installation, you have your infrastructure team verify that the required infrastructure is correctly installed and configured as described in the product prerequisite in the documentation. Now we are considering delete the local user after installing Anypoint Platform PCE in configure Anypoint Platform PCE in Anypoint Platform Private Cloud Edition. During installation, Anypoint Platform Private Cloud Edition, Anypoint Platform PCE, create a local Anypoint Platform user that enables you to configure platform components during the installation. The credentials for this user are stored locally in Anypoint Platform. However, after configuring an external authentication provider such as LDAP, you should delete this user to improve security. Before deleting the local user, perform the following. Install and configure your external identity provider. Ensure that the system admin user is not the owner of any other organizations. Select the new user to whom you want to assign administrative privileges. This user must be defined in your external identity provider. 3. Determine whether determine the internal user ID for this user. From Anypoint Platform, select the access management. Select users and then select the name of the user. Record the internal user ID and this ID applied to a URL. 4. Enter the gravity shell. Then you give the command gravity space enter. 5. Identify one of the identification server containers. kubectl space get space products space -n space access -management space -l space component equal authentication -server. 6. Change the owner providing the internal authentication -server container and user ID obtained earlier. kubectl space exec space -it space -n space access -management and authentication server prod space -c space application space space node space bin /change _owner .js space new owner id user ID. This command change the owner from the default system user to new new user managed by the external authentication provider. This command to use the command you should use be similar to the following here. kubectl space exec space -it space -n space access -management authentication server prod space -c space application space space node space bin /change _owner .js space new owner id space A362F-982F-998-2F-493C-BC08F-91BE90D4. Disable and delete system admin user. Login as the user you just added as the organization owner. From the Anypoint platform, select access management, select users, select username in the same row as system admin, and delete, select disable and then delete, and then select delete. This remove the default user from the platform. Now we are considering create a backup in configure backup and restore your for Anypoint platform PCE in managing Anypoint platform PCE in Anypoint platform private cloud edition. To create a backup, run the following command on any node in the cluster. Here gravity backup /var /lib /gravity /parent /share /backup.tar.gs. This command creates an archive of the current system state in /var /lib /gravity /parent /share /backup.tar.jz. You can pass the following optional parameters to the gravity backup command. / follow. The output the backup jobs log to SDD out. In the following example here, TEE enables you to output the STD out and the file at the same time. Timeout specify the deadline for backup jobs, for example 30s or 5M. Default is 30M minutes. Now we are considering MuleSoft professional services required in upgrade workflow in Anypoint platform private cloud edition. Contact MuleSoft professional services prior to updating. MuleSoft professional services must be involved throughout the upgrade process. Before an Anypoint platform private cloud edition Anypoint platform PCE upgrade is performed, you must verify that your working installation meet an additional requirement of the new Anypoint platform PCE version, such as opening additional ports or adding a new port at the load balancer. When upgrading from the previous Anypoint platform PCE version, all policies available in the previous version remain. Policies are not replaced, but additional policies might be included in the upgrade. Refer the About Anypoint platform PCE in documentation for additional information about policies included in the Anypoint platform PCE. Refer to the Anypoint platform private cloud edition release notes in the documentation for additional information about the most recent Anypoint platform PCE version. Now we are considering features included in the government cloud overview in government cloud. The MuleSoft government cloud includes full functionality of the Anypoint platform runtime plane services and Mule runtime engine, and the subset of Anypoint platform control panel, browser based management and of APIs and runtime engine instances functionality. Government cloud supports the full API-led connectivity methodology and end-to-end API lifecycle management. The feature to deploy an API proxy to hybrid agent is not available in government cloud. MuleSoft government cloud supports Mule runtime engine version 1.9 and the later with some restrictions. Government cloud supports the Mule runtime engine TLS release channel. The Mule runtime engine H releases the channel is not supported as it is not in the FedRAMP approved, because the MuleSoft government cloud does not support Mule agent with the self-signed certificate. Specific versions of government's Mule agents are required. Mule 3 version 1.12.0 and later supported only for cloud deployment. Mule 4 version 2.2.0 and later. For more information about creating servers with the FIPS support, refer to add servers to runtime manager in the documentation. By default, in runtime engine is configured in the FIPS compliant mode. Although Anypoint Studio is not part of the government cloud, you can use Anypoint Studio offline to build application and then manually deploy them to the government cloud. Now we are considering FedRAMP compliance in security in MuleSoft government cloud. In government cloud, MuleSoft Government Cloud meets all the FedRAMP security and compliance standards. FedRAMP provides an standardized approach to security assessment, authorization, and continuous monitoring for cloud products and services used by US government. Mule4 connectors that are verified for FIPS compliance can be found in the Anypoint Exchange at assets provided by MuleSoft. Following modules are FIPS compliant: compression, crypto, Java, JSON, OAuth2 provider, scripting, Spring, validation, and XML. A partial list of FIPS 140-2 compliant Cypress suites supported by MuleSoft Government Cloud is provided in FIPS 140-2 compliant support in the documentation. A third-party assessment organization 3PAO performed the security assessment following guidance in the National Institute of Standard and the Technology NIST 800-37 publication. The security assessment validated the management, operational, technical security control to use to protect their confidentiality, integrity, and availability MuleSoft Government Cloud and the data it stored, transmit, and processes. MuleSoft obtained in the FedRAMP agency authority to operate ATO at the moderate impact risk level. Now we are considering set up your government cloud account in government cloud. After you set up your account, Government Cloud works with your identity provider IDP to enable single sign-on SSO for users in your agency. Instead of using the Anypoint platform sign-in page, your users sign into the SSO system to access Anypoint platform. When you purchase Government Cloud, your customer success manager sends you an onboarding instruction and access to the MuleSoft Help Center to configure your IDP to work with Government Cloud. Verify that you have access to the support portal. If not, contact your customer success manager for credentials. In the support portal, click the create new case, enter your support center credentials, click login, request to configure an external identity provider for your organization to enable SSO. Provide the required information, your IDP, and the additional information if applicable. For required information, see the documentation that supplies to SSO standard you use, OpenID Connect, SAML. Using the information you provide, MuleSoft supports configure IDP to enable SSO for your organization. Important, Government Cloud does not support the configuration of local users, for which usernames and encrypted passwords are stored outside the Government Cloud. Now we are considering root external request to a dedicated load balancer dedicated load balancer configuration in Government Cloud. A Mule Government Cloud dedicated load balancer provides an alternative domain name to route the HTTP request to Mule application listening on port 8091 and HTTP request to Mule application listening on port 8092. You can also use mapping rules to rename request to the MuleSoft Government Cloud dedicated load balancer to a different Mule application domain name. Mule Government Cloud dedicated load balancer exposes an external domain name that resolve to the public IP address that are accessible from the outside of your Mule Government Cloud Anypoint VPC network. LB-name is the name you gave to the load balancer when you created it here. Here underscore lb-name.lb-g prod-rt.anypointdns.net. Now we are considering Government Cloud IPsec settings in Anypoint VPN configuration in Government Cloud. Anypoint VPN supports the following IPsec settings in the Government Cloud environment. IKE version 1, IKE version 2 for root-based VPN only, AES 128 or 256 bit encryption operating in the CBC and GCM, SHA-2 256 384 512 hashing, Diffel-Hellman PACE 1 groups 1421, Diffel-Hellman PACE 2 groups 14-21, timeouts for IKE version 1, IKE PACE 1 lifetime 28,800 seconds 8 hours, IPsec PACE 2 lifetime 3,600 seconds 1 hour, timeouts for IKE version 2, iKey phase 1 lifetime to 28,000 seconds, 7 hours and 50 minutes. IPsec phase 2 lifetime 30,000 seconds, 50 minutes. Now we are focusing on Saas, software as a service. Saas is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. Saas is also known as on-demand software and web-hosted software. As an example, we can consider this operation. SAP Concur connect dash connector colon create dash report. This is related to SAP Concur connector 4.2 Mule 4. Anypoint connector for SAP Concur Concur connector is a SaaS provider from SAP for integrated travel and expense management solution. As an example, we can consider example 2. We can consider Magento connector, Mule 3. Magento connector Mule 3 enable instant API connectivity with the Magento e-commerce platform with the Magento connector, making it simple to manage e-commerce storefront, shopping carts and inventory. As an example 3, we here to install the box connector in Anypoint Studio, follow these steps. Open Anypoint Studio and go to help, install new software. Select Anypoint connectors, update site to http://repository.mulesoft.org/connectors/ releases/3.5.0. locate the step 2, locate the box connector. Step 3, click next and accept the license agreement. Step 4, restart studio when prompted. Here the box we are regarding here box connector 5.1 Mule 4. The Anypoint connector for box is a closed sourced SDK based connector that provide synchronization of data and automation of processes between box and third party CRM, CMS, mobile and social applications. Now we are focusing on social. Social of a group of people, an organization, etc., consisting or composed of people associated together for friendly interaction or companionship. As an example, we can consider the message processor, LinkedIn get profile by LinkedIn get profile by ID. This gets the profile by ID. Here the with regarding LinkedIn connector Mule 3. This is under LinkedIn connector Mule 3. Find top talent faster through link in by creating connectivity between the professional social networking site and popular third-party applications and services with MuleSoft Anypoint Link-in connector. A Anypoint connector gives businesses the power to connect to numerous LinkedIn APIs, including job, share, groups, invitation, profile, and more, to create seamless integration across applications and services. This is in org.mule.modules. Here you can see the attribute ID, the ID to search, and this is a string. And here you can see child element, blinking, colon, profile dash fields. This is optional, and the profile fields to retrieve. Here you can see the fields to retrieve, and this returns return type is person, profile by ID. As an example too, we can consider this message processor Facebook colon like. This write to the given profiles feed or wall. The Facebook connector this is related to Facebook connector Mule 3. It provides businesses with instant Facebook API connectivity, allowing them to easily integrate the social networking service with other applications such as Twitter, Drupal, and Salesforce, or extend the application capability to applications by leveraging Facebook connector. This is in Mule org.mule.modules here, and here you can see attribute post ID. This represent the ID of the post object, and this message processor returns return type is boolean, and it returns true if successfully liked. Here as an example 3, to use this Mule module Facebook within a flow, the name is space to the Mule must be included. The resulting flow will look similar to the following. The Mule module LinkedIn the Mule module Facebook. The Facebook is a social networking service and website launched in February 2004. This is in org.mule.modules. Here goes your flows and configuration elements. This module is configured using the config element. This element must be placed with outside your flows and at the root of your Mule application. You can create as many configurations as you deem necessary as long as each carries its own name. Error handling during authorization. If for any reason an error occurs, while processing the callback, the exception strategy of the flow containing the authorize will be executed. So if the callback sent the wrong information, you can handle the situation by setting up an exception strategy as follows. This is in the environment with the Mule LinkedIn connector. Now we are considering mobility and devices. Mobile computing is a human-computer interaction in which a computer is expected to be transported during normal usage, which allows for a transmission of data, voice and video. Mobile computing involves mobile communication, mobile hardware and mobile software. Communication issues include ad hoc networks and infrastructure networks, as well as communication properties, protocols, data formats, and concrete technologies. Hardware includes mobile devices or device components. Mobile software deals with the characteristics and requirement of mobile applications. Computing device, a functional unit that can perform substantial computations, including numerous arithmetic operations and logic operations without human intervention. It can also be a device that provides a specific set of functions, such as a phone or a personal organizer, or more general functions such as a laptop or desktop computer. As an example, we can consider HTTP endpoint coupled with a REST component. The first step in communicating with the mobile application would be to use an HTTP endpoint coupled with a REST component. This step takes care of most of the complexity associated with communicating with your mobile apps and consuming JSON objects. Now we are considering Microsoft OneDrive connector release notes in Microsoft OneDrive connector. Here the Microsoft OneDrive connector. Anypoint connector for Microsoft OneDrive. OneDrive connector enables you to access Microsoft Graph API to provide a unified programmability model that you can use to access tremendous amount of data in Microsoft 365, Windows 10 and Enterprise Mobility plus Security. Now we are focusing on APIkit, Anypoint API Manager and APIhub. APIkit, Anypoint API Manager and APIhub. Now we are focusing on APIkit. APIkit is a tool for building Mule, REST or SOAP APIs. You develop APIs based on one of the following modeling languages: RESTful API modeling language, RAML 1.0 and 0.8 versions, Web Services Description Language, WSDL. APIkit simplifies the design and implementation of REST APIs. APIkit generates minimal Mule flows based on either RAML or WSDL that meet the communication operations required by a REST or web service contract respectively. In Studio, the REST APIkit project looks like this. This is the REST API in Anypoint Studio UI with Package Explorer and Canvas sections. Here 5 items illustrated here show one here the project files in the Package Explorer of Studio with the API dot RAML file under here under here API.RML file under src/main/resources then API folder. Number 2, here the main flow with the APIkit router. Here number 3, the APIkit console. Number 4, error handling, and number 5, the generated flows for each resource method. The generated minimal flows meet the communication operations required by a REST contract. Here in Studio, the SOAP APIkit project look like this. This is a SOAP API in Anypoint Studio UI with the Package Explorer and Canvas sections. The 4 items illustrated here shows number 1 here the project files in Package Explorer of Studio with the example.wsdl file under src/main/resources/API folder. Then number 2, the main flow with the SOAP router. Number 3, SOAP fault response template. Number 4, generated backend flows containing SOAP message templates. After you create your APIkit project, you can continue building the application by performing calls to test API and finalize its implementation. Here as an APIkit anatomy, the REST SOAP Studio project uses APIkit has following part: REST or SOAP interface, main flow and backend flow. Here we are considering REST Studio project here. In the REST interface, relationship between REST resources and actions are called resource action pairing. The interface exposes the internal data assets requested by the REST service. Also, the interface define API designating resources that contain no access data and specify actions such as get and put on the example data. Here you can see API console interacts with RAML. Here you can see the API main, API console and API config here. This is flow 1, this is flow 2, and here you can see HTTP listener -config and APIkit config, the main then flow name equal API main, etc. And you can see here APIkit router. Here you can see a SOAP Studio project. In the SOAP interface, the interface defined by a WSDL file exposes a number of services. Each service has a set of operations. The underlying type of data is XML, defined by schemas within WSDL file or by an imported XSD file. Here you can see SOAP UI interacts with WSDL, and here you can see API main here. The SOAP route is here, and SOAPkit -config here. Sorry, API SOAPkit -config is here, and SOAPkit -config is here. This is flow 1, and this is flow 2, and here you can see HTTP listener -config, APIkit SOAP config, and flow name, API main, etc. Here you can see a REST API main flow. The main flow for RAML based API manages these functions, exposes the API using HTTP or Jetty, routes requests between the interface and the backend flows based on HTTP request, routes reference exception strategies that produce HTTP status code responses. The APIkit router tasks include routing messages, serializing responses, and validating payloads, headers, query params, and URI params. Message routing consists of routing incoming API requests to existing Mule flows and returning outgoing HTTP response codes to exceptions. Here you can see HTTP is connected to APIkit router, and APIkit router is connected to here, and you can see the reference exception strategy here. Here you can see SOAP API main flow. The main flow for WSDL based API managers the first two tasks. The logic in the main flow accepts requests, sends responses, and facilitate communication between interfaces and API process. The main flow typically consists of HTTP listener and SOAP router components. Here you can see /t-shirt service /t-shirt service port. It's there, and it's connected to SOAP router, and it is connected to here, and you can see the error handling here. Here you can see the how APIkit works with RAML. The following diagram shows how a RAML based API built by APIkit processes end user request. Here in step 1 you can see the end user sends HTTP request to API. In step 2 the HTTP or Jetty endpoint in the main flow receives the request and passes the message to APIkit router. In step 3 the router checks with the interface to confirm that the resource action pair exists in the interface. Step 4 here the router checks where to see if a body is defined as part of the request. Generally, a request sends a body with put, post, patch requests. In step 5, if the request includes a body, the router determines the media type associated with the body, then matches the request content type with the one defined in the interface. In step 6, if a schema is defined for the content type, the router checks that the schema on the incoming request matches the schema defined in the interface. If the schema is not valid, the application rejects the request. In step 7, the router uses the information contained in the interface to determine which backward backend flow should receive the request. For example, based on the request and the resource action pairing, the router determines what it should send the request to flow 2. In step 8, router send the request to flow 2. In step 9, the flow 2 process the flow 2 processes the request, accessing a resource and acting upon data as required. In step flow 10, step 10, flow 2 returns a response to the router. In step 11, the router pushes the response to the HTTP or Jetty endpoint. Step 12, the HTTP or Jetty endpoint sends the response to the end user. And step 13, from the console, you can simulate API calls by submitting requests through the web user interface. Here you can see single Mule Studio project. Inside it you can see RAML API definition, end user, and config.xml. Here interface.raml. So interface.raml interacts with config.xml, and config.xml interacts with end user. Single Mule here a single Mule Studio project here. In config.xml, we can see APIkit colon config is there, and exception storage is set there, and flows are here, and config.xml interacts with Anypoint platform private cloud edition or on cloud storage, and you can see the console here. The console interacts with a single Mule Studio project, and here you can see get, and here you can see post request, and here response in console. As an example, we can consider create a new project, new APIkit project. This procedure launches the new project and generate a main flow with an HTTP listener and an APIkit router, and references to flows to handle errors. The project supports REST resources and methods. These flows, called skeleton flows, are the bare minimum structure needed to support the RAML specification. The RAML files imported by this procedure is located at src/main/API. Step 1, download the example file to your local drive. Step 2, from the file menu, select new, then Mule project. Step 3, in the new Mule project wizard, enter a project name, my project for example. Mule server 3.8.0 will be selected by default in the runtime section. And step 4, check add APIkit components. Step 5, in the APIkit settings section, select the downloaded api.raml example file, and step 6, click finished. Here you can see a screenshot of step 5. So here in the APIkit settings section, select the downloaded api.raml example file here, and if you run the project, for example, API returns a list of machines. The output is the payload set on the message by get :/machines :API config flow. This is a sample output here. As an example 2 in XML, we can consider the APIkit element here. So here APIkit config, the APIkit configuration. This is a required one, and here you can see APIkit namespace and schema. Namespace and schema locations. Now we are considering APIkit overview. APIkit is a toolkit that simplifies the development of API-led applications for Mule developers. It scaffolds the application from given specification, validate inputs, parameter validation, and create Mule unit test suites. APIkit has a module for each supported web service type. APIkit for GraphQL supports GraphQL APIs. And APIkit for OData v2 version 2, and APIkit for OData version 4 support OData APIs. APIkit for REST support RML, and OAS APIs. APIkit for SOAP support SOAP APIs. With APIkit, incoming requests are intelligently routed to the appropriate endpoints based on the defined API contracts. This routing mechanism simplified the request handling, improves performance, and ensures that the requests are processed by the correct API resources. Although each module is designed for family of web services, all modules share common usage patterns. So if you are a Mule developer who works with SOAP APIs, you can easily work with GraphQL, RAML, OData, or OAS APIs. Here you can here you can see the what's new in the API kit for GraphQL 1.0.0 for Mule 4 release notes. In the API kit release notes, it's here the API kit for GraphML module is released. Now we are considering language and protocol support in API kit compatibility. Here the RESTful API modeling language RAML 1.0 and 0.8. Open API specification OAS 2.0 and 3.0, OData 2.0 and 4.0, SOAP 1.1 and 1.2. Now we are considering select sources in mapping GraphQL API to your data sources in API kit for GraphQL. Module sources vary depending on the implementation of your GraphQL API. API kit for GraphQL provides two kinds of sources, data fetchers and data loaders. Your selection depends on your implementation needs. GraphQL is transport layer agnostic, so you choose the main connector listener depending on protocol that you want to serve your data. Now we are considering querying GraphQL API implementation. Here the trigger request. This is in the API kit for GraphQL. The following examples illustrate the implementation of GraphQL service to query data using API kit for GraphQL. Before running this example, download and run the API kit for GraphQL application example in the documentation, which loads a simple data set in memory for testing purposes. The example application is based on the following GraphQL API. You can see here type post ID, ID, user type, title is string, body string, comments, comment, etc. And request query example is the following. In the following example, the type query define the list of queries that are that the services exposes. Here the type query. Here the look for user by ID. Here the look for a post by ID. Here returns the list of all users. Here the returns the list of all posts. Retrieve all posts. This this use case makes the simplest request for the data of each existing post. Here the here you can see the make a query here, all post ID, title, body. Trigger a request here. Here the get a response. Here you can see ID, title, body, ID, title, body. Here also ID, title, body for the all posts. Now we are considering installing OData version 2 tooling in API kit for OData. To install the API kit for OData version 2 plugin in Anypoint Studio, first select help, then install new software, then add to the in name type API kit for OData version 2 update site. In the tree in location, type your URL of the site, https://studio.mulesoft.org/s4/API kit for OData. 4. Select add. 5. Select Anypoint OData plugin and next. 6. Accept the terms and condition of the product and select finished. 7. Restart Studio to complete the installation. Now we are considering retrieve a list of customers in building, implementing and testing OData version 2 API. Here they call the REST API to retrieve the list of customers here. The response is like this as an example. Now we are considering installing OData version 2 version 4 tooling in API kit for OData version 4. To install the APIkit for data version 4 plugin in Anypoint Studio, select help, then install a new software, and then click add. To the in name the type APIkit for data version 4 update site, and in location type in URL of the site, for example here, then click add. Here type the URL here, then click add. 5 select Anypoint OData plugin, and then click next. 6 accept the terms and condition of the product and click finish, and then 7 restart the studio to complete the installation. Here you can see the get request example in building, implementing, and testing an API in APIkit for OData for implementation example here. The request is here, and customer BLA blouse, and response is here. Now we are considering design your API specification with design your API specification in building, implementation, and testing the REST API in APIkit for REST. Design your API specification with API designer from the design center with the API specification project tool from Anypoint Studio, or with the test editor if you of your choice. 1. Create JSON file including a list of users that serve as an example of what the service returns. To save it as for example user underscore example.json. Create a new blank file with the following API specification here. Save it as api.raml. 5 in the studio, select file, new file, then new, then module, new project. 6 in the project name, type the name of your Mule project. If you are importing API specification from Exchange, select import to publish API and click plus icon, and then select from Exchange. If you are implementing API specification from the local file, if you are in your file system, select import RAML from local file. If you are importing API specification from your design center, select download RAML from design center. 7 select scaffold flows from these API specifications if not already selected. Click finish. APIkit generates the necessary flows based on the API specification you imported. 9 run your project by clicking run, then run as, then Mule application. Now we are considering validating query parameter headers in configuring behavior during runtime in APIkit for REST. Configure API router to validate headers and query parameters, restricting them to attribute specified in your API specification. Select first in the studio, select APIkit router, then click edit your router configuration. 3 select your parameter strict validations. Validations to restrict usage of query parameters to the ones defined in your API specification. 4 select headers strict. This is the query parameter strict validation. 4 select header strict validations to limit the header to the ones specified in your API specification. You can configure APIkit router to validate headers and query parameters by updating APIkit configuration code as follows here. Now we are considering identifying identity operations to implement in implementing SOAP SOAP interface in APIkit for SOAP. To know what happens with an implemented operation, make the API fail using SOAP UI. Follow steps in the following example here to create a request in SOAP UI using order t-shirt. Operation for a customer named John. Because the API cannot handle this operation, SOAP fault occurs. In the SOAP UI, create a new SOAP project and put the URL for your deployed Mule APIkit project in the initial WSDL file. In this example, as an example URL, http :/localhost :8081 / t-shirt service / t-shirt service port $WSDL. In the SOAP UI, request a large t-shirt for John by entering some values into the request envelope. Select projects, then t-shirt service port $WSDL, then t-shirt service SOAP binding in order shirt, then request one, then enter L between size tags, enter John between name tags. Submit the request. The result is the SOAP fault here. As an error example, you can consider this one. This code snippet, in APIkit 4.0 replaces the exception strategy and error mapping with the Mule runtime 4.0 error handler. This error handler uses error types as shown in this snippet here. Each error response is generated using data view. Here you can see APIkit bad underscore request type. The status code is 400 and the message is bad request here. Now we are considering Anypoint API Manager. Anypoint API Manager is a component of Anypoint platform that enables you to manage, govern, and secure APIs. It leverages the runtime capabilities of API Gateway and Anypoint Service Mesh, both of which enforces policies, collect and track analysis data, manage proxies, provide encryption and authentication, and manage applications. Here you can see what API Manager looks like. To access API Manager, log into Anypoint platform and select API Manager from the main menu. Here in one you can see the environment selector. Anypoint platform enables you to create and manage separate deployment environments for APIs and applications. API Manager displays all environments except design environments. Number 2, navigation menu. In API groups, an API group is an API asset that enables the organizations to publish a group of API instances as a single unit. Automated policies. Policy automation enables security architects and administrators to secure and govern every API running in an environment. Client applications. Applications are external services that consumes APIs. Custom policies. Custom policies are policies that anyone can develop and apply to their APIs with the intention of extending existing functionality or defining new functionality. Data graph administration. Anypoint data graph enables you to unify all the data within your application network in a unified schema. Analytics. API analytics provide insight how your APIs are being used and how they are performing. Number 3, API the add API button enables you to add a new API instance to promote an API from any environment to the current environment. Or to import a configuration zip file that was exported from API Manager. In 4, the environment information button, available only to administrator users, enable administrators to display a dialog with information about the current environment, such as environment credentials. Use environment credentials to provision the Anypoint service mesh adapter or to configure Studio to sync with your environment. Number 5, search. Search enables you to search for managed APIs using API search field. Searches are case insensitive. Filter search results by selecting active. Number 6, the tracking the registration status of each API, active, inactive, or unregistered. The status of unregistered means that Anypoint platform has never tracked the endpoint for this API version. Either you have entered a URL for an API or proxy that hasn't yet communicated with the platform, or you have declared an endpoint that is hosted somewhere other than an API gateway, or need to proxy that endpoint so that the platform can track it. The endpoint must have a tracking registration status of active for governance policies and SLA tiers to function. SLA tiers to function. 7, the name of each API. Clicking the API names navigate you to the API settings view, where you manage the following alerts, contracts, policies, SLA tiers. 8 percentage of API requests that resulted in errors. If no data is displayed, automatic monitoring has not been enabled for the API. 9 the total number of API requests in the past 24 hours. If no data is displayed, automatic monitoring has not been enabled for the API. Number 10, the number of contracted client applications for each API. Here you can see API Administrator Sandbox and Sandbox API Administration, API Groups, automated policies, client applications, custom policies, data graph administration, analytics. In the here you can see the status, API name, label, version, instance, error rate, total request, client application, and creation date. Here you can see API gateway capabilities. The runtime, the Mule runtime includes an embedded API gateway. Using this gateway, any user can, for example, apply a basic authentication policy on top of a Mule application, enrich an incoming and outgoing messages, or add any other complex capability to an API without having to write any code. Overall API gateway allows you to add a dedicated orchestration layer here on top of your backend APIs and services to help you separate orchestration from implementation concerns. You can leverage the governance capabilities of API Manager to apply, among other capabilities, throttling, security, caching, and logging to your APIs. Here you can see API Manager is connected to Anypoint Runtime Manager agent. Governance enforce is passed from API Manager to Anypoint Runtime Manager agent. In Mule Runtime Engine, you can see the API gateway is there and backend APIs here, and you can see here orchestration layer and implementation layer. Clients are connected through API gateway here. Actually, clients interacts with API gateway, and API gateway interacts with backend API, and endpoint is interact between clients and API gateway here. Here you can see Anypoint service mesh architecture. Anypoint service mesh enables you to extend your microservices network by including your non-MuleSoft applications into the platform. Platform is spare. You can then manage and secure your application network, including your non-Mule applications seamlessly from a single pane. Your non-MuleSoft microservices might be written using different languages and platforms, or might be deployed in different environments to alleviate issues arising from different differences in these microservices, Anypoint Service Mesh ensures the following application management advantages. Provides resilient service-to-service communication using zero trust policies to handle traffic control, fault tolerance, and load balancing. Extends MuleSoft API management capabilities to any non-Mule service with policies, security, and analytics all applied directly from Anypoint platform. Amplifies reuse of services with discovery of non-Mule services within Exchange available for use in future projects. Here, Anypoint Service Mesh architecture. Anypoint Service Mesh architecture. Anypoint Service Mesh is an independent architecture layer encapsulated in Kubernetes or Red Hat OpenShift cluster. In the Anypoint Service Mesh architecture, instead of services directly communicating with one another, a sidecar proxy is used to perform the same job. The sidecar proxy enables you to bring your existing non-Mule microservices from the Kubernetes cluster as API into Anypoint platform. You can manage these APIs within API Designer, API Manager, and Exchange. Additionally, you can monitor the health of your APIs using API Analytics. Because of the mixer component is deprecated in Istio version 1.5 and later, the authorization mechanism aspect of the mixer is now implemented by leveraging Anypoint Service Mesh envoy filters. With the envoy filter, requests are sent directly to the adapter, thereby minimizing additional processing. As illustrated in this diagram, at the top of the architecture is Anypoint platform, which brings complete lifecycle API management capabilities to the microservices built with Mule runtime engine. Mule. These Mule instances might be deployed within Cloud Hub or Runtime Fabric at your location. Istio, which is installed on a Kubernetes cluster, uses Envoy to manage services by using a sidecar proxy. The sidecar is responsible for any communication with your service and resides within the same container as that service. With Anypoint Service Mesh enabled, you can continue to use Istio's native policies for traffic control and security. The MuleSoft adapter connects components to Anypoint platform. Along with the broker, the adapter enables all services that are managed by the mesh to share metadata, which in turn enables your existing microservices in the Kubernetes cluster to be recognized as APIs by Anypoint platform. After services are discovered, Anypoint Exchange uses the metadata to automatically discover and create APIs, HTTP, REST, or SOAP for each service. These APIs can then be managed within API Manager. Similarly, Anypoint monitoring uses the metadata to get information from the sidecar proxy and makes it available for API Analytics. Here you can see Mule applications. Under that you can see Cloud Hub and Runtime Fabric. You can see Mule apps are in Cloud Hub and Mule apps are in Runtime Fabric. And these applications, Mule applications connected to Anypoint platform. And here you can see Kubernetes cluster or Red Hat OpenShift. You can see here Istio under that. And under Istio you can see Mule adapter. And here you can see service A is connected to sidecar proxy, and service B is connected to sidecar proxy, and sidecar proxies are interacting each other. And Kubernetes cluster or Red Hat OpenShift is connected to Anypoint platform. API-led connectivity for microservices. You can see discover, manage, and secure inside API platform. And external and internal and external APIs are APIs are on top of Anypoint platform here. This is related. We can consider this as an example. Add a new API, adding an API instance. After you have created an API using Design Center or any other application, you can then manage that API in API Manager by adding an API instance. There are 3 options for adding API instance. Add a new API, like here. Select this option to add a complete new instance of an API, or promote API from environment, and import API from a zip file. Here we are considering add a new API. Step 1, log onto Anypoint platform. Step 2, in the navigation bar or the Anypoint platform page, click API Manager. Step 3, click Add API and select Add New API. Step 4, select and configure your runtime from the following options. API Flex Gateway. Select Flex Gateway for any APIs that need a flexible, performant API gateway that will work with distributed and microservices environment and fit into your CI/CD environment. Choose the connected Flex Gateway you have installed and registered from the list under the Select Gateway. Note, if you do not see a Flex Gateway listed, or you see a Flex Gateway but its status is disconnected, go for documentation related to install Flex Gateway or register and run in connected mode for more information. Mule Gateway. Select the Mule Gateway if you have an API on Mule runtime that need an API gateway to manage, observe, and secure your APIs. Select proxy type from the following options. Connect to existing application basic endpoint. Use this option directly interact with your Mule runtime engine Mule application where your application is configured with API gateway auto discovery. Select the Mule version. Next point, deploy a proxy application. Use this option to interact by proxy with an application, either because it is Mule application not configured with API gateway auto discovery, or because it is not a Mule application. Here select target type from the following options. Cloud Hub. Select Cloud Hub if you want to use the Mule runtime hosted on the cloud by MuleSoft. The Cloud Hub proxy includes a CPU with 0.1 vCores and a memory of 500 MB by default. Select the runtime version. Enter a proxy app name. Option 2 is next option, hybrid. Select hybrid if you have a Mule runtime running on an on-premises server that you want to use. Note, if you are running an API with self-managed server. Use classic API creation flows to manage your API. Select target from the list or click add server. Enter a proxy app name. Service mesh. Select service mesh to extend Anypoint platform API management capabilities to your Istio service mesh through the endpoint of a Mule adapter. Note, after adding the API on Anypoint platform, you will need to bind it to a service using the Anypoint service mesh client. Click next. Select an API from the following two options. Click select API from Exchange if you have an API shared with you through Exchange that you want to manage. Step 1, click the API from the list under select API. You can search for a specific API if needed. Step 2, update asset type, API version and asset version if needed. Point 2, next point, click create new API. Enter a name for step 1. Enter a name for the new API asset. Step 2, select the asset type from the following option. REST API. Select REST API if you have an RAML or OAS API definition file you want to include for your asset. Upload either RAML or OAS file for your REST API. HTTP API. Select HTTP API if you do not have an API definition file you want to include your asset. SOAP API. Select SOAP API if you have a WSDL API definition file or an external link to the file. Upload the WSDL file for your SOAP API or add the link to the file. This option is not available for Flex Gateway runtime at this time. Step 3, optionally you can add an asset ID and customize the version or API version details by clicking advanced. Step 7, click next. Step 8, configure the endpoint and other settings. Enter the implementation URI for this API. The implementation URI is the URL to access the proxy or the API. For example, you can use the URL of your API asset in Exchange. This is the only required field. Next point, update the other fields if needed. Step 9, click next. Step 10, review your selections. You can edit search section if necessary. Step 11, if you are ready to deploy, click save and deploy. Otherwise, you can select save to save the API instance and deploy it at a later time. With related to configure an API instance on Flex Gateway options, we can consider the field name implementation URI. The URL to access for the proxy or the API, it must end with a forward slash. This is a required one, and notes, for example, you can use the URL of your API asset in Exchange. As an error example, we can consider this one. Entitlement required. Account is not entitled to use API Manager. Contact your organization administrator for more details. Now we are focusing on APIhub or API portal. API portals are bridges between API providers and API consumers that provide information about the API at every stage of an API's lifecycle. API portals allows providers to expose and publicize their APIs, educate developer communities about them, provision user access, generate client keys, and more. For API consumers, API portals are the place to register applications, reset credentials, share and interact with API documentation, provide feedback about the quality of the API, and report bugs. Here you can see the 3 API lifecycle stages. Basically, what is full lifecycle API management? As API adoption increases, their usage continues to spread across all areas of the business, but APIs alone are not enough to meet the rising integration challenges of today's digital world. Organizations must give their API programs first-class treatment with the full lifecycle API management solution, enabling developers with an API management solution across full lifecycle of that API provides them with the flexibility and adaptability necessary to integrate application systems and data in an evolving environment. Full API lifecycle management is the process of overseeing an API from its creation to retirement across its full lifespan. This includes everything from designing, publishing, documenting, securing and analyzing APIs. An effective API strategy must include an API management solution that makes APIs easily discoverable and reusable and ensures that they are properly governed and secured. At the core of the API management is the need to survive the full lifecycle of an API and enable the associated ecosystem. An API first approach emphasizes the importance of the entire lifecycle by strategically treating APIs as a product and managing them as such. The outcome of this approach is well-designed, managed, and secured API to serve developers building new experiences. Below are the 3 distinct stages of this product-centric life cycle: design, implementation, and management. Design. The first step in the API lifecycle is design. When the API is created, the designing an API start with the outside in the perspective, beginning with the interface contract of the API. API developers create the user interface of API first, determining how the API looks and behaves. This is also known as the API contract. This approach is typically referred to as design first approach and should follow a deliberate API design lifecycle to optimize for the best experience. The step must be done in a human readable fashion. To specify the contract in a way that developers can easily digest. Within this step, developers perform these tasks: design, identify the process and business requirement, create logical data model, translate into logical service API groupings, simulate, model API resources, model API operations methods, model request response payload codes, feedback, mock up the API, publish interactive console, create notebook use cases, receive developer feedback, invalidate, modify API design as appropriate based on the developer feedback. Continue to validate. Any well-designed API will repeatability across other APIs. This can easily be encapsulated into best practice patterns both at the structural level of the API, nouns, resources, as well as at the method level, verbs. So as API developers go about the design process, it is important that they can discover and share repeatable patterns. Implement. The API implementation is a crucial piece of enabling next generation enterprise, enabling the continuity of hundreds or thousands of APIs to a backend as well as to each other key. This must be done in a systematic manner as opposed to point-to-point code. The two steps that go into the implementation stage are building and testing. A systematic approach to building ensures that the API developer has the following architectural patterns easily available to them: orchestration, transformation, routing, data mapping, and connectivity across systems. Once the API is built, it will go through rounds of API testing to ensure that it is functioning as expected. If the testing is completed with no problems, you can move on to the next lifecycle stage. But most often the API will go through several rounds of testing and adjusting before moving on to deployment. Test automation tools are critical here, as this integrates onto the DevOps processes of continuous delivery and deployment. Management. It is critical to ensure your application building blocks are following the best practices in security and architectural governance by applying policies to them at runtime. Monitoring all traffic via an API manager is equally critical because it just takes just one weak link to bring the ship down. Within this lifecycle stage are the following steps: secure, deploy, monitor, troubleshoot, and manage. Additionally, these APIs need to be discoverable to be reused for other purposes. The ability to appropriately publish them so the consuming developer can find, research, and understand them easily could make or break your entire program. So here you can see steps. The first step is design. Under that you can see this task: design, simulate, feedback, validate, and let's go to the API specification. It is connected to the API specification. Then the next step is implementation. Here you can see two steps: build, and then build is connected to test here, and test is connected to service with API. And here you can see next step, management. Secure is connected to deploy, and deploy is connected to monitor, and monitor is connected to troubleshoot, and troubleshoot is connected to manage, and go to likewise. Here you can see meet Anypoint. You can see the Anypoint exchange here. Anypoint exchange is the global repository for all technical assets in an API or Mule application's lifecycle. It is a central hub for saving, discovering, and collaborating on reusable assets such as APIs, connectors, examples, and templates. Users can discover and use proven assets by the MuleSoft ecosystem or curate private tenant of Exchange with organization-specific assets for internal collaboration and learning. As new APIs are created, Exchange automatically generates documentation and maps API dependencies like fragments, connections, and policies. Anypoint platform supports both API, Open API specification (OAS) and RESTful API modeling language (RAML), making API development language agnostic. API providers can also create registration structure that allows the provider to track who is accessing their APIs. After searching for an API or integration asset, the natural next progression is to test portions of API before implementing it in the project. Exchange portal have API notebook snippets embedded within the portal, as well as mocking service integrated directly with Exchange to make testing easy. This allows the user share and test functionality of the API with both internal and external users without implementation, and most importantly without disrupting existing integrations. Once an API portal is ready to share with relevant stakeholders, you can customize your portal to fit your brand. You can change the banner image, color, favicon, and more, so that it provides a seamless transition from your web properties. As a central repository for all technical assets, Exchange also keeps track of APIs as they are updated. It is a great place to host information surround the deprecation policy, what circumstances may cause an API to retire, and how to migrate to a new version of an API. In the event that APIs are deprecated, any Exchange setups a banner to notify users about deprecation of a specific API version and emails all existing consumers of the API to notify them as well. As an example, we can consider to access an organization's public portal. Step 1, navigate to Exchange, then public portal. Step 2, from the developer portal page, select the asset that you want to access. As an example 2, we can consider to publish an API on the portal. Step 1, in Anypoint platform, click API Manager, then in API Administration, click an API version of an API. Step 2, on the API version details page, under API portal, select Create New Portal from the drop-down menu. In step 3, on the home page for the portal, edit the text using Markdown. Step 4, click one of the grayed out icons in the center of the canvas to enter text, upload a graphic, or upload the file. For example, click the text icon and enter information about the API that you want to communicate to the portal visitors. Step 5, click the graphics icon to enter a t-shirt graphics. Step 6, use the add drop down in the left pane to add widgets and pages to the site. For example, add an external link, add the navbar heading, click set to visible, add an API reference, API console, setting this page to visible as well. Step 7, click private, toggling the public private control to make the portal public. Step 8, click live portal to see the published portal. Here you can see step 8, click live portal to see the published portal. Here you can see here t-shirt ordering service 1.0 development. Now we are considering limitations in API Experience Hub overview. This release has the following limitations. API Experience Hub does not use the platform cache. API Experience Hub functions at the main organization's level only. You cannot connect the Salesforce organization to more than one Anypoint organization. An API portal can have maximum of 250 APIs. Do not make changes to the permissions of the out-of-box teams created in access management for API Experience Hub. Each assist added to the API portal uses 2 permissions, and access management has a limit of 1000 permissions per team. API groups are not available. API Experience Hub is not certified for use on the mobile devices. Some functionality works on mobile devices, but some functionality such as API console does not work. IP restrictions are not supported. For more information, see the troubleshoot section in the documentation. Validation rules cannot be applied to the standard objects that are created during the Salesforce linking process. For more information, to see the troubleshoot section for the workaround in documentation. From the API console, API cannot be tested using the authorized credentials from the request panel. From API console, sync API and SOAP specifications cannot be downloaded. The current release, we are considering the released as of December 2023. Here we are considering a release notes in 1.3.0 in September 2023 in API Hub experience in Hub release notes in API Experience Hub. Here, what's new in this version? The API details page now shows the content of instances and the link to the instances screen, where you can view the name and the URL and a copy of URL if available. Now we are considering administrators in getting started in API Experience Hub. Following users can get started with these links: administrators and developers. Here we are considering administrators. Administrator can create API portals in these easy steps. One, assign administrator permission, set up the necessary permission for the administrators to connect to the Salesforce and create a portal. Connect to the Salesforce. The instance can be a new or existing Salesforce organization. To connect, specify the environment type and enter the custom Salesforce domain. If you have one, log in and allow permission and confirm the account. Style your portal. Once you have connected, once you are connected to Salesforce, you can style the portals out of box pages with logos, fonts, color schemes, and more. Manage your portal. Manage APIs by adding APIs from Exchange and setting the visibility for the API versions. Manage your users by approving access requests from your users. Preview and publish your portal. Publish the portal to make it available to your community. Now we are considering grant the API Experience Hub administrator permission in assigning administrator permission in API Experience Hub. The organization administration and API Experience Hub administrator can perform all of the functions to create the portal. Only organization administrator or existing API Experience Hub administrator can grant a user the API Experience Hub administrator permission. Grant this permission when you want to another user in your organization to perform Salesforce linking process, create and curate the portal, manage the portal, and manage users. To grant the API Experience Hub administrator permission to the user, one log on to the Anypoint platform using the account with the organization administrator permissions. Click Access Management, click Users, click the username of the user that you want to add the API Experience Hub administrator permission. Select the permission and click Add Permission. From the select permissions to add for this user search box and enter API Experience Hub admin and select the checkbox. Then click the blue plus icon. Now we are considering connect to Salesforce. Connecting to Salesforce in API Experience. The process of creating API portals include connecting with Salesforce Experience Cloud to link your Anypoint platform organization to your Salesforce organization, then installing the Salesforce Experience Hub Experience Cloud package. The linking process is one-time step when creating your portal. Not only an organization administrator or API Experience Hub administrator can link the organizations. Follow these steps to link your API portal. Navigate to the Anypoint platform, enter username and password, and then click sign in. From Anypoint platform, select API Experience Hub from the list of products. From the connect to Salesforce Experience Cloud dialog, select the option for the environmental list, production, sandbox. If you do not know which Salesforce in organization environment type you have, connect to the Salesforce and contact your Salesforce administrator. If you have a custom Salesforce domain, select I have a custom Salesforce domain and enter your domain address. If you don't use a custom domain and you have Salesforce sessions in the selected environment, logging in the Salesforce using the first active session, click connect. Confirm the Salesforce access information and click continue. Click allow for MuleSoft to access your data and click connect. Click continue. This process of installing the Salesforce Experience Cloud package begins. Then when the package is installed successfully, you receive an email. Now we are considering style API portal homepage in styling and creating your API portal in API Experience Hub. Follow the guided steps to style homepage. To add the company logo, drag or upload an image file to upload company logo. The supported file formats is PNG, JPG, SVG, and GIF. If to add a banner image, drag or upload on image file to select the banner image. The supported file format is PNG, JPG, SVG, and GIF. To brand your org with fonts colors from customize org branding, select font style from the drop down menu. Select font color for the banner image for the color picker. Select page background color from the color picker. To add the title to your portal banner, enter the title in the enterprise title in the enter product banner title text box. To add the description for your API portal, enter the description in the enter portal description text box. To add the footer text and an URL, enter your footer text and URL in the corresponding text boxes from the configured footer. Click next to style and the API catalog. Now we are considering add APIs from the Exchange, managing APIs in managing your portal in API Experience Hub. Curate your portal in API Experience Hub by adding API from Exchange. When adding APIs to the portal, default visibility is administrator only. You can change the visibility to include members or everyone. To add APIs to your portal, from the API management page, select APIs in Exchange Hub. To search for an API by name or description, enter the name or description into the search bar. 3. Select an API from the list. Click the more options icon and select add to portal. The API displays in the first list in the API in the portal tab. Now we are considering add and remove portal components using the builder for common customizations in customizing your portal using Experience Builder in API Experience Hub. From the builder, add or remove API Experience Hub component from your portal. Navigate to your builder, click the component icon, scroll to custom components, click a component, for example API console, or drag it into the portal. To remove the component, click the trash icon. Now we are considering previewing and publishing your portal in API Experience Hub. When you are done managing and curating your portal, you can preview your changes in the builder, then publish it to your users. The URL for portal is not accessible until the portal is published. When you publish your site at the first time, the portal URL is live and logging access is enabled. To preview and publish the portal, follow these steps. If you are on the manage your API portal page, click preview and publish your portal. Review your changes, then click publish. Now we are considering registering for access to portal in discovering and consuming APIs in API Experience Hub. Users who access an API portal without logging, it cannot perform most actions in the portal, like requesting access to APIs to use them. Becoming a member gives you access to more APIs and functionality. Anyone can sign up for an account to become a member. After signing up, API Experience Hub send a welcome email that contains a link to set up the account and password. To register for an account, in the browser window, enter the URL of the portal, click login, click not a member, enter your first name, last name and email address, click sign up, follow the instruction in the welcome email to set up your account. Now we are considering cannot see images in the builder preview that were uploaded when creating the portal in troubleshooting in API Experience Hub. In the builder preview, you cannot see the images that were uploaded when creating the portal because the shared for user is not a member of any libraries. To add the shared user as a member of the asset library, log into the Salesforce organization as a system administrator. Click the app launcher, enter files in the search and select files. Click libraries in the navigation pane. Click asset library in the list. Click manage members to manage library members. The manage library members screen opens. In the add members field, click down the arrow next to the stack icon and select people, and the add members field shows the search people box. Click in the people box and select builder preview. In the access field, select author. Click add to allow the builder preview user to upload images in the builder for later use. Current members section shows the builder preview members and author access. Close the screen, confirm that the builder preview user can see the library images in the builder. Reload the page if the images are not showing up. As an error example, we can consider this. Request access for an API group through public portal is showing resource not found pop-up. The resource you are trying to access could not be located. It was probably removed by someone else. If you think this is a mistake, contact your administrator. There's a request ID here. Now we are focusing on Mule Studio, Anypoint Integration Platform and Enterprise Manager. Mule Studio, Anypoint Integration Platform and Enterprise Manager. Now we are focusing on Mule Studio. Anypoint Studio is MuleSoft Eclipse-based integration development environment for designing and testing Mule applications. Here you can see the following quick reference explain the different views you use to build a Mule project. Here you can see the project explorer, view your project structure. Here you can see the canvas, drag and drop building blocks here to create a message flow. Here you can see palette, filter and select building blocks from here. Here you can see properties editor tab, configure attributes of the selected building blocks. Here you can see the console tab. This is the properties editor tab here. This is the console tab. Feedback about your app when deploying. So this is Mule Studio. Here you can see all API related use cases in single design environment. As API development becomes more common task for our users, we have been building support for capabilities capabilities in Anypoint platform. In Anypoint Studio 6.0 release, these capabilities have been unified to help users speed development and delivery of quality APIs by working with the context of API development lifecycle. Here you can see others, and here this under here API portal, API designer, API manager, runtime manager, and exchange is under others, and here design, register, deploy, consume, implement, and mock and test are under here the Anypoint Studio 6.0. Here API portal, here the API designer. Here the design embedded RAML editor, API designer Studio Sync 08 or 1.0 support interacts with API designer, and API designer is connected to API portal, and design is connected to implement out of the box APIkit, RAML or SOAP or data beta 2 flow auto generation. Here register to API manager through API auto discovery is connected to API designer. Here the mock here the implement is connected to mock and test, RAML to unit test, suite auto generation, embedded API console. Here the mock and test is connected to register. Register is connected to API manager. Here the register is connected to deploy, and here the deploy to runtime manager. Here the deploy is connected to runtime manager, and here the exchange is connected to consume. Consumption of REST API through HTTP plus RAML and SOAP API through WS. Here you can see synchronization between API designer and Anypoint Studio. To help the API design to implement journey, we have decided capabilities to Anypoint platform that provide a seamless path for round tripping between Anypoint Studio and Anypoint API designer. Our web-based solution for design a RESTful API with RAML. As an example, user can now import RAML files directly within the Anypoint Studio from Anypoint platform. You can also push and pull and compare the differences between local and the one on the API designer. With these additions, you no longer need to switch between two environments when iterating over API designs. Here you can see the pull, and here sync and refresh, and here push. And here you can see the compare files and versions. This is regarding this example regarding configuring Mule stack traces. Mule does not display all stack traces by default. When a Mule does show the stack traces, it filters out some internal class references from to produce a readable output. You can control Mule stack trace behavior in two ways. Use command line argument, set properties in Mule Studio. We are considering here set properties in Mule Studio. In Studio, you can set properties to specify to instruct Mule to provide the stack traces and filter out packages or classes to remove. To adjust these settings, Step 1, select run, then run configurations. Then step 2, define the properties to specify the behavior you want. In this example here, you can see the mule.verbose.exceptions property is set to true. As an example 2, we can consider test your API specification using API console. Studio provides an API console view and a mocking service for the API you are designing. While the mocking service is enabled, the API console view returns the HTTP code status and example payloads that you defined in your API specification. Simulating calls to your API is critical design tasks that help you troubleshoot problems and demo APIs to prospective users even before you implement it. You can simulate calls to API in the API console view before publishing a new version of API specification to Exchange. Studio mocking service does not modify the base URI field in your API specification when it is enabled. There are prerequisites before these steps. You must have API specification project created. Your API specification project must be synchronized with Design Center. You must turn on mocking service. In your package explorer view, right click your API specification project and select API specification, then turn on mocking service. So these are the steps to test your API specification using API console. Locate your API console view within the API design perspective. The API console view displays the summary of your API specification, all the available endpoints and their allowed HTTP methods, a list of all types defined in your API specification. Step 2, navigate through the endpoint section, click the HTTP method that you want to test and click try it to simulate calls to an API. Your expanded API console view shows the mocking service to the right of the console. Request URL is populated with your selected API endpoint. The request URL field is populated with your selected API endpoint. Use query parameters if you need to add specific parameters to your request. Step 3, click send to send your test request. Now we are considering enhance experience you importing API specifications in what is new in Studio. When importing API specification of fragments from Design Center, Studio provides more information, including types of asset and date the asset was last updated. Now we are considering editors in Anypoint Studio. Studio editors help you to design and edit definitions of your applications, APIs, properties and configuration files. Mule configuration files, API specification, properties files, a pom.xml file to handle dependencies. Now we are considering what's new in May 4, 2023 Anypoint Studio 7.15.0 release notes. Improved performance for customers on Windows by enabling the inclusion of Studio from Windows Defender scans. Enhanced experience when importing API specification of fragments from Design Center. Easy deployment and redeployment of Mule app to CloudHub 2.0. Native support for Apple M1 and M2 processors. More and clearer details in the log if the pom.xml file contains an error. Upgraded .git ignore to show the .mule folder is ignored in the Studio UI. Now we are considering exclude Studio from Windows Defender scans in download and install Anypoint Studio. While Windows Defender is a tool for keeping your computer safe, it can slow down the performance of Studio because it scans the files in real time as they accessed, which causes delays. To prevent performance issues, you can completely exclude Studio from Windows Defender real-time protection. First, run Studio. Windows Defender real-time protection notice asks whether to exclude the Studio folder and processes. Here you can see your performance could be affected by Windows Defender real-time scanning. Do you want to exclude the following items? Optionally select remember my decision checkbox, and here the .p2 folder stores the Studio plugins. The second folder shows the path of the workspace that you select when when launching the Studio. The third folder points to the Anypoint Studio application location. Optionally select the remember my decision checkbox. Click yes. Click yes again when Windows PowerShell request permission to make the change. Note, if you select remember my decision checkbox and click no, Windows Defender Real Protection scans Studio folder and processes as you work with them. Now we are considering Mule Maven plugin update for workspace created with Studio 7.1.x and earlier versions in update workspace. Studio simplifies the configuration of the Mule dash artifact .json file. When packaging your Mule application, this file is used to identify the application class loader configuration and settings, and the minimum required Mule runtime engine version required to run your application. This is class loader descriptions here, and Mule runtime engine version required to run your application. Minimum required Mule runtime engine. Studio includes the new version of the Mule Maven plugin that can automatically infer some of the required metadata. This makes it easier for you to keep track of the declarations you need to make when exporting sources. Here you can see mule-artifact.json in 7.1.x, and here you can see the mule-artifact.json in 7.12. This simplification reduces the number of declarations you need to monitor during deployment. A fully configured mule-artifact.json file is still required by Mule runtime when executing the package application. You can find the generated mule-artifact.json file inside the target directory after packaging. The plugin inspects the metadata declared in mule-artifact.json. If value is not declared, the plugin inferred it from the application code before packaging. Any other metadata is declared, the plugin uses it to package the application. If you update the latest plugin but choose to keep your former descriptor files, you must manually monitor the descriptor metadata. When you update the workspace created using Studio 7.1.x and earlier, Studio overwrites your existing mule-artifact.json file. If you have other declaration in mule.artifact.json that you want to preserve, for example, secure properties, or redeployment enabled, you should back up those files outside your workspace, perform the migration, and then restore your old mule-artifact.json file. Do not perceive the following declarations. Configs, name, required product, class loader, mod loader descriptor, bundle descriptor loader. Export your studio configurations in export and import studio preferences. In studio, go to preferences. Ensure that you applied all configurations you want to export. Then select the export icon. To configure the preferences that you want to export, here the select export all to export all of your preferences, and select the specific configuration that you want to export. Define the location and name for your exported preferences. And select finish. Now we are considering installing a different Mule version in install Mule runtime engine in Studio. In the top menu bar, select help, then select install new software. The select Mule runtime for Anypoint Studio. https://studio.mulesoft.org/studio-s3/studio-runtimes/ here select the Mule version you want to install and select next. Accept the terms and condition and click next. Click finish. Restart Studio after installation is completed. After installing the Mule version, you can proceed to update your project to use that version. Now we are considering import an API specification from Exchange in import API specifications. Here the import an API specification from Exchange into a new project. In the project taskbar, at the top of the Anypoint Studio display, select file, then new, then Mule project. Type a name for your project, then select a Mule runtime engine version 4.1.4 or later. In the API specification section, select from Exchange or Maven tab. Click the add icon 2% and select from Exchange. Select your Anypoint platform username. If you are not logged in, you can click the add account button to add your Anypoint platform account. From the list of available APIs, select one or more and click the add button. You can type a asterisk character in the search bar and press enter to list your available APIs. To select the version of the API that you want to import, use selected modules table. Click finish. Now we are considering API specification as API specification projects in Studio, in API development in Studio. You can start an API specification project in Studio and synchronize it with the design center. Studio uses version control system VCS capabilities to keep your API specification synchronized between your Studio Workspace and Design Center. You can also import an API specification from Design Center as API specification project with VCS enabled capabilities to edit your API specification using Studio and synchronize your changes with Design Center. Design your API specification in Design Center. You can either create and publish API specification with the visual editor or with the code editor. Import the API specification from Design Center into Studio. You can import the API specification as an editable asset by synchronizing an API specification with Design Center. Now we are considering create an API. Now we are considering create branches in create an API specification project in Studio. Using different branches enable you to use a modified API definition in certain cases without modifying the main branch in the Design Center. To create a different branch in the Studio, in the Package Explorer view, right click your API specification project and select team, then switch to the new branch. So with the right click your API specification project and then select team, then switch to new branch. To create the branch window, configure your new branch. Here the in the branch name field, type the name of your new branch. You can select the configure upstream for push and pull option if you want to also pull changes from a Design Center into a local branch. When configuring this option, you must select the behavior you want Git to have when it pulls changes from your Design Center. Select check out new branch for Git to switch to this new branch as soon as you create it. Click select finish. With the newly created branch, you can start committing your changes. Now we are considering steps in using API console in test your API specification. Locate your API console within the API design perspective. The API console view displays summary of your API specification, all available endpoint and their allowed HTTP methods, and list of types defined in your API specification. To navigate through the endpoint section and click HTTP method that you want to test and click try to simulate the calls to an API. Your expand API console view shows the mocking service to the right of the console. Request URL is populated with your selected API endpoint. Request URL is populated with your selected API endpoint. Use a query parameter if you need to add specific parameters to a request. 3. Click send to your test request. Now we are considering import an API specification from Design Center to edit locally. In synchronize API specification with Design Center in API sync. Ensure that no other project in your workspace has the same name as the API project you want to import. In the taskbar at the top of the Anypoint Studio display, select File, then Import. Select Anypoint Studio, then API specification from Design Center. For in the import from Design Center window, select your Anypoint platform, username and Anypoint platform business group where the API specification is located. If you are not logged in, click the add account. Button to add your Anypoint platform account. If you have not configured your Anypoint platform credentials, the username and the business group option are unavailable. If you want to use the different account, click the add account button and log into the login again. From the list of available APIs, select the one you want. then click finish. Studio imports the API specification as API specification of the project that you can work on your API specification project offline. Now we are considering import and exchange example into Studio in import Mule project from Exchange in import and export projects. Click the open Exchange button on top navigation bar. Import project Exchange C2FCE. In the Exchange window, select the MuleSoft organization from the left navigation bar. 3. Click the all types drop down menu and select examples, and select select the example you want to import, and in the examples page click open from the right menu. Now we are considering from Studio in add custom modules to your project in add modules to your project. To install local custom module from Studio, first in the top menu bar, select the manage dependencies icon, 2-point icon, and under project, under Mule project, select modules, select the green plus icon from Maven. In the properties window, from Maven here, in the properties window, configure your custom module modules Maven coordinates. This information is available in your modules pom.xml file. Now we are considering deploy to CloudHub. In deploy a Mule application to CloudHub, right click the project folder on your package explorer view, then select Anypoint platform and then deploy to CloudHub. If you don't have the Anypoint platform credentials configured in your Studio, you will need to provide your login information before continuing. 3. Configure your CloudHub instance to which your application is being deployed. Anypoint Studio uses package name as your name of your application on the CloudHub. This name is part of the domain your deployed application. For example, naming your application deployment-1 makes your application's public domain deployment-1.cloudhub.io. You can also configure the runtime version. By default, Studio uses application version you are using in a project using development. To reduce the compatibility risk, you should always deploy the runtime version in which your Mule application is created, though closest alternative. Additionally, you can configure the amount of worker and worker size for the CloudHub instance you are going to use, enable insight, static IPs, configure log levels and properties placeholders for your application. Now we are considering create Mule domains in design Mule applications in domain support. Go to file, then new, then Mule domain project. You can also right click on package explorer view and select new, then Mule domain project. Set the name for your project. This is also the artifact of your domain's POM file. When editing your Mule domain, all related applications in your class path get updated accordingly. Now we are considering search inside API specification dependencies in search inside in dependencies. When you import your API specifications from specifications from Maven from Exchange or Maven as dependencies of your project, those dependencies relocate from src/resources API / to a zip file in your project's class path. This change means that you cannot search your API dependencies by using the file search option in the Studio. To enable you to search to a specific text inside your API dependencies, Studio introduces the API search feature. You can access the API search menu from taskbar at the top of the Anypoint Studio display, either by selecting search, then search ... or by using the Control and H keys in your keyboard simultaneously. To search inside your API specification dependencies, type the text you want to search for, following these conventions. Use asterisk to search any chain of characters in your search criteria. For example, /*customers matches the both possible endpoints, /customers and /customer ID. Append a question mark to search any character after a specific pattern. For example, /customer matches /customer ID but not the /customers, because there must be a character between the search criteria that you define between question marks in literal. Here the what matches is the / open curly brace customer ID close curly brace. Use backward slash to escape any of the reserved characters used in the search patterns. For example, if you want to search for strings containing asterisk, question mark, or backward slash, you must escape them. Backward slash asterisk, backward slash question mark, and backward slash. If you want to specify specific name pattern for the files you want to search through, type the pattern in the file name patterns field following these conventions. Use asterisk to search any chain of characters in your search criteria. For example, asterisk.rml searches all the file names that end with the .rml extension. Use question marks to allow any character after a specific pattern. For example, customer $1.rml searches the inside the file such as customer 01 .rml, customer 11r.rml, customer 21.rml. Use exclamation to include certain file names and patterns. For example, exclamation marks examples.rml searches all sources inside the all files except example.rml. Click choose button to filter per file type. For select one of the following types of API specification in your project. API dependency searches inside the API specification imported from the Exchange or Maven. Local API files searches inside the specification added from your local file or from Anypoint Design Center. Click search. Now we are considering conditional breakpoints in Studio in breakpoints in Studio Debugger. A conditional breakpoint is conditional breakpoints activates when a predefined condition evaluates to true when Studio execute the event processor with the breakpoint. To define the condition using a data view expression, to add a conditional breakpoint, right click the message processor and select add breakpoint. To in the Mule breakpoints view, select the breakpoint to which you want to add the condition and select conditional at the bottom. Enter the condition that must be met for the breakpoint to be activated. For example, following expression evaluates the breakpoint if the method used in the request is get attributes dot method equal attribute dot method double equal get. For example, the following expression activate the breakpoint if the method used in the request is get here. You don't need to stop the application execution to change the condition. Now we are considering Data Science Explorer in Data Science. The Data Science Explorer is a feature in Studio that allows you to preview the message data structure at different points in the flow while still in the design time. Select the specified element in the flow and click the Data Science Explorer icon and explore the structure of the data that enters and leaves. The Data Science Explorer allows you to navigate the Mule event and the Mule message. It takes the known output field of flow elements and the data science metadata of compatible connectors into account to predict the Mule events content at any given point in the flow. You can easily find what information is available where even the variables that implicitly created by certain flow element which you might not be aware of. Now we are considering metadata tab in access the metadata editor in metadata editor. Select the component in your canvas to display its Mule properties view. Select the metadata tab on the component's Mule properties view. Click on the add metadata button to start defining the metadata for your payload attributes and variables. Select the Mule event components to which you want to define metadata and click on the edit icon access metadata editor to open the metadata editor. Now we are considering define data structure on other components in define input and output structure for transformation in create mapping via UI in workflow in transform message components. One, they make sure that all other elements in the flow are fully configured. When input and output of a component can be predicted based on its configuration, these are exposed to the rest of the flow. For example, when a Salesforce connector is configured to carry out a specific operation, its output structure is known and exposed. If input or output of a certain components can't be predicted, usually define the output and input key components via the metadata tab. For example, an HTTP listener might receive requests containing any payload. Now we are considering access the EU control plane from Anypoint Studio in Studio. Configure your Anypoint Studio implementation to point to the EU control plane to perform tasks there, such as deploying to Cloud Hub, importing asset from Exchange, or implementing an API definition from Design Center. Open the preferences view in the manner appropriate for your OS. In Mac OS, either navigate to Anypoint Studio, then preferences, or press CMD plus and comma. In the window, we see CMD and comma. In the window and Linux, navigate to window, then preferences. Expand the Anypoint Studio. In the left navigation bar, select Anypoint platform. Select EU from the region, the drop down menu, and then select apply and close. As a result, the Anypoint platform tools embedded in the EU Studio, Anypoint Studio display your Anypoint platform from EU control plane. Now we are considering configure your PC certificates in Studio in configure private cloud edition in Studio macOS in configure private cloud edition in Studio. Follow these steps to integrate your Studio Studio installation with the Anypoint platform components in the PC deployment. Extract your CA certificate using Open SSL here. This is bash and where the DSM name is the domain name of your PCE instance, and certificates name underscore name dot PEM is the name that you define for the file to which you exported your certificates. For example, here, and your .pem .pem certificate to your Studio embedded Java CSS key store. Here the CACERTS underscore path is your Anypoint Studio artifact. For example, Java 11 Anypoint Studio dot app /content /eclipse /plugin /org.mule.tooling.jdk.macOS x.x86 underscore 64 underscore 1 dot 1.5 /contents /home /lib /security /ca certs. In Java 8 Anypoint Studio.app /contents /eclipse /plugins /org.mule.tooling.jdk.v8 macOS x84 underscore 64 underscore 1.1.5 /content /ajari /lib /security /cat certs. Here the pass is your cat certs certificate key store password. Java default CSRts password is change it. 3 alias is the name your certificate gets when you have to have it in the key store. For example, my dash certificate. Certificates underscore name is the path to the .pm file generated and saved in the previous step. 3 add your cert to the to your Mac OS key store and set it as always trusted. Here the command is security. Here the command is there. Here the add your certificates to your Mac OS key store and set it as always trusted. Optionally, you can use the keychain access UI. On your computer, open your keychain access.app app. In the left navigation bar, select system, drop the .pm file that you generated in the previous task into the list of certificates and double click your imported .pm file. Then select always trust from the when using this certificate drop down menu. In the studio, open the preferences view, navigate to Anypoint Studio, then preferences, or press CMD and comma. 5 expand the Anypoint Studio in the left navigation bar and then select Anypoint platform. 6 select the use private cloud instance URL. Type the URL of your PCE's installation in the private cloud instance URL defined. Click apply and close. Restart Studio. Now we are considering adding Anypoint platform user account. configure access for external identity providers. In the top menu bar, navigate to the Anypoint, then Studio, then Preferences. Then select Anypoint Studio in the left navigation bar, then Authentication, then Add. Select Configure, then select External Identity, then enter your organization's domain name and select OK. Consult your organization administrator if you don't know the organization domain. Then select external identity provider you want to use, select OK, enter your username and password for your external identity provider and select sign in, select apply and close. Now we are considering customizing the location of your storage and password files in SQL storage overview. To change the location of the password and SQL storage files, locate your Anypoint Studio.ini file. In Windows, go to your Anypoint Studio installation directory. In macOS, go to your /application folder. I click on the Anypoint Studio package and then show package contents. And go to contents, then Eclipse, then open the Anypoint Studio.ini file. In Linux, go to /usr/lib/Anypoint Studio /Anypoint Studio.ini. Add in the following options to bypass the password provider mechanisms. One here, configure the location of the secure storage file, and here configure the location of the password file which Studio uses as the main password. Caution: you only decrypt your credentials when the same password file is used to encrypt them. Now we are considering configure proxy settings. Anypoint Studio allows you to configure proxy configuration for your computer is behind a proxy server there and needs for you to connect to the internet to download plugins and install updates. Anypoint Studio supports configuration for authenticated and unauthenticated proxies. Open the preferences view in the manner appropriate to your OS. In macOS, either navigate to Anypoint Studio, then preferences, or press CMD plus comma. In the Windows and Linux, navigate to Window, then Preferences. Under General, select Network Connections. Select your active provider. Direct causes Anypoint Studio to open connections without use the proxy server. Manual causes Anypoint Studio to to open connections using settings defined in the options. Native causes Anypoint Studio to open connection using settings discovered in the OS where you install the Anypoint Studio. Click edit when selecting the proxy entry for select each schema to configure its host and port number. If you are using authentication proxy, select requires authentication and complete the user and password fields. 5 if necessary, you can add bypass to your proxy. This is a list of hosts that you should not use any proxy. Click add host, then to add host names to your proxy bypass list. Keep in mind that when setting a manual provider, don't disable the default localhost and 127.0.0.1 bypasses. If you disable the bypass, the embedded Mule runtime with Studio within the Studio won't be able to reach your application. When applying the changes to your proxy settings, Anypoint Studio restart the Mule instance used to obtain metadata and test outbound connections. If this fails, manual restart to instance and to navigate to preferences, then tooling, and click restart instance. Now we are considering configure Studio browser settings. Anypoint Studio comes bundled with the default browser to display element of the Anypoint Studio Anypoint platform UI. For example, when you deploy the CloudHub from Studio, the runtime manager UI displayed in the Studio is rendered using a built-in browser. This built-in browser is default. However, if you log into Anypoint platform using multi-factor authentication (MFA), you must configure Studio to use any system navigate native browser to render the Anypoint platform UI. Navigate to preferences, then Anypoint Studio, then browser. Select the default browser for the navigate preferences, then Anypoint Studio, then browser, and select the type of the default browser for Studio. Built-in uses the built-in browser. Native uses the native browser for your operative system. Click preview to verify the change configuration. Additionally, if you use the Windows select now we are considering selected JRE version for a specific project. In select a different JRE to run the embedded Mule runtime engine. Right click on your studio project, navigate to the build path, then click configure build path. In the libraries tab, select your JRE your system library and click edit. Then select the alternative JRE option and select your desired JRE from the drop down menu. Now we are considering configure studio to access the MuleSoft government cloud region. To configure the studio to configure studio to connect to MuleSoft government cloud, open the preferences view in the manner appropriate to your OS. In Mac OS, either navigate to Anypoint Studio, then preferences, or press command CMD +1 comma. In the Windows and Linux, navigate to Windows, then preferences. Expand the Anypoint Studio. In the left navigation bar, then select Anypoint platform. Under the region settings, under the region settings, select GOV from the drop down menu. Select apply and close. Now we are considering access and update site in Anypoint Studio update sites. Navigate to help, then install new software. Then in the work with field, select one of the update sites. Now we are considering configure studio to use your own Maven. Anypoint Studio comes bundled with Maven, but you can use Studio with an external Maven installation as well. Open Studio, go to Studio Preferences. In macOS, go to Anypoint Studio, then Settings. In Windows, go to Anypoint Studio, then Preferences. In the Preferences panel, go to Anypoint Studio, then Maven. Deselect use embedded Maven installation. Click the browse next. Click the browse next to the Maven installation home directory field. Select your Maven root installation path and click open. Click test Maven configuration to verify your Maven configuration in Studio is correct. Click apply and close. Now we are considering configure XUL runner as Studio default layout engine in Windows. In troubleshoot issues with platform content in Windows. Download the XUL runner. We recommended the version 24.0. Unzip your package and install it. Go to your Anypoint Studio installation directory and open Anypoint Studio.ini file. Add the org.eclipse.sw.browser.xul runner path equal variable with the full path to your XUL runner binaries here. XUL runner binaries are located in the folder where you extracted the XUL runner package. Here now we are considering configure Studio to use your own JDK in Windows. In configure Studio to use your own JDK, locate your Anypoint Studio.ini file inside your Anypoint Studio installation directory. Add -vm option to the point you to your specific JDK installation path. The -vm option and the installation path must be on a separate lines. The value must be a full absolute path, absolute or relative path to the JDK executable, not just the Java home directory. the dash VM option must occur after the other studio dash specific options such as dash product dash dash launcher dot asterisk etc. But before the dash VM args option. If you encounter Java was started but return exit code equal 1 while starting Anypoint Studio, modify the dash VM argument to point to the jvm.dll. Now we are considering define input and output structure of a transformation Anypoint Studio in creating a mapping through Anypoint Studio in Studio UI in workflow in Mule overview. Make sure that all other elements in the flow are fully configured. When the input and output of the component can be predicted based on its configuration, these are exported to the rest of the flow. For example, when Salesforce Connect is configured to carry out a specific operation, its output structure is known and exposed. If the input or output certain components can't be predicted, manually define the output and the input key component via the metadata tab. For example, HTTP listener might receive a request containing any payload. Now we are considering exclude XML files from MUnit coverage report. You can exclude one or more XML files from the MUnit coverage report when testing your application. For example, you can exclude third-party XML file that does not comply with quality standard to improve your final report score. Go to the flow to change. Click run and run, then run configuration. Click the name of your project. In the ignored file section, click add. Type the name of the XML file to exclude from coverage report and click OK. Then apply and run. Now we are considering add the module to your Mule project. Add the module to a new Mule project in using Anypoint Studio to configure tracing module 1.0. Add tracing module to a Mule project to automatically populate the XML code with the module's namespace and schema location to add the required dependencies to the Mule's project's pom.xml file. In the Mule palette view, click X search in Exchange. In the add dependency to the project window, type tracing in the search field. Click tracing module in the available modules. Click add and click finished. Now we are considering activate remote debugging in debugging outside Studio in Mule runtime. You can start Mule with dash debugging option to activate remote debugging as shown in this here the Linux example. With this option, the Mule start normally and logs the following message in the console. Listening for transport DT_socket at address 5005. Mule is normally remotely debugging on port 5005. Follow the step to debug Mule. Access Eclipse and then select the run then debug configurations menus. From there, create a remote Java application configuration that uses port 5005. Add the source code for your Mule local instance as the external archive on the second tab of the configuration panel and click the debug button at the lower right corner of the configuration screen. Local Mule instance resumes at its startup sequence and you can debug the app step by step. Now we are considering configure a source in using Anypoint Studio to configure aggregators Mule module 1.1 -Mule 4. The source initiates this flow when a specified condition is met. You can configure one of these sources to use the aggregated module. HTTP then listener initiates the flow each time it receives request on the configured host and port. Aggregator listener initiate the subflow by listening to element triggered by the reference aggregator scope. After aggregator scope is referenced by the listener, complete an aggregation, and aggregator listener triggered the subflow with the list of all aggregator elements. For example, to configure the aggregator listener, follow the steps. In the Mule palette view, select aggregators, then aggregator listener. Drag the aggregator listener to the studio canvas. On the aggregator listener configuration screen, optionally change the value of the display name field. Set the aggregator name to the name of the aggregator scope to listen to. Listener executes after the aggregator scope releases its elements. Select the include timeout groups to indicate whether the listener should be triggered when the group is released due to the timeout. This configuration option also works for non-group aggregators such as time-based aggregator and size-based aggregator scopes. Now we are considering configure a source in using Anypoint Studio to configure compression module 2.2 in Mule 4. The source initiate the flow when the specified condition is met. You can configure the one of these sources to use the compression module. HTTP listener initiate the flow each time it receives the request in the configured host and port. Scheduler initiate the flow when the time-based condition is met. For example, to configure the HTTP listener source, follow the steps. In Mule palette, select HTTP then listener. Drag the listener to the studio canvas. On the listener configuration screen, optionally change the value of the display name field. Specify the value for the path field. Click the plus sign next to the connector configuration field to configure the global element that can be used by all instances in HTTP listener source in the app. On the general tab, specify the connection information for the connector. On the TLS tab, optionally specify the TLS connection for the information for the connector. On the advanced tab, optionally specify the connection information including the reconnection strategy. Click the test connection to confirm the Mule can connect with the specified server and click OK. Now we are considering configure an input source in Anypoint Studio using Anypoint Studio to configure WSS module Mule 4. An input source create a flow when the specified condition is met. You can configure the one of these input sources to use WSS module. Greater than sign, less than sign asterisk connector specific input source greater than sign asterisk HTTP listener, which initiates the flow of each time it receives the request on the configured host and port. Asterisk scheduler, which initiates the flow when the time-based condition is met. For example, to configure HTTP listener, follow these steps. In the Mule palette view, select HTTP then listener. Drag the listener to the studio canvas, and on the listener configuration screen, optionally change the value for the display name. Specify the value for the path field. Click the plus sign next to the connector configuration field to configure the global element that can be used by the instances of HTTP listener in the app. On the general tab, specify the connection information for the connector. On the TLS tab, optionally specify the TLS information for the connector. On the advanced tab, optionally specify the reconnection information including reconnection strategy. Click the test connection to confirm Mule can connect with the specified server and click OK. Now we are considering configure input source in using Anypoint Studio to configure configure scripting module 4. The source initiates the flow when a specified condition is met. You can configure the one of these input sources to use the scripting module. HTTP listener, which initiates the flow each time it receives the request on the configured host and port. Scheduler, which initiates the flow when time-based condition is met. For example, to configure HTTP listener, follow these steps. In the Mule palette view, select HTTP then listener. Drag the listener to the studio canvas. On the listener configuration screen, optionally change the value of the display name field. Specify the value for the path field. Click the plus sign next to the connector configuration field to configure the global element then that can be used by the all instances HTTP listener of the app. In the general tab, specify connection information. On the TLS tab, optionally specify TLS information. On the advanced tab, optionally specify connection information including reconnection strategy. click test connection to confirm that Mule can connect with the specified server, and click OK. Here you can now we are considering configure a source in Anypoint using Anypoint Studio for configure HTTP connector 1.8 Mule 4. The source indicates the flow when the specified connection condition is met. You can configure the one of these kind of sources to use the HTTP connector. HTTP listener initiate the flow each time it received a request on the configured host and port. Scheduler initiate the flow when a time-based condition is met. For example, to configure HTTP listener source, follow these steps. In Mule palette, select HTTP, then listener. Drag the listener to the studio canvas. On the listener configuration screen, optionally change the value of the display name field. Specify a value for the path field. Click the plus sign next to the connector configuration field to configure a global element that can be used by the all instances of HTTP listener source in the app. On the general tab, specify connection information for the connector. On the TLS tab, optionally specify the TLS information for the connector. On the advanced tab, optionally specify the reconnection information, including reconnection strategy. Click text connection to confirm that the Mule can connect with the specified server, and click OK. We are considering now we are considering add the connector in Studio in configuring box connector 5.2 using Studio Mule 4. In Studio, create Mule project. In the Mule palette view, click X, search in Exchange. In add modules to the project, click type box in the search field. Click this connector name in available modules. Click add. Click finish. Now we are considering configure the connector in Sora Aqua Connector Studio configuration. To configure this connector, drag the connector operation into Studio canvas to create the global element for the connector. Set this field username Sora username, password Sora password, base URI, the base path of the Aqua API for your instance, for example http://rest. API sandbox.sora.com :443. Now we are considering configure the connector in WebSockets Studio configuration. Go to the global elements tab and click create. From the connector configuration, select WebSockets config. If you want your connector to listen for incoming requests, check the configure inbound WebSockets section. If you want to perform the request to external services, check the configure outbound WebSocket section. You can check both if your application will be doing both inbound and outbound connections. Now we are considering other improvements in Studio 7 in introduction to Mule 4. New set of graphic icons for better usability, and a watermark text that will always display on the operation name, such as select or delete when you change the default display name of the operation. This change provides your view with the better visibility, collapsible flows with the interactive preview. Now we are considering limitations in test recorder in Studio test record in Studio in MUnit. The test recorder has the following limitations. When you create MUnit tests, you cannot create test for flows with Mule errors raised inside the flow already existing in the incoming event, even if an on error continue error handler control them. The record flow execution ends successfully, but the result does not reach the destination because the application is killed. Your validations fail every time your test runs. If you configure SPI, your asset processes to asset values for random data, time dependent information such as timestamps for values resulting from parallel process, because those values change in every execution. Mocking values resulting from the parallel process causes a mixture of real and mock data that comprises the execution of the processes that follow in your test. Although the record supports data iteration in the flow, such as recursions or loops, it does not support cases in which the structure of the data being tested changes inside the iteration. Recorder does not support the mocking message before or inside the for each for processor. When using test recorder to generate the test over your flow, you can only mock the parameters included in your flow. You cannot mock the parameters in subflows or in reference flows through the test recorder UI. If you need to mock parameters in subflows or any other processes in the project, you can modify the mocking component after creating the test. As an exception example, we can consider this: unable to connect to any database from the Mule Studio Mule Studio. This is occurred in the environment with Anypoint Studio version 7.4 and Mule runtime 4.2.02. org.mule.runtime connection exception could not obtain connection from data source. org.mule. The same is repeated here and caused by org.mule. Extension.db.api.exception.connection creation exception could not obtain connection from data source, etc. As an error example, we can consider this one: MuleSoft Studio console error occurred in the environment with Anypoint Studio version 7.9.0. http.listener.10 selector runner org.mule.service.http.impl.service.server.grizzly.mule.ss filter SSL handshake error received fatal alert certificate unknown. Now we are focusing on Anypoint integration platform. The MuleSoft's Anypoint platform is a unified single solution for IPAAS and a full lifecycle API management. The Anypoint platform consists of the following major components: Anypoint Security, Anypoint Design Center, Anypoint Management Center, Anypoint Exchange, Runtime Engine and Services, API-led connectivity, Application Network, Data View. CloudHub 2.0 is a fully managed, containerized integration platform as a service PaaS, where you can deploy APIs and integrations as lightweight containers in the cloud. Mule, the runtime engine of Anypoint platform, is a lightweight Java-based enterprise service bus ESB and integration platform that allows developers to connect applications together quickly and easily, enabling them to exchange data. It enables easy integration of existing systems regardless of the different technologies that the application use, including JMS, web services, JDBC, HTTP and more. The ESB can be deployed anywhere, can integrate and orchestrate events in real time or in batch, and has universal connectivity. Here you can see critical components of MuleSoft Anypoint platform. Anypoint MuleSoft Management Center, a unified web interface to efficiently manage all critical aspects of the platform, including but not limited to traffic, service level agreements, SLAs, API users, underlying integration flows, and more. Anypoint connectors offers state of the art tools and assets you need to connect faster. Anypoint Design Center, development tools that make it quick and simple to implement integration flows, design APIs and build connectors. Anypoint Exchange, a collaboration hub to search for private, pre-built and public reusable assets. Runtime services, an extensive suite of platform services that offer enterprise-grade scalability, security, high availability and reliability. Mule Runtime Engine combines real-time orchestration and application integration with robust data integration capabilities. Here you can see Anypoint Design Center. Within that you can see Studio, API Designer, Connector, Div Kit. And here you can see Anypoint Management Center. Within that you can see Runtime Manager, API Manager and Analytics. Between you can see Anypoint Exchange. Below Anypoint Design Center, Anypoint Exchange and Anypoint Management, you can see Runtime Services and Mule Runtime Engine. Below Mule Runtime Engine you can see there's Anypoint Connectors, and below Runtime Engine Hybrid Cloud is there. This diagram illustrates the relationship between design tools and other MuleSoft products. Anypoint Design Center includes a web-based tool where MuleSoft developers design and create API specifications and fragments. API Designer. Once your API specification or fragment is ready to be shared with the rest of the organization, you publish it to Anypoint Exchange for testing and approval. This development approach is spec driven. Before moving into API implementation phase, it's crucial to get the sign off from the business and other teams involved. They will test the API returning mock results, provide initial feedback and validate requirements. Anypoint Exchange is a virtual market to share, discover and reuse APIs, connectors, templates, etc. Other part of the design center, Flow Designer, is used to build Mule applications that connect systems into workflows. Here, specification writer uses API Designer. The design center consists API Designer and Flow Designer. Anypoint Platform consists of Design Center and Anypoint Exchange and API Manager. Developer uses Anypoint Studio. Anypoint Studio imports API specification as connectors for Mule apps from API Designer. And API Studio imports API specification as connectors for Mule apps from Anypoint Exchange. API Designer publishes specification and fragments to and imports them from Anypoint Exchange. Anypoint Designer can create dependencies on assets in Anypoint Exchange. Citizen Designer uses Flow Designer. Flow Designer imports API specification as connectors into Mule apps from Anypoint Exchange. Developer uses API Manager. API Manager imports API specifications from Anypoint Exchange. Here you can see a CloudHub 2.0 architecture. To understand CloudHub 2.0 security and availability, you should understand the architecture behind CloudHub 2.0. CloudHub 2.0 architecture comprises two major components: Anypoint Platform Services and shared global regions. These two components, along with Anypoint Runtime Manager, through which you can access them, work together to run your integration applications. Integration applications that you create and deploy to CloudHub 2.0 to perform integration logic for your business. Runtime Manager, user interface that enables you to deploy and monitor integrations and configure your account. Platform Services, shared CloudHub 2.0 platform services and APIs, which include Anypoint monitoring, alerting, logging, account management, private spaces, secure data gateway, and load balancing. CloudHub 2.0, an elastic cloud of replicas, an elastic cloud of replicas, Mule instances that run integration applications. Here, integration applications. An integration application is any integration that you have built using Anypoint Studio. These applications can do everything from synchronizing data from Salesforce to a database, to publishing a SOAP or REST API, to creating complex orchestration of business processes. Platform services. Platform services are responsible for coordinating all aspects of the platform. They coordinate deployment of applications, monitor integrations, provide analytics data, store application data, run schedule jobs, and more. Many of these services are exposed through the CloudHub 2.0 REST API. CloudHub 2.0 replicas. Replicas are dedicated instances of Mule runtime engine that run your integration applications on CloudHub 2.0. Replicas have following characteristics. Capacity. Each replica has a specific amount of capacity to process data. Select the size of your replicas when configuring an application. Isolation. Each replica runs in a separate container from every other applications. Manageability. Each replica is deployed and monitored independently. Locality. Each replica runs in a specific global region, such as the US, EU, or Asia Pacific. The memory capacity and processing power of replica depends on how you configure it at the application level. Replica sizes have different compute, memory, and storage capacities. You can scale replicas verticality by selecting one of the variables vCore sizes. Replicas within fewer than one vCore provide limited CPU and I/O apps with similar workloads can burst to higher CPU speed for short time. This ability helps to improve application startup times and to process infrequent large workloads. Note that application bursting depends on resource availability for nodes and is not guaranteed to occur. If you need consistent performance, use replicas with more vCores. Replica with one or more vCores provide performance consistency. Each replica has a minimum 8 GB storage, which is used for both system and application storage. If your application requires more storage, for example, verbose logging, use a replica with 2 or more vCores, enabling the application to access additional storage in /temp. All applications, including stopped applications, count toward replica usage. To prevent stop application from consuming resources, delete the application. If your applications require more vCores than are available, CloudHub 2.0 allows you to create an application, but you cannot start it until the additional vCores become available. To increase vCore allocation, delete an application or contact your account manager. To increase your subscriptions vCore allocation. Note applications that are stopped till consume vCores as if they were running. The metaspace limit for apps deployed to CloudHub 2.0 is currently 256 MB regardless of the replica size. The initial metaspace size is 128 MB. Metaspace garbage collection begins after the metaspace reaches that threshold. You can scale your applications horizontally by adding multiple replicas for persistent queues. CloudHub 2.0 monitors replicas to verify that they are operating correctly. If you enable automatic restart, CloudHub 2.0 also automatically restart application if necessary. Shared global regions. CloudHub 2.0 provides ability to deploy apps in different regions of the world: North America, South America, the European Union, and Asia Pacific. This global distribution enables you to host your integration in the local closest to your services, thus reducing latency. It can also provide for adherence to local laws, such as the EU Data Protection Directive for the US Cloud and MuleSoft government cloud control planes. MuleSoft hosts the management console and platform services in the United States. For EU cloud control plane, MuleSoft hosts these services in Europe. The region that you deploy your application to determine the domain provided by your application. Load balancer that Cloud 2.0 uses to route request beside in the same region as your application. Here, integration apps are connected to CloudHub 2.0. Runtime Manager interacts with platform services. Platform services consist REST API, Object Store version 2, Anypoint monitoring, logs, alerts, private specs, replica management, and schedule management. Platform services interacts with CloudHub 2.0. Here you can see the graphic. The graphic shows here this graphic shows the dedicated viewpoint, dedicated Anypoint VPC architecture. An Anypoint VPC is a logically private and isolated network hosted inside the Cloud Hub. You can connect to a private intranet to your Anypoint VPC as if they were all part of a single private network. The Anypoint VPC configuration exposes the DNS record, Mule worker internal app name .cloudhub.io. This is a DNS A record which includes the IP address of all of your workers, IP addresses of all of your workers. This DNS record cannot be accessed from outside your Anypoint VPC. Each Anypoint VPC allows you to configure firewall rules to check inbound connections directly to your workers. Four firewall rules are created by default. Two rules that allow your private address space to connect through ports 8091 and 8092, and two rules that allow external request proxies by Cloud Hub. Shared load Cloud Hub's shared load balancer through ports 8081 and 8082. All traffics that is not allowed in a firewall rule is blocked by default. Here external intranet interacts with DNS record in VPC. IPsec tunnel VPC peering direct connect is passed back and forth between DNS record and intranet. Here worker app names, workers and firewall rules and DNS records are inside VPC. DNS record is connected to firewall rules and firewall rules are connected to workers here. Here public internet is connected to DNS record in shared load balancer. In the Cloud Hub you can see shared load balancer and DNS record and VPC. This DNS record is inside shared load balancer and shared load balance is connected to DNS record here. 8081, 80 HTTP and 82 443 to 443 HTTPS pass from shared load balancer to DNS record here, and DNS record here is connected to firewall rules here, and this public internet interacts with DNS record here also. Here this graphic shows the Anypoint VPC architecture with a dedicated load balancer. You can configure a dedicated load balancer inside your VPC, which allows you to provide custom certificates and optionally enforce two-way SSL client authentication. If you configure proxy rules that map your applications to custom domains, you can, for example, host everything under single vanity domain. A CloudHub dedicated load balancer is assigned to a particular Anypoint VPC. A dedicated load balancer then routes traffic to a particular Anypoint VPC within a particular service region of the VPC. Each dedicated load balancer has a DNS A record. It's a IB name it's a LB name dot LB dot anypoints DNS dot net or lb dash name dot l dash lb dash prod dash eu dash rt dot anypoint dns dot net for EU control panel that resolve to two public IP addresses of its two instances. Throughout your DNS provider, you can add CNAME record pointing to the dedicated A record and use your own domain names to access it. This DNS A record can also be reached from outside VPC additionally. Outside VPC. Additionally, a CloudHub dedicated load balancer has an internal domain name to be used by applications and clients within Anypoint VPC. The structure is internal dash lb dash name dot lb dot anypoint dns.net. Here you can see public internet is connected to SSL endpoint, and DNS record and SSL endpoint and other internal DNS. These DNS records are inside dedicated load balancer. Intranet interacts with DNS record here, starting with internal dash lb dash name, and IPsec tunnel VPC peering direct connect is passing back and forth to and from intranet and DNS record. 2A TLS is passed to and from DNS record to SSL endpoint. Dedicated load balancer and mapping rules, DNS record here, and firewall and workers are inside VPC. Dedicated load balancer is connected to mapping rules. Mapping rules are connected to DNS record here, and 88, 8091, 80 HTTP and 8092 443 HTTPS are passed from mapping rules to DNS record. This DNS record is connected to firewall rules, and firewall rules are connected to workers here. And in the Cloud Hub, you can see shared load balancer with and DNS record and VPC. This DNS record here in shared load balancer, and 8081, 80 HTTP, 8082, 443 HTTPS are connected to DNS record here. Here you can see Mule ESB. The key advantage of an ESB is that it allows different applications to communicate with each other by acting as a transit system for carrying data between applications within your enterprise or across in the internet. Mule has powerful capabilities that include service creation and hosting. Expose your host reusable services using the ESB as a lightweight service container. Next point, service mediation. Shield services from message formats and protocols. Separate business logic from messaging, and enable location independent service calls. Next point is message routing. Route, filter, aggregate, and resequence messages based on content and rules. Next point is data transformation. Exchange data across varying formats and transport protocols. Here, business applications, portals. Here the Mule transporters and connectors are connected to business applications, portals, rich clients, trading partners, B2B, data resources, and connectivity services, adapters. Mule transports or connectors are connected to Mule integration services, routing, transaction management, transformation, message broker, transportation management, and security are inside Mule integration services. Below Mule integration services, app container is there. It's optional, and with app container you can see Tomcat, WebLogic, WebSphere, JBoss, JTO, Geromino is there. Here you can see the architecture of Mule management Console. Mule Management Console MMC was deprecated in December 2015. Its end of life is July 2019. This diagram summarizes the architecture of the Mule Management Console. Here, the Mule ESB instances monitored by MMC. This can be standalone or embedded instances or clusters. Here the MMC agent contained in the Mule instance, which is responsible for facilitating data transfer between the Mule instance and MMC, applying changes, that is thread pools and configuration file changes to the Mule applications. The number 3, the Mule instance, the MMC instance, the MMC instance, the web-based interface that interact with Mule through MMC agent, JMX function, and next point is JMX functionality exposed by Mule. MMC instance is a web application package as MMC instance is a web application package as a WAR file that execute from within your web servlet container, that is Tomcat, JBoss, etc. Number 4 here, transactional database, that is stored business event transactional data collected by the MMC agent within the Mule instance. This database by default is an H2 database, but you can configure MMC to use other relational databases. Number 5, the environmental database that stores state information about various Mule instances and applications managed by MMC, including alerts, deployments, configuration, etc. The database is by default Apache Jackrabbit, but you can configure MMC to use other relational databases. Number 6, MMC's REST interface, which exposes MMC functionality through a REST API. MMC users can invoke this API to apply to MMS users can invoke this API to programmatically Mule instances paired with MMC. Here you can see Mule ESB instances or instances, and you can see MMC agent here within Mule ESB instance. This instance interact and MMC agent interacts with the MMC web application, the console. MMC web application the console is connected to transaction data, business events, environment data. This MMC application, the console is connected to console interacts with MMC REST API here. Component lifecycle. This is related to developing components. When developing components, you focus on developing code to handle the business logic, not to integrate the component with Mule. For example, if you are developing a component that adds customer data to an invoice, you focus on writing code that queries the customer database and updates the invoice as needed. You do not have to write any special code to handle the message that's passed to the component or to integrate with Mule, as all integration is handled through configuration. You can develop the component as a POJO or as a web service using popular container such as Spring, EJB or Plexus. Component lifecycle. Your component can implement several lifecycle interfaces. The lifecycle flow typically look like this, with the on-call often being replaced by an entry point resolver. Following are the most commonly used lifecycle interfaces. org.mule.api.lifecycle.initializable. This is called only once for the lifecycle of the component. It is called when the component is created and when the component pool initializes. With the interface initializable, the initializable is a lifecycle interface that gets called at the initialize lifecycle stage of the implementing service. Here you can see the method initialize. The method is used to perform any initialization work. If a fatal error occurs during initialization, an initialization exception should be thrown, causing the Mule instance to shut down. If the error is recoverable, say by retrying to connect, a recoverable exception should be thrown. There is no guarantee that by throwing a recoverable exception that the Mule instance will not shut down. org.mule.api.lifecycle.startable. This is called when the component is started. This happens once when the service starts and whenever the component is stopped and started either through the API or JMX. The interface startable provides an object with the start method which gets called when the Mule instance gets started. This is mostly used by infrastructure components, but can also be implemented by service objects. This lifecycle interface should always be implemented with its opposite lifecycle interface stoppable. And here you can see the method start. Here you can see the interface org.mule.api.lifecycle.callable. Callable is used to provide service with an interface that supports the event calls. Components do not have to implement this interface. Through the on-call method provides an example lifecycle method that is executed when the event is received for the implementing service. Here you can see on-call method passes the event to the listener. And here you can see org.mule.api.lifecycle.stoppable. This is called when the component is stopped. This happens when the server stops, so whenever the component is stopped either through the API or JMX. With the interface stoppable is a lifecycle interface that introduces a stop method to an object. This lifecycle interface should always be implemented with its opposite lifecycle interface startable. org.mule.api.lifecycle.disposable. This is called when the component is disposed. This is called once the server shuts down. And with the interface disposable is a lifecycle interface that gets called at the disposed lifecycle stage of the implementing service as a service is being destroyed. You can see the dispose method here, a lifecycle method where implementer should free up any resources. If an exception is thrown, it should just be logged and processing should continue. This method should not throw runtime exceptions. And here you can see default constructor is connected to initialize is connected to start is connected to on call is connected to stop is connected to dispose methods. Here you can see Anypoint virtual private network in CloudHub 2.0. Anypoint VPN virtual private network creates a secure connection between your private space and your on-premises network. Anypoint VPN enables apps running in the private space to access the resources on your on-premises data centers behind your corporate firewall. You can create multiple site-to-site VPNs if required. If the number of VPNs you can create depends on the network connection entitlements available on your account. Contact your MuleSoft account representative if you don't know how many network connection entitlements you have on your account. Anypoint VPN supports site-to-site internet protocol security (IPsec) connections between the private space and the VPN endpoint. The gateway device is a physical or software compliance located in your network. MuleSoft side of the connection is an implementation of a virtual private gateway. VGW. The MuleSoft VGW is associated with a single private space but can support up to 10 VPN connections. To create an Anypoint VPN connection to your network, create a connection to your external network in the documentation. Here you can see a private space. You can see the private space in CloudHub 2.0. Here the private space 10.0.0.0.0/24, and here CloudHub interacts with the CloudHub external gateway IP address here. Here in this example 54.208.209.9, and it interacts with the CloudHub external gateway IP address interacts with the your external gateway IP address via IPsec and tunnel is 217.18.13.66. Here the data centers are in on-premises data center. Here the 192.168.177.0/24 here. Here you can see here you can see configure high availability with Anypoint VPN. Following example here, this shows a high availability VPN topology using a single Anypoint VPC and two VPN connections. MuleSoft virtual private gateway VGW supports one Anypoint PVC association, but it supports up to 10 VPN connections, you can locate your VPN gateway in the same data center or different physical connections. The BGP routing to advertise the same route via VPN 1 and VPN 2. In this scenario, the VPN gateways are configured to prefer VPN 1 tunnel, VPN 1 tunnel 1, VPN 1 tunnel 2, then VPN 2 tunnel 1, and finally VPN 2 tunnel 2. This configuration produces an automatic failover to another tunnel and to another VPN in the event of VPN connectivity issue. This makes the Anypoint VPN solution more resilient and robust. High availability VPN connections also support static routing, in which you establish a VPN 2 to work as a redundant standby connection in the event of failure with VPN 1. Here you can see private space. Here applications are in private space, and private space is in CloudHub 2.0. It's in here the it interacts with the MuleSoft virtual private gateway. Here Anypoint VPN 1 is connected to MuleSoft virtual private gateway via tunnel 1 and tunnel 2. And here the Anypoint VPN 2 is connected to MuleSoft virtual private gateway via tunnel 1 and tunnel 2. Here Anypoint VPN is connected to customer VPN gateway, and here the Anypoint VPN 2 is connected to customer VPN gateway. Customer VPN gateway is interested in the customer network here. Here you can see transit gateway attachments. The AWS Transit Gateway acts as a cloud router in AWS, simplify network access between private spaces, on-premises data centers, and third-party software, while providing increased visibility and control over the network. Transit gateways effectively merge your organization cloud resources and the on-premises data centers into one network topology. On Cloud 2.0, you can take advantage of this network's implication by securely attaching your private space to AWS Transit Gateway in your AWS account. You can add multiple transit gateways to your endpoint platform organization. The number of transit gateways you can add depends on the network connection entitlements available on your account. Contact your MuleSoft account representative if you don't know how many entitlements are associated with your account. To use the transit gateway attachment, your private space and AWS Transit Gateway must be in the same region. Here you can see private space. Here the 10.0.0.0/24 is in CloudHub 2.0. Here the private space interacts with the transit gateway via VPC attachment. Here the CloudHub 2.0 transit gateway and AWS VPC are in AWS region. Here the transit gateway interacts with private space via VPC attachment, and AWS VPC via VPC attachment, and on-premises data center via VPN. Here the with the data centers are in the AWS VPC here, and the on-premises data centers are in the on-premises data center here, and here you can see the firewall. Here you can see CloudHub 2.0 at architecture. To understand the CloudHub 2.0 security and availability, you should understand the architecture behind the CloudHub 2.0. CloudHub 2.0 architecture comprises two major components: Anypoint Platform Service and shared global regions. These two components, along with the shared global regions and these two components, along with Anypoint Runtime Manager, through which you can access them, work together to run your integration applications. Here the one integration applications that you create and deploy to CloudHub 2.0 to perform integration logic for your business. Here Runtime Manager, user interface that enables you to deploy and monitor integrations and configure your account. Here the shared CloudHub 2.0 platform services and API, which include endpoint monitoring, alerting, logging, account management, private spaces or secure data gateway, and load balancing. Here the platform services are here. The shared Cloud 2.0 platform services and APIs, which include endpoint monitoring, alerting, logging, account management, private spaces, so secure data gateway, and load balancing. Here the Cloud Hub 2.0 and Elastic Cloud of replicas, Mule instances that run integration applications. Note, you can view the live status and detailed service history for Runtime Manager, Platform Services, and Cloud Hub 2.0 on status.mulesoft.com for default US hosted control plane, and EU1-status.mulesoft.com for EU control plane. Integration applications. An integration application is any integration that you have built using Anypoint Studio. This application can do everything from the synchronizing data from the Salesforce to the database, to publish a SOAP or REST API, to creating complex orchestrations of business process. Runtime Manager. Runtime Manager is integrated into Anypoint platform, signed in with your Anypoint platform credentials to deploy them and manage integration application at runtime. Console provides monitoring information from the platform services and also functions as a comprehensive dashboard for both application level and account level management. Administrator account holders can use the Anypoint platform to add and manage other users in the organization, define user roles, create and manage sandbox environment. Platform services are responsible for coordinating all aspects of the platform. They coordinate deployment of application, monitor integrations, provide analytics data, store application data, run schedules jobs, and more. Many of these services are also exposed through the CloudHub 2.0 REST API. Here you can see application integration apps are connected to CloudHub 2.0. CloudHub 2.0 interacts with the platform services, REST API, object store version 2, Anypoint monitoring, logs, alerts, private spaces, replica management, and schedule management are in platform services. Platform services interacts with the runtime manager. Here you can see CloudHub components, load balancer, virtual private cloud, and a DNS record of the Mule workers. The CloudHub provides a variety of tools to architect your integrations and APIs, so they can here the Mule workers. The CloudHub provides a variety of tools to architect your integrations and APIs so that they are maintainable, secure, and scalable. Here you can see the basic network architecture, DNS and firewall rules. This image shows the CloudHub components, load balancer, virtual private cloud, and DNS record of the Mule workers. Load balancing, CloudHub provides the load balancing service for all integrations. You can use the default balancing service to obtain a dedicated load balancer. CloudHub load balancing service does round-robin load distribution across workers, which allows workers to scale linearly as they receive more requests. Load balancing service also provides transparent switch holder when an application is upgraded. Each application deployed on the CloudHub has a CNAME record that refers to the load balancer. For example, myapp.region.cloudhub.io Mule application deployed to the CloudHub must listen to the host 0.0.0.0 and to either HTTP port 8081 or to the HTTPS port 882. Following ports are assigned to the Mule worker. HTTP port is set to 8081. HTTPS port is set to 8082. The load balancer then forward requests to the assigned ports on the Mule worker. Forward traffic still uses HTTP and HTTPS protocols, which means it can't listen to the HTTPS on assign open curly brace HTTP dot port close curly brace or plain HTTP on the HTTPS dot port. You must reference these ports using the reserved properties HTTP dot port and HTTPS dot port recursively. CloudHub services can then dynamically allocate a port at deployment time. DNS records. The following DNS records for your applications are exposed when they are deployed to CloudHub. myapp.region.cloudhub.io load balancer port 80 and 443 forward to HTTP dot port and HTTPS dot port respectively. Mule worker myapp.region.cloudhub.io the external IP address of the Mule worker. Public HTTP services are exposed on HTTP dot port and HTTPS dot port. Mule worker internal myapp.region.cloudhub.io the internal IP address of the Mule worker. The IP address for this DNS record are accessible only within a customer's private Anypoint VPC. These IP addresses are not accessible for workers running in the MuleSoft shared VPC. Internal HTTP services are exposed to http.private.port and https.private.port. The default assigned ports are 91 and 892 respectively and cannot be changed. In certain situations, you may want to know the application's internal IP addresses. For example, when communicating with worker directly within the customer Anypoint VPC without sending data over the public internet. When setting up your own load balancer, you can access these IP addresses through the Mule worker internal myapp.region.cloudhub.io record within the Anypoint VPC. If you access the workers directly, any load distribution benefits from the CloudHub load balancing layer are lost. Here you can see load balance is connected to myapp worker 1 and myapp worker 2. myapp worker 1 and myapp worker 2 is in optional VPC, and optional VPC interacts with the external VPC network. Here we are considering building Mule applications to support persistent queues. in CloudHub. For your application to benefit from the persistent queuing, implement the reliability patterns in your application code, separating individual XA transactions. The reliable acquisition flow reliably delivers a message from an inbound HTTP connector to an outbound VM endpoint. If the reliable acquisition flow cannot put the message into the VM queue, it ensures that the message is not lost by returning the unsuccessful response to the client, so that the client can retry the request. Application logic flow delivers the message from the inbound VM endpoint to the business logic processing in your application. This flow represents one transaction. Your business logic may involve several other transactions not shown. Between these two flows, VM queues hold the messages committed by the reliable acquisition flow until they are ready for processing by the application logic flow. In case of processing error within a transaction, or in the case of transaction timeout, that the allotted for the transaction is exceeded, Mule triggers the rollback. This rollback erases any partial processing that has occurred in the message and passes the message back to the queue. If your Mule instance experiences an outage and is unable to execute rollback transaction automatically roll back once the time allotted for the transaction is exceeded. Allotted time is determined by the timeout attribute of the transaction element. You can configure timeout yourself or accept the default. It is helpful to think that each transaction in terms of 3 steps. Begin. Mule kicks off the processing of all subcomponents within the transaction. Commit. Mule send the result to the completed transaction to the next step. For XA transaction, commit step has 2 phases: commit request phase and commit phase. During the commit phase, Mule coordinates the result of the Mule resources within the scope that the transaction and confirm that all processing executed successfully and ready to commit. Commit phase then calls each resource to the commit its processing. Rollback. If an error occurs in either the begin or commit step, rollback back to the options within the transaction so that no one part results in the partial completion. Here you can see a request client is connected to the HTTP via request HTTP, and add message queue are in reliable acquisition flow. HTTP is connected to the add message queue, and here the HTTP is connected to the client via status response, and here the add message queue is add message to the queue is connected to the VM. VM interacts with the reliable acquisition flow and application logic flow. VM is connected to the consume message from the queue. Consume message from the queue, flow ref to the business logic subflow, and add message to the queue are in application logic flow transaction 1 here. Consume message from queue is connected to flow ref to business logic subflow, and it is connected to add message to queue, and it is connected to the VM. Here you can see Anypoint CloudHub default deployment model. If the application uses multiple workers, CloudHub deploy the worker in a separate availability zones by default provide HA across availability zones. The distance between availability zones is variable and generally doesn't exceed 350 miles. If an application uses a single worker, then the availability zone is unavailable. CloudHub automatically restart the application in a different availability zone. In this case, the application might experience downtime. You can set up status.mulesoft.com to receive alerts when the failure occurs in an availability zone or region. Here you can see Mule interacts with region, and Mules interacts with region and availability zone. Availability zone interacts with the other availability zones. Here availability zones are in the region, and here the again availability zones are in the region. Here the Mule region and availability zones are Mule and regions are in Amazon Web Services. Here you can see suggested alternative deployment model. You can use the load balancer or load balancer cloud or on premises for applications deployed to a different regions to provide better disaster recovery strategy. Here you can see region and Mule and regions and Mule are in Amazon Web Services. Here availability zones are in the regions. Mule interacts with the region and the availability zone. Here Mules are connected to Mules interacts with the load balancer. Here you can see a virtual private cloud in CloudHub. Anypoint virtual private cloud VPC offering allows you to create virtual private and isolated network segment in the cloud to host your CloudHub workers. Connecting to your Anypoint VPC extend your corporate network and allow CloudHub workers to access resources behind your corporate firewall. You can connect to the on-premises data centers through a secure VPN tunnel or transit gateway attachment, or connect private AWS VPC to your Anypoint VPC through VPC peering or AWS Direct Connect. The base Anypoint VPC subscription includes 2 Anypoint VPCs, and each Anypoint VPC can associate with the multiple environment. This allows you, for example, to have one isolated network for your production environment and another for your non-production environment. For example, QA and staging. Your license requirements depend on your specific deployment scenario. Anypoint VPC support different Amazon regions. During setup, you need to specify which Amazon region you want. You can even have multiple Anypoint VPCs inside a single Amazon region. Each Anypoint VPC allow you to configure firewalls rules to apply to your workers. You can choose to expose or block your custom ports, or even blocks request to apps coming from the CloudHub shared load balancer. If you use dedicated load balancers, you can configure one or more dedicated load balancer to validate requests using your own SSL certificate and to map input URLs calls to the different CloudHub applications. Combining firewall rules and dedicated load balancers configuration enables you to fine-tune how external services reach your applications. Here workers are inside production VPC here, and here the workers are inside non-production VPC. Here you can see the IP addresses. Here the production VPC and non-production VPC are in region US East 1, and region is inside CloudHub. Here the production VPC interacts with your network, and also non-production VPC interacts with your network and devices, users, and office buildings are in your network. Here you can see the default Anypoint VPC architecture in CloudHub. The Anypoint VPC is logically private and isolated network hosted inside CloudHub. You can connect to a private intranet to your Anypoint VPC as if they were all part of a single private network. Anypoint VPC configuration exposes the DNS record mule-worker-internal, then appname.cloudhub.io. This DNS record, which includes the IP address of all your workers, this DNS record cannot be accessed from outside your Anypoint VPC. Each Anypoint VPC allows you to configure firewall rules to check inbound connections directly to your workers. For firewall rules created by default, two rules that allows you private address space to connect through the ports HTTP ports 8091 and 892, and rules that allow external request proxies by the CloudHub shared load balancer. And here the 881 and 882 also here, and the shared load balancer ports through 881 and 882 here. All traffic that is not allowed in the firewall rule is blocked by default. Here graphic shows the default Anypoint VPC architecture. Here you can see a public internet is connected to DNS record here. Here the shared load balancer, DNS record, and here the VPC are in CloudHub. Here the DNS record is in the shared load balancer. Here the DNS record, here the HTTP ://appname.region.cloudhub.io, and it is connected to DNS record via HTTP 881 88 HTTP and 882 443 HTTPS to the DNS record. Here the you can see the DNS record. Here the HTTP :// mule worker app name.region cloudhub.io port, and DNS record is connected to firewall rules here. Here worker app names, firewall rules, and DNS records are in VPC here. Here the VPC 10.10.0.0/24. Here the here there's a DNS record DNS record interacts with IPsec tunnel, VPC peering, and direct connect. Here you can see the DNS records HTTP :// mule worker internal app name.region.cloudhub.io 8091, and same with 8092, and DNS record is connected to firewall rules. Here the firewall rules are connected to worker app name. You can configure here you can see the Anypoint VPC architecture with the dedicated load balancer. You can configure a dedicated load balancer inside your VPC which allows you to provide custom certificates and optionally enforce a two-way SSL. Allows you to two-way SSL client authentication. If you configure proxy rules that map your applications to the custom domains, you can, for example, host everything under single vanity domain. This graphic shows the Anypoint VPC architecture with the dedicated load balancer. CloudHub dedicated load balancer is assigned to a particular Anypoint VPC. Dedicated load balancer then routes the traffic to that particular Anypoint VPC. Within the particular service region of the VPC. Each dedicated load balancer has a DNS record. ib-name.lb.anypointsdns.net or lb name lb-prod eu rt.anypointdns.net for EU control plane that resolves the two public IP addresses of its two instances. Through your DNS provider, you can add a CNAME record point into the dedicated A record and use your own domain names to access it. The DNS A record can also be reached from outside the VPC. Additionally, a CloudHub dedicated load balancer has an internal domain name to be used by the applications and clients within the Anypoint VPC. The structure is internal -lb-name.lb.anypoints.dns.net. Here you can see public internet is connected to SSL endpoint. Here http://api.yourdomain.com/app-name. Here the dedicated load balancer and mapping rules and DNS record and firewall rules and worker app names are in VPC. Here the DNS record and SSL endpoints interacts with the two-way TLS, and here you can here the internal -lb-name.lb-anypoint.net /app name. This DNS record interacts with the IP sec tunnel, VPC peering, and direct interact via direct connect for the internal network. And here the dedicated load balance is connected to mapping rules. Here the lb-name.lb-anypoint.net /app name and app name.cloudhub.io. Here Mapping rules are connected to a DNS record via 8091, 80 HTTP and 8092 443 HTTPS. Here the DNS record, here the http:// mule worker internal app name .region cloudhub.io 8091 and 92. The DNS record is connected to firewall and firewall is connected to app worker app name. Here the VPC and DNS record and shared load balancer are in CloudHub. Here the 8081, 80 HTTP, 882, 443 HTTPs are connected to DNS record here, http:// mule worker app name .region.cloudhub.io.port. Here the DNS record is in shared load balancer, and here the http:// app name .region.cloudhub.io. Here you can see IPsec tunnel in CloudHub. You can use the IPsec tunnel with the network to network configuration to connect your on-premises data centers to your Anypoint VPC. An IPsec VPC tunnel is generally the recommended solution for VPC to on-premises connectivity, as it provides the standardized, secure way to connect. This method also integrates the well-existing IT infrastructure such as routers and appliances. Note, if you are using legacy VPN, and migrate to Anypoint VPN before making changes. To create Anypoint VPN connection to your network, see the Anypoint VPN in the documentation. Here you can see Anypoint, the workers are in Anypoint VPC, and Anypoint VPC is in the CloudHub, and it's interact with the CloudHub external gateway IP address here, and CloudHub external gateway IP address is in IP address interacts with the UI external gateway IP address via IPsec tunnel, and it's interacts with the firewall, and firewall interacts with the on-premises data center here. Data centers are inside on-premises data center here. Sorry, data centers are inside the on-premises data center here. Here you can see transit gateway attachments. AWS transit gateway act as a cloud cloud router in AWS, simplifying the network access between EPC on premises data centers and third-party software, while providing increased visibility and control over the network. Transit gateways effectively match your organizational cloud resources and on-premises data centers into one network topology. On CloudHub, you can take advantages of this network simplification by securely attaching Anypoint VPC to an AWS transit gateway in your AWS account. To use the transit gateway attachment, use your Anypoint VPC and AWS transit gateway must be in the same region. Here workers are in Anypoint VPC, and Anypoint VPC is in CloudHub, and CloudHub and AWS VPC and transit gateways are in AWS region, and Anypoint VPC interacts with the transit gateway via VPC attachment, and transit gateway interacts with the Anypoint VPC via VPC attachment, and AWS VPC via VPC attachment, and on-premises data center via VPN. Here the transit gateway, AWS VPC and on-premises data center are in your network, and data centers are in your AWS VPC and in the VPC, and data centers are in on-premises data center. This is the firewall. Here you can see VPC peering. VPC peering provides the connection between your two VPCs. In this case, it pairs your private Amazon VPC directly to your Anypoint VPC. This enables you to route traffic between two VPCs so that so they can communicate as though they are in the same network. Here you can see Anypoint workers are in Anypoint VPC, and Anypoint VPC is in CloudHub, and CloudHub and AWS VPC are in the AWS region. Anypoint VPC interacts with the AWS VPC via VPC peering connection. Data centers are in the AWS VPC. Now we are considering AWS Direct Connect in CloudHub. To create a direct connection to Anypoint VPC, create and or leverage the existing AWS Transit Gateway on your AWS account and set up the direct connection to the Transit Gateway. Then attach Anypoint VPC to the Transit Gateway and configure the required routing to enable the Anypoint VPC on-premises connectivity. Note, to use the Direct Connect, your AWS Direct Connect partner and the Anypoint VPCs must be located in the same region. Direct Connect gateways are not supported. Direct Connect requires the use of Broader Gateway Protocol (BGP) for dynamic routing. For higher availability, use multiple Direct Connect connections from the different AWS Direct Connect locations. Here you can see workers are in Anypoint VPC, and it is in CloudHub, and CloudHub and your network are in the AWS region. Anypoint VPC interacts with the Transit Gateway via VPC attachment. Transit Gateway interacts with the on-premises data center via AWS Direct Connect, and data centers are in on-premises data center, and a Transit Gateway and on-premises data center are in your network. Here you can see how a load balancer interacts with VPC and Anypoint platform. Routing internal requests to the dedicated load balancer. The CloudHub dedicated load balancer has an internal domain name. The internal domain name that is used by the application and clients within the Anypoint VPC. Internal domain uses the following naming convention. LB-name is the name you give to the load balancer when you create it. It's internal -lb name .lb.anypointdns.net. Each DLB and has DNS records. LB name.lb anypoint.dns.net that resolve to the public IP addresses correlated to the number of workers. Through your DNS provider, you can add CNAME record pointing to the record and use the domain names to access it. If you want your load balancer to merge all connections to your applications but do not want to default domain name for your application publicly exposed, then the application must listen to the HTTP port 80 or port 8091 or 8092. Alternatively, you can create a custom mapping policy to direct outside request from your load balancer to a specific applications. The following diagram shows how a load balancer interacts between VPC and Anypoint platform. Load balancer listens from outside request or HTTPS, and by default they communicate internally with a worker over HTTP. If you configured your Mule application within the Anypoint VPC, to listen to HTTPS, you must set the upstream protocol to HTTPS, then creating the mapping list by using the load balancer mappings add command. Internal HTTP mod lets you to configure how HTTP requests are managed. They are either silently ignored is mapped HTTPS on default SSL endpoint, or URL is mapped straight to the corresponding HTTPS URL. Here the LB management service perform LB management, LB deployment and recovery procedures based on the customer request and checks performed in recurring basis. Instance presence check runs every minute. Instance impaired check status check, which checks the degraded hardware or services, run every 5 minutes. Check the will trigger recovery if needed. Here the services and LB management service are inside the Anypoint platform. LB management service is connected to load balancer here. Here the watchdog and LB process are in load balancer here, and watchdog checks once a minute if LB process has failed, so that the LB management service can recover when there is a failure. Here it is HTTP 80 and HTTP S443 HTTPS 443 via public DNS is connected to LB here. Here the LB is connected to apps. Here the is via HTTP 8091 or HTTPS 8092 via internal DNS. Apps are inside customer VPC or VPC. Here the public access via 8091 and 8092 are connected to app 1, app 2, app 3 is not possible here. Here you can see CloudHub 2.0. At MuleSoft Connect 2022, we announced their CloudHub 2.0. This new release builds the on success of existing CloudHub infrastructure by bringing the brand new deployment experience and containerized architecture based on the Kubernetes. With this update, users can quickly deploy their integrations, APIs, and automations to a resilient, scalable environment. Today, we are to announce this to environments. Here, you can see the Anypoint control pane. It's interact with the Anypoint monitoring analogs, object store version 2, and runtime manager, Anypoint exchange, and access management. This interacts with the MuleSoft platform services. MuleSoft platform services interacts with the worker nodes, and here the CloudHub 2.0 shared space VPCs are here. Here you can see the worker nodes, and here the orchestration services. Here you can see CloudHub architecture. MuleSoft defined a CloudHub as a cloud-based integration platform as a service, IPaaS, that enable developers to integrate and orchestrate applications and services while giving operations and control and visibility they required for mission critical demands, all without the need to install or manage middleware or hardware infrastructure. You can deploy applications to CloudHub through Anypoint Anypoint runtime manager found on the Anypoint platform. Comparing CloudHub with other app deployment scenarios, Runtime Fabric, customer hosted, private cloud foundry. It is the easiest option for deploying Mule applications. However, the applications CloudHub as itself and Mule applications are deployed, executed under AWS infrastructure. For example, and specifically each deployed application is running under EC2 instance with the Linux or Mule runtime with JVM. How each instance per work is more complex than it may seem. CloudHub workers also execute cloud-based system services on the OS. and Mule Runtime, which are required for the platform capabilities provided by CloudHub, such as monitoring of Mule application in terms of CPU, memory usage, number of messages, errors, etc., which allow Anypoint platform to provide analytics and alerts based on the matrices. Auto restarting failed CloudHub workers, including failed Mule runtime and on the otherwise functional EC2 instances. Load balancing only to healthy CloudHub workers. Provisioning of new CloudHub workers to increase or reduce capacity. Persistence using object stores of message payloads or other data across the CloudHub workers of a Mule application. DNS entries for CloudHub workers on and CloudHub load balancer. Each Mule application is assigned a DNS name maintained by the AWS root. Here Amazon AWS platform services are connected to naming, persistence, load balancing, and AWS platform services interacts with the provisioning and auto start. Here the persistent is connected persistence, provisioning, load balancing, and auto start are connected to HA and scalable execution. It interacts with the CloudHub worker. Here the auto restart is connected to CloudHub auto restart and load balancings are connected to CloudHub system services in CloudHub worker. Here the monitoring and alerting of API implementations is connected to CloudHub system services in CloudHub worker. CloudHub system services, Mule runtime, Linux, and policy holder search implementation are in CloudHub worker. Here the CloudHub system services are connected to Linux, and here the CloudHub system services are connected to interact with Mule runtime, and Mule runtime interact with the Linux. Here the backend system interact with the Mule runtime and policy holder search implementation. Here the fault tolerant API invocation interacts with the Mule runtime and policy holder search implementation. Policy holder search RAML definition is in policy holder search implementation. Here you can see the high level architecture in which the API implementations running on each CloudHub worker involved, worker invoked. Each Mule application is assigned a DNS name maintained by the AWS root 53 service. In turn, it also received the two other known DNS names that resolved all the CloudHub workers of the Mule application. The following diagram represents the high-level architecture in which the API implementations running on each CloudHub worker are invoked. The client certificates associated with the CloudHub load balancer only work if it is a dedicated LDB, not a shared load balancer SLB. In case of using shared load balancer, the default certificate of CloudHub will be applied. And the certificate applied in the HTTP listener component will be replaced by the one in the CloudHub. Here you can see API client is connected to a CloudHub load balancer via HTTP or HTTPS, and the API client is connected to CloudHub worker 1 and the worker N via HTTP or HTTPS here. and the API client is connected to Amazon route 53 via DNS lookup, and Amazon route 53 is connected to CloudHub load balancer. CloudHub load balancer interacts with the client certificate, and it is optional, and CloudHub load balancer is connected to CloudHub worker 1 and worker n via HTTP or HTTPS. Here the API implementations are in CloudHub workers here. Here you can see the Mule events in Mule runtime. A Mule event contains the core information processed by the runtime. It travels through the component inside your Mule app following the configured application logic. Note that the Mule event is immutable, so every change to an instance of a Mule event results in the creation of a new instance. A Mule event is composed of these objects. A Mule message contains message payload and its associated attributes. Variables are Mule event metadata that you use in your flow. Here you can see attributes and payloads are in Mule message, and variables are in Mule event. Here you can see a Mule message structure in Mule runtime. Mule message is a part of the Mule event that serves as a container for message content and metadata, typically from external sources, as it is processed within the flows of a Mule app. Mule message is immutable, so every change to the Mule message results in creation of a new instance. Each processor in a flow receives a message, returns a new Mule message consisting of these parts: message payload, which contains the body of the message, for example, the content of a file, a HTTP body, a record from a database, or a response to a REST or web service request. Message attributes, which are metadata associated with the payload, such as HTTP headers and query parameters. Here the attributes. Mule event source triggers a process that creates a Mule event with the Mule message and execute the Mule flow that contains the event source. For example, this process begins each time the HTTP listener source receives the request to the scheduler executes. After a flow begins its execution, downstream process such as core component, file read operations, or HTTP request operation can then retrieve, set, and process Mule message data, payload, and attributes that reside in the Mule event according to their configurations. Note that in Anypoint Studio, the Data Science Explorer shows the structure of a message at any given point of the flow. Message payload. The message payload contains the content of the body of the message. For example, a payload contains the result of a HTTP request, the content of records you retrieve through the selection operation of the database connector, or the content of a file you retrieve through a read operation to a file or FTP connector. Attributes contains the metadata associated with the body or payload of the message. The specific attributes of a message depend on the connector, such as HTTP, FTP file associated with the message. Metadata can consist of headers and properties received or returned by the connector, as well as other metadata that is populated by a connector or through a core component, such as a transform message. Here you can see attributes and payload are in Mule message. Here you can see Mule errors. Here the Mule error types. In Mule runtime, Mule errors have a namespace such as HTTP and file, an identifier such as not found. They belongs to a hierarchy of error types. Naming conventions enable you to distinguish the errors according to their domain. For example, instead of throwing not found, the HTTP connector can throw HTTP : not underscore found. The file connector can throw file : not found errors. Unlike connectors, Mule runtime errors have an implicit Mule namespace. So Mule : expression and expression are interpreted in the same way. Error types can have a parent type. For example, parents of HTTP : unauthorized is Mule : client underscore security. And the parent of Mule : client underscore security is Mule : security. This hierarchy implies each error type is a specification of more global error type. For example, an HTTP : unauthorized error type is the type of a client security error. Mule : client security, which is a type of a more broad security issue, Mule : security. Hierarchies enable you to route errors in a general and or more specific way. For example, an error handler or Mule security catches an HTTP unauthorized errors and auth errors. The follow figure shows the core runtime hierarchy. All errors belongs to one of these two main types, any or and critical. Each type under any is matched by its parent and can be handled, while error types under critical are so severe that cannot be handled and are only logged. Critical errors include fatal JVM error and overload. Whenever there is no clear reason for a failure, a component can use the unknown type. You handle this error through any type to define unclear errors without changing the existing behavior of the app. For connectors, for each connector, define its error type hierarchy considering core runtime hierarchy through connectivity. And retry exhausted types are always present because they are common to all connectors. Error types, any error types that matches all error types that occur in the flow can be handled. This type does not include errors that occur on the source. Transformation indicates an error occurred while transforming a value. This involves the Mule runtime internal transformations and not data wave transformations, expressions. Indicates an error occurred while evaluating the data view expression. Validation indicates an validation error occurred. Duplicate message indicates a validation error regarding a message being processed twice. For example, using independent message validator. Redelivery exhausted indicates that the max attempts to reprocess a message from a source have been exhausted. Connectivity indicates that there was a problem establishing connectivity connection. This could occur while using a connector, for example, HTTP requester. Retry exhausted indicate that the retries of a certain execution block have been exhausted. For example, for a given operation or using until successful scope. Routing indicates an error occurred while routing a message, for example, using a round-robin router. Composite routing indicates that one or more errors occurred while routing a message, for example, scatter-gather router. Security indicates the security error occurred, like invalid credentials being received or expired token being used. Client security indicates an external entity calling an external endpoint produces a security error. Server security indicates a security error enforced by the runtime, Mule runtime. Not permitted indicates a security restriction enforced by a filter, for example, using the authorization filter of the Mule Spring module. Stream maximum size exceeded indicates the maximum size allowed for a stream has been exceeded. For timeout indicate timeout occurred while processing a message. Unknown indicates an unknown or unexpected error occurred. This cannot be handled directly, only by handling any to ensure backward compatibility in case more error types added in future runtime versions. Source indicates that error occurred in the source of the flow. These errors cannot be handled. A source error response generate indicates that an error occurred in the source of the flow, generating the parameters of an error type, error response. This error cannot be handled since the source has already executed the failing path. Source error response send indicates that an error occurred in the source of the flow sending an error response. This error can be handled since the source has already executed the failing path. Source response indicate that the error occurred in the source of the flow while processing a successful message. These errors can only be propagated since the source already executed the successful path. These errors cannot be handled. Source response generate indicate an error occurred in the source of the flow while generating the parameters of the successful response. Source response send indicate an error occurred in the source of the flow while sending a successful response. Critical indicates the severe error occurred. These errors cannot be handled. Overload indicates the problem of overloading occurred and execution was rejected. Flowback pressure indicates the problem of overloading occurred at the source level, for example, using Registry listener as a source. Fatal JVM error indicates a fatal error occurred, such as stack overflow. Here you can see errors, and errors are connected to any or critical, and in critical you can see the types unknown, transformation, routing, connectivity, and it has subtype connectivity is connected to retry exhausted, and connectivity and expression and security. Security has client security and server security. In the critical errors you can see a fatal and overload. Here you can see how resources exported by Mule artifact.json are applied within the app in Mule runtime. In the class loading isolation mechanism, once APIs are clearly defined, you can prevent access to internal classes of artifact and only make the public API accessible from outside. To protect the API, Mule for users the custom class loading mechanism. Consider the and the following mule-artifact.json descriptor file for the extension here. The following diagram shows how resources exported by Mule artifact.json are applied within the app. Artifact class loader, a regular Java class loader pointing to a Java files included in the extension. This class loader loads all files and classes of the extension. Artifact filtering class loader, a wrapper created over the artifact class loader which enforces access restriction to the extension code for the foreign artifacts app or other plugins. It uses the content of the mule-artifact.json descriptor to determine what is public. Extension code. The Mule extension code uses artifact class loader which does not have any restriction, and it is only able to locate resources of the plugin itself. Application code, the Mule app code, it uses the artifact filtering class loader of the extension to prevent the app from accessing restricted code or resources. Here you can see application code is connected to artifact filtering class loader via load resources, and artifact filtering class loader is connected to application descriptor via filter with, and the artifact class loader is connected to artifact filtering class loader is connected to artifact class loader via delegates to, and extension code is connected to artifact class loader via load resources. Here you can see a simple flow in Design Center in Mule flows in Mule runtime. Understanding the basic flow architecture is the key to understanding a Mule application. Essentially, every Mule flow contains a series of Mule components that receive or process messages. At the simplest level, flows are a sequence of processes. A message that enters a flow can pass through a variety of processes. In a typical flow, a Mule application receives a message through a source such as an HTTP listener component, transform that message into a new format, and process any business logic before writing the process message to an external system in a format that the system can read. To separate processing into more manageable units, Mule applications often contain multiple interrelated flows instead of just single flow. One flow can call another flow as a direct reference. Here you can see HTTP listener /source is source the payload any attributes HTTP request attribute, and HTTP listener is connected to transformed data view. Here payload object and attributes HTTP request attributes, and transform data view is connected to database connectivity and insert payload statement result attributes HTTP request attributes, and database connectivity insert is connected to logger info, payload is statement result. Here you can see async scope in Mule runtime. The async scope is a branch processing block that executes simultaneously in the main flow. The main flow continues to execute while it initiates and processes the async scope. The flow does not have to pause until the last message processor embedded in the asynchronous flow has completed the task. Async can be useful for executing time-consuming operations that do not require you to send a response back to the initiating flow, such as printing a file or connecting to a mail server. To facilitate simultaneous branch processing, async scope send one copy of the message it has received to the first embedded message processor in its own processing block. At the same time, it sends another copy of the message to the next message processor in the main flow. Because the async scope is executed in fire and forget manner, the result of the processing within the scope is not available in the main flow. Here you can see the message process is connected to scope here. The async here you can see async scope and embedded asynchronous processing block. Here the scope is connected to the processing block and next processing block, and here the scope is connected to the main flow here, the next processing block. Here you can see a batch processing architecture. The Mule batch processing components prepare records for processing in the batches, run processes on those records, and issue a report on the result of the processing. Record preparation and reporting take place within the batch job component. Processing takes a place within one or more batch step step components, and optionally a batch aggregator component within a batch step component. Processes you place within a batch processing components act on records. Each record is similar to a Mule event. Processes can access, modify, and route each record payload using a payload keyword, and they can work on Mule variables using vars. However, they cannot access or modify the Mule attributes from the input to the batch job component. Here you can see the Mule flow. Message source is connected to message processors, one or more. Message process are connected to batch job scope. Here the process record, and this is on complete. Here the batch job process records, and on complete is in batch job scope. Here the batch steps scopes are in process records. Here the record processors, one or more, is connected to batch aggregator, optional. And record processors and batch aggregator are in the here the batch step scope, and record process are in batch aggregator here, and batch scope step scope is connected to another batch step scope. Record process, one or more, are in the batch step scope, optional here. Report processor recommended is on complete. Here you can see batch job phases. Each time a batch job phases in Mule runtime. Each time a batch job component execute, the following phases take place. One, load and dispatch phase. Batch job component splits valid input into records and prepare the records for processing. This phase takes within a batch job component. Process phase. Mule components and connector operates within one or more batch step components in a batch job processes. Process records within a given batch job instance. Process within a batch aggregator component also occurred in the process phase. On complete phase, the batch job component issue a report object with the result of processing a batch job instance. Here you can see the phases: load and dispatch phase, process phase, and on complete phase. Here you can see the process phase in batch job phases in Mule runtime. The process phase begins after a load and dispatch phase finishes. Loading records to the queue and start execution of a batch job instance. In this phase, batch job components concurrently pull records of the configured size of the queue to process them. The default batch block size is 100. Within batch step component, processing takes place in parallel at the block level, but records within each block process sequentially by default. Mule uses auto tuning capabilities to determine how many threads to use and level of parallelism to apply. During this phase, processes within the components can access and modify the record using payload and vast Mule variables. The batch job component consumes records after all record processing finishes. So any transmission of the process records to an external server or service must take place within the batch job step or batch aggregator components. After processing records in a block, the batch step send the records back to the stepping queue, where the records wait for the next batch step component. This process continues until every record phase go through the every batch step component within the same batch job component. At the end of this phase, all records are consumed. They are not available for further processing by downstream processors in the Mule flow. Note that since the changes to records that take place within the batch aggregator component are not propagated outside of the batch aggregator component, changes are not visible to subsequent batch step component in the flow. As processing takes place, each record keeps a track of all the batch step components that process it. Here you can see the record stepping queue. Record stepping queue is connected to batch steps here. Here the batch is connected to batch step 1, and here the record processors are in batch step 1 here. Record processor is connected to next record processor and is connected to next record processor, and it is the last one is connected back to the record stopping queue, and here the record stopping queue is connected to batch step 2 likewise, then batch step 3 here, and also batch step 3 likewise here. Here you can see the behavior when a batch aggregator component sets a fixed size. By default, the batch job instance does not wait for all the queued records to finish the processing in one batch step component before making them available for processing the next batch step component. Configuring a batch aggregator component changes this behavior. Here's behavior when the batch aggregator component set a fixed size. The processor within the batch aggregator must be able to receive any array of records as inputs. Here each batch step component within the batch job component received one or more records blocks and start processing them in parallel. 2, after processing a record, batch step component send the records to the batch aggregator component for further processing. 3, here when set to process the fixed size, the aggregator component arrange the record into one or more blocks containing a specified number of records. If fewer records are available than the configured size, then the last block of record is smaller. 4, after processing records in a given array, the batch aggregator component send all the records back to the stepping queue. Here the record stepping queue is connected to batch step, and batch step is connected to aggregator fixed size, and it's connected to did the array of records reach its configured size. If it is no, it's connected back to aggregator fixed size, and if it is yes, it's connected to record stepping queue. Here you can see the behavior when batch aggregator component is configured to stream records in Mule runtime. Behavior when batch aggregator component is configured to stream records. When streaming, the batch aggregator component processes record as soon as it receives them, instead of putting them into record blocks. No record is exposed to the next batch step component in the flow until all records in the aggregator processes all records in the current batch step. The processor within the component must be able to accept an array of records as input. Each batch step component receive one or more record blocks and start processing them in parallel. After batch step processes a record, the batch step send the record to the batch aggregator for further processing. The batch aggregator component continues processing record until there are no more records in the stepping queue that are awaiting to be processed by the current batch step. For the batch aggregator component send all aggregated records to the stepping queue. The Mule retains a list of all records succeeded or fails processed through each batch step, and in the event of processor in a batch step fails to process a record, Mule continues processing the batch, skipping over the failed record in each subsequent batch step process step based on the accept policy. The batch step component provide the max fail record property for setting the number of record that can fail before the batch step stops. Here you can see record stepping queue is connected to batch step. Batch steps is connected to aggregate streaming, and it is connected to any records in the queue for this step. If it is no, it's connected to back to aggregator streaming. If it is yes, it's connected to these records are connected to record stepping queue. Here you can see schematic diagram of a choice router with 3 options, one being the default option. In Mule runtime, the choice router dynamically routes messages through a flow according to a set of data view expressions that evaluates message content. Each expression is associated with a different routing option. The effect each expression is associated with a different routing option here. The effect is to add conditional processing to a flow similar to a if then else code block in most programming languages. Only one of the routes in the choice router executes meaning at the first expression that evaluates to true triggers the route execution, and the others are not checked. If none of expressions are true, then the default route executes. Here you can see a choice, and choice is connected to routing options here, and here the default routing option. Here you can see the order of processing when one flow references another in Mule runtime. The flow reference routes the Mule event to another flow or subflow, executes all processes in the reference flow, and then routes the event back within the same Mule application. The following diagram shows the order of processing when one flow references another. When the main flow is triggered, the Mule event travels through and then execute the flow until until the event reaches the flow reference. Event then travels through and execute the reference flow from beginning to end, and then returns to the main flow. This process enables you to treat the entire reference flow like a single component in your current flow. This flow reference breaks the Mule application into discrete and reusable units. For example, a flow that lists files on a regular basis might reference another flow that processes the output of the list operation. Instead of appending all the processing steps to the flow that lists the files, you can append the flow reference that points to the processing flow. Here you can see the main flow and here the reference flow. Here 1, 2, then flow reference, and then 3, 4, 5, then 6, then 6, 7. Here you can see on error propagate in on error components in Mule runtime. Executes but propagate an error to a higher level, such as containing scope. For example, a flow that contains try scope where the error occurs, or external flow containing the flow reference to the flow in which the error occurs. The error breaks the owner's execution and propagate to that high level, causing a failure at the level. In addition to any transaction, the owner handle is rollback. However, note that the transaction is not rollback if another component, one that does not own on error propagate, created the transaction. Here the try scope and on error propagate is in the flow. Here the flow error handler. Here the one is connected to 2 and 2, 3, and others are in the try scope here. 2 is connected to 3 and 3 In 3 error is moved to 4 in the error propagate, and 4 is connected to 5 on error propagate, and then the 6 then this is 6 in error flow handler, and 6 is connected to 7 in error flow handler. Now we are considering architecture in scheduler endpoint trigger in Mule runtime. Like other Mule event source component, the scheduler is the first component in the Mule flow. The XML for the scheduler consists of the following element: scheduler, the top level element of the scheduler, scheduling dash strategy, second level element that accepts one of the following children: fixed frequency for common scheduling frequency such as every second, cron, the cron expressions and time zone settings. Scheduler sets a scheduling strategy at a fixed frequency or interval based on the cron expression. For example, fixed frequency setting in the scheduler execute every 15 seconds. Cron expression or the cron expression in a scheduler triggers the generation of Mule message in a new execution of the flow every 15 milliseconds. At least one processor must follow the scheduler. Processors include Mule components and connect operations such as HTTP request operation or transform message component. Failure to provide the processor produces a Mule runtime exception and causes the deployment of the Mule application to fail with the following error message in logs: error Mule runtime exception, the content of the element flow is not complete, etc. Here the scheduler and processors are in the flow example here, and this is error handling. Schedule is connected to a processor, and processor is connected to the another processor here. Here you can see the behavior of scatter gather component in Mule runtime. Scatter gather component is a routing event processor that processes a Mule event through different parallel processing routes that contains different event processors. Each route receives a reference to the Mule event and execute the sequence in one or more event processors. Each of these routes use a separate thread to execute event processors, and the resulting Mule event can be either the same event processors, and it can be either same event without modification, or a new same event, or the new Mule event with its own payload, attributes and variables. The scatter gather component then combines the Mule events returned by each processing route into a new Mule event that is passed to the next event processor. Only after every route completes successfully. The scatter gather component execute each route in parallel, not sequentially. Parallel execution of routes can greatly increase the efficiency of your Mule application and may provide more information than sequential processing. The scatter gather component works with repeatable streams. It does not process non-repeatable streams, which can be read only once before they are lost. By default, all streams are repeatable in Mule unless the component stream strategy is configured to be non-repeatable. The following diagrams details the behavior of the scatter gather component. The scatter gather component receive a Mule event and send a reference of this Mule event to each processing route. Each of the processing route start executing in parallel. After all processors inside the route finish processing, the route returns a Mule event, which can be either the same Mule event without modification, or the new Mule event created by processors in the route as a result of the modification applied. 3. After all processing routes have finished the execution, scatter gather component create a new Mule event that combines all resulting Mule events from each route and then passes the new Mule event to next component in the flow. Warning: configure your scatter gather component to have at least 2 routes. Otherwise, your Mule application throws an exception and does not start. Here, Mule event is connected to scatter gather component, and here the it's break into event processes. Here you have 3 event processes, and event process connected to Mule event again. Connected to Mule event here. Here you can see the REST Studio project in APIkit anatomy in Mule runtime. The REST SOAP Studio project that uses APIkit has the following parts. REST SOAP interface, the main flow and backend flows. The REST interface, the relationship between REST resources and actions is called resource action pairing. The interface exposes internal data assets requested by the REST service. Also, the interface defines the API designing resources that contain or access and specify actions such as get and put on the example data. Here you can see API console interact with RAML. Here you can see the flows, API main, and the listener and the router error handling. Here the flow 1 and here the flow 2. Here you can see the SOAP Studio project in APIkit anatomy in Mule runtime. The SOAP interface, the interface defined by WSDL file exposes the number of services. Each service has a set of operations. Underlying types of data is XML defined by schemas within WSDL file or by an imported XSD file. Here the main flow for the API manages these functions, exposes API using Anypoint connector for HTTP connector, routes requests between interface and backend flows based on the HTTP request, accept requests and send and facilitate communication between interfaces and API processes. The main flow consists of HTTP listener, API kit REST or SOAP router components. APIkit router is the key message processor that validates the request against the provided definition, enriches messages, for example, by adding default values to the messages, and routes requests to the particular flow. And also routerizes error messages if errors occurs while routing, validating, or processing the user request. Backend flows, APIkit for REST generate a backend flow for each resource action pairing in the RML file. In the APIkit for SOAP generates backend flow for each operation in WSDL. Here you can see SOAP UI interacts with WSDL, and here the main flow. Here the main flow, and here the listener and the router. Here the flow 1, flow 2. Here you can see RAML scaffolding in Mule runtime. Start a new API project using an API definition file. Use this method if you want to start a project by either importing an existing RAML or WSDL file, or by referencing the file URL. Select file, then new, then Mule project. The 2 in the project name, enter the name of the project for the export, for the example my project, and select or accept the default EE runtime, for example Mule server 4.0.0 to 4.2.0 EE. In the implementation, select specify API definition file location or URL. In location, do one of the following. If you created an api.raml file in design center, select design center, log into Anypoint platform if necessary, and select API.rml. If you didn't create a RML file in Design Center, select Browse Files and select the RML or WSDL file that you created. If you didn't create RML file in Design Center, select Browse Files and select RML or WSDL file that you created in the text editor. For a WSDL file, select a service and port from the drop down menus and accept the default. Then accept the location default options and click File. Click Finish. Using this method, APIkit scaffolding technique generates an archetype that contains basic configuration files plus the Mule XML configuration file, an implementation of API. For RML based APIs, RML file appears under source main resources API folder. The implementation of the API contains the main flow with the HTTP listener, APIkit router component, error handlers, RML dependencies, push or pull changes from one location such as Studio to the other such as Design Center, backend flows containing REST resource action mappings. For WSDL based APIs, the WSDL file appear under the source main resources API folder. Implementation of the API contains a SOAP router, and other components. Here the RML based API, the RML file appears under source main resources API folder. The implementation of API contains the main flow with the HTTP listener, APIkit router component, error handlers, RML dependencies, push and pull changes from one location such as Studio to other such as Design Center, backend flows containing REST resource action mappings. Here you can see RML is connected to scaffold. Scaffold is connected to the API main. Here listener is connected to APIkit router, and APIkit router is connected to here, and you can see here error handling. Here the main API, and here the listener and router and error handler. Here you can see WSDL scaffolding in Mule runtime. For WSDL based APIs, WSDL file appears under source main resources API folder. In the implementation of the API contains SOAP router, SOAP fault response template, backend flows containing SOAP messages templates. Here the WSDL is connected to scaffold. Scaffold is connected to the API main. Here the listener is connected to the SOAP router, and SOAP router is connected to here, and the you can see the error handler here. This is XML config, and here you can see the API main, and here the listener, and here the router. Here the API main is connected to XML config. Here you can see the setting a target variable. Target variable changes the typical course of message through a flow in enrich data with target variables in Mule runtime. Here the normally an operation outputs a different message than it received as input. Here the original payload is connected to component A. Component is A interacts with payload modified by A. Component A is connected to B via payload modified by A, and component B is producing output via payload modified by B. Here you can see the setting a target variable changes the typical course of message through the flow in enrich data with target variables in Mule runtime. Here the In this case, the component C receives the same message that B received from A. However, when you set a variable from an operation, the operation outputs to the next component in the flow the same message that is received as input. For example, assume you have a flow consisting of component A followed by component B with the target value of my message. Then the component C and then component C. In this case, the component C receives the same message that B received from A. Here the original payload is connected to component A. Component A is connected to component B via payload modified by A. Component B is connected to set target message, set target my message. Here the component B is connected to component C via payload modified by A. Now we are considering configuring target variable affects the behavior of existing variables. In enriched data with target variables in Mule runtime, existing variables retain their original values after an operation with the target variable finishes processing. For example, consider a flow where you set variable 1 and 2 and then operation modifies the variable 1 and 2 and also outputs the target variable A. In this case, after the execution of the operation, variable 1 and 2 returns to their previous values. Because the component set a target variable, variable 1 and 2 revert to their previous values after execution of the component. Original payload is connected to set variable 1. Set variable 1 is connected to set variable 2. Set variable 2 is connected to component modified variable 1 and 2, and it is connected to set variable A, and component modified variable 1 and 2 is connected to interacts with original payload, and it produces here. Now we are considering architecture in configure shared resources in Mule runtime. A Mule domain project in Anypoint Studio has following key files. The source main mule domain config.xml. This is the shared resource configuration file. This file must have a mule domain config.xml file name. pom.xml. This is the dependencies file descriptor. It is a maven pom file required plugins for the domain projects. Mule-artifact.json. This file descriptor. This file is a descriptor for domain artifact. Here you can see the consuming REST API flow in Mule runtime. The Mule application consuming REST API consists of the following: one or more message process configured to build your request. An HTTP request operation configured to call REST API, and one or more message processors configured to accept and process the response. Here you can see the consuming REST API flow. You configure the portions of the application that build the request and process the response. Here you can see consume REST API. REST API here build the request. In listener, the VM listener and transform message are in build the request. Here the listener VM listener is connected to transform message is connected to request is in call the REST API. Request is connected to transform message and write are in process the response, and transform message is connected to write. Here you can see what happens when an event processor such as an HTTP request or database operation throws an error. In messaging errors in configure error handlers in Mule runtime, Mule throws an messaging error, a Mule error whenever a problem occurs within the flow of the Mule app, where the Mule events and the messages are the messages they contain are processed. You can handle Mule messaging errors in more than one way. You can rely on the default error handling mechanism. Within the flow, you can set up on error components, on error continue and on error propagate inside the flow built in error handle component. This component can contain any number of components to process the error. The following here figure shows what happens when an event processor such as an HTTP request or database operations throws an error. Outside the flow, you can set up error handler component and reference it from other error handler configurations. The global error handler can contain on error component and their contents. It is possible to set up error handling from within try scope that reside in the flow. The scope contains a built-in error handler in which you can configure on error components and their contents. Here you can see the flow, and event source is connected to the event processor is connected to another event processor, and so there's another one here, and there's an error, and then event processor is connected to the event processor in on error is connected to the another event processor in on error, and on error is in error handler is and error handler and event source and other event processors here are in the flow. Here you can see synchronous logging in Mule runtime. By default, Mule logs messages asynchronously. When logging synchronously, the execution of the thread that is processing your message is interrupted to wait for the log message to be fully handled before it can continue. Here you can see thread and you can see here logging, and then let's continue here. Here you can see asynchronous logging in Mule runtime. When logging asynchronous, the logging operation occurs in a separate thread, so that the message can process before the logging completes. In most situations, Mule recommend that you use asynchronous logging because the substantially improves the throughput and lowers the latency of the message processing. When asynchronous logging is used, some actions might be logged if there is a system crash. The situation occurs because log writing is performed on separate thread that runs independently of other actions. If you use app logs as audit trails, configure your app to always use synchronous logging. This prevents the loss of any log messages. Mule 4 introduced thread local functionality to optimize the memory usage of log4j. To enhance the use of this feature, you can set the system property async logger config ring buffer size 20,000 is the suggested value, but you need to tune it to meet your needs. Here you can see the thread is going on. This is logging is in the separate thread here. Here you can see performance tests in configure logging in Mule runtime. The chart here shows the performance difference between synchronous and asynchronous logging. How much latency is increased as more concurrent messages were added. In this test, the app logged about 1 million messages. Using an increasingly higher amount of thread on each run, each transaction resulted 1,000 messages. As indicated by the chart, the result of logging asynchronously are significantly closer to the result of asynchronously here. As indicated by the chart, the result of logging asynchronously here are significantly closer to the result of not logging at all. Here you can see the asynchronous logging, here no logging, and here the synchronous logging. Here you can see a reliability pattern couples a reliable acquisition flow with an application logic flow as shown in this diagram in Mule runtime. A reliability pattern is a design that results in a reliable messaging for an application, even if the application receives messages from a non-transactional connector. A reliability pattern couples a reliable acquisition flow with an application logic flow as shown in this diagram. Reliable acquisition flow, the left side of the diagram here, delivers a message reliably to the Mule event source that does not implement the transaction to an outbound operation of a connector that implements the transaction. The operation can be of any type of transactional endpoint such as VM or JMS. Such as if the reliable acquisition flow cannot deliver the message, it ensures that the message isn't lost. The socket-based connections like HTTP, this means returning the unsuccessful response to the client so that the client can retry the request. For resource-based connections like file or FTP, it means not deleting the file so it can be reprocessed. The application logic flow, the right side of the diagram delivers the message from the event source that uses transactional connector to the business logic for the application. Here you can see the request is client is connected to the HTTP via request, and here the HTTP is connected to the client is connected to the receive message via request, and it's HTTP, and receive message is connected to the client via state response, and here the receive message is connected to the add message queue, so the VM, and add message queue is connected to the VM. Receive message and add message queue and are in reliable acquisition flow, and VM is connected to the application, connected to the consume message from queue VM here, and the consume message from queue flow of ref to business logic subflow, and add message queue are in application logic. Here the consume message from queue is connected to the flow ref to the business logic subflow, and it's connected to the add message to queue, and it's connected to the VM. Here the transaction one here. Here you can see a reliability pattern where the reliable acquisition flow delivers a message to a JMS endpoint. You can couple reliable acquisition flow with any type of transactional endpoint. You don't have to use VM endpoint in reliability pattern. The following this diagram illustrates reliability pattern where reliable acquisition flow delivers a message to an JMS endpoint. And also we can use the file-based VM standalone Mule, provided easy to use with Mule. There is no need for additional software. Applies only to non-clustered environment. We can use the we can have a JDBC as endpoint. Depending on the resource available, JDBC can hold a large amount of information. Requires additional software. Database server can be complex to use since property DBMS. Schemas required, and I can use the endpoint as JMS like here. Enable for persistence, apply to both clustered and non-clustered environment. Requires additional software. Message queue server. Note the comparison doesn't include any in-memory persistence setup for VM and JMS because they can lose messages that are not considered reliable. Here the client is connected to the receive message via request. Receive message is connected to the client via status response. Receive message and add message to queue are in reliable acquisition flow. Receive message is connected to the add message to queue, and it's connected to JMS. JMS is connected to consume message from queue, and it's connected to flow ref to business logic subflow, and it's connected to add message queue. Consume, and it's connected to JMS. Consume message queue, ref to business logic subflow, and add message to queue in application logic flow transaction 1. Here you can see performance test invoice structure. In separate host avoid interference in Mule runtime. Here is used a control environment. Use a self-control environment to obtain repeatable, reliable and consistent data. Use an infrastructure made by Triplet. Use a dedicated host for Mule application to isolate the app information, preventing other running processes from interfering the result in the case of on-premises test. Use separate dedicated host for running load client tools that can drive the load without becoming a bottleneck. Use separate dedicated host on to run backend services like database, Tomcat, JMS, ActiveMQ, and so on. Test using the same host that the application uses in production. For the on-premises test, run the load client runtime server and backend in the same Anypoint virtual private cloud, Anypoint VPC to decrease the network latency. For CloudHub test, run the load client and backend server on dedicated machine that is separate from but in the same region as the CloudHub worker to decrease the network latency. Use a wired stable network. Don't use your laptop because it may outperform the same application deployed to a customer's environment, particularly if it is virtualized. Here you can see the performance test infrastructure here. Here you can see a load client, Apache JMeter, Gatling, Apache Benchine load client, and load client is connected to Mule. Mule is connected to a backend. Here MySQL, Apache, RabbitMQ, JMS in backend. Now we are considering Mule high availability in cluster runtime instances. In Mule runtime, the Enterprise Edition. Mule High Availability provide basic failover capability for Mule. When the primary Mule instance become unavailable, for example, because of a fatal JVM or hardware failure, or it's taken offline for maintenance, backup instance immediately become primary node and resumes the processing where failed instance left off. After system administrator has recovered the failed Mule instance and both it back the online, automatically becomes the backup node. The seamless failover is made possible by the distributed memory store that shares all transient state information among clustered Mule instances such as SCADA service event queues, in-memory message queues. Mule High Availability is currently available for following transports: HTTP including CFX web services, JMS, WebSpare MQ, JDBC, file FTP, clustered replaces local VM transport. Mule High Availability is available with Mule Enterprise subscriptions. Here the web portal or REST and web services .NET or HTTP and applications are connected to reverse proxy server, and reverse proxy server is connected to Mule Active here. Mule Active interacts with Mule Passive here, and JMS database and file FTP and SFTP are connected to Mule Active here. Here you can see JMS queues in cluster runtime instances in Mule runtime. JMS can be used to archive HA and FT by routing messages through JMS queues. In this case, each message is routed through JMS queue whenever it moves from component to component. Pros easy to do, well understood by developers. Cons require a lot of transactions, and transaction can be complicated. Performance hit if you are using XA. Here you can see the Mule server in a cluster, and transport is connected to inbound router via external queue, and inbound route is connected to service component via external queues, and service component is connected to outbound router via external queues, and outbound route is connected to transport via external queues. Here you can see the example in load balancers. In cluster runtime instances in Mule runtime, load balancers simply route requests to different servers based on the current load of each server and which servers are currently up. Load balancers can be a software or hardware based. This approach commonly used in clustered databases. Pros straightforward to do, well understood by developers, and cons not a complete solution on its own, doesn't provide fault tolerance. In this example architecture, HTTP requests come through a load balancer and are immediately put on a JMS queue. JMS queue is clustered between different servers. A server will start processing a message of the JMS queue and wrap everything in a transaction. If the server goes down, the transaction will roll back and another server will pick up the message and start processing. Note the HTTP connection is open for duration of this process. This approach will not work as load balancer will not transparently switch connections between servers. In this case, HTTP client will not will need to retry the request. Here the HTTP with load balance is connected to cluster JMS queue, and it interacts with the transaction, and server 1 and server 2 are within the transaction here. Now we are considering handling stateful components in cluster runtime instances in Mule runtime. While most applications can be supported by different techniques, some require sharing state between JVMs more deeply. One common example of this is an aggregator component. For example, assume you have aggregator that is aggregating messages from two different producers, producer 1, and send the message to the aggregator, which received it and hold it in the memory until producer 2 sends the message. If the server with the aggregator doesn't goes down between between producer 1 sending a message and producer 2 sending a message, producer 2 can't just send the message to the different server because that server will not have the message from producer 1. Solution is to this is to share the state of the aggregator component across different machines through clustering software as Terracotta, Oracle Coherence, JGroups, etc. By using one of these tools, producer 2 can simply fail over to a different server. Note that the MuleSoft has not tested Mule with these tools and does not officially support them. Pros works for all clustering cases, can work as a cache as well. Cons not officially supported by MuleSoft, required performance tuning to get things work efficiently. Here producer 1 and producer 2, number 2 is connected to aggregator, aggregator is connected to some other component. Here you can see a Mule runtime high availability HA cluster overview in cluster runtime instances in Mule runtime. Important for an equivalent to clustering in CloudHub. See the CloudHub HA in the documentation for details about how workers can be shared or doubled to scale your application and provide high availability. Mule Enterprise Edition supports scalable clustering to provide high availability HA for applications. A cluster is a set of Mule runtime engines that act as a unit. In other words, a cluster is a virtual server composed of multiple nodes, Mule runtime engines. The nodes in a cluster communicate and share information through a distributed shared memory grid. This means that data is replicated across memory in different machines. Incoming messages, here the outgoing messages. Here the nodes distributed shared memory interacts with nodes. Distributed shared memory and cluster nodes are in cluster. Cluster has incoming messages and outgoing messages. Contact your service representative about pricing of this feature. Here you can see the node 1 processes message 1 while node 2 simultaneously processes message 2. In benefits of clustering in cluster runtime instances in Mule runtime. By default, clustering Mule runtime engines ensures higher system availability. If a Mule runtime engine node becomes unavailable due to failure or planned downtime, another Mule in the cluster can assume the workload and continue to process existing event and messages. Following figure illustrates the processing of incoming messages by a cluster of 2 nodes. Notice that the processing load is balanced across the nodes. Node 1 processes the message 1, and node 2 processes while node 2 simultaneously processes the message 2. Here you can see the client, and client is connected to the cluster via message 3 and 4 here. While the node 1 processes message 1 and node 2 processes message 2 here. Node 1 and node 2 are in cluster here. Here you can see if node 1 process if node 2 fails, node 1 processes both message 1 and 2. If node 1, in benefits of clustering in runtime, cluster runtime instances in Mule runtime, if node 1 fails, the other available nodes pick up the work of the failing node. As shown in the following figure here, if node 2 fails, node 1 processes both message 1 and message 2. Here client is connected to the cluster via message 3 and message 4, while message 1 and 2 when node 1 is processing message 1 and 2, and node 2 is failed here, and node 1 and node 2 are in the cluster here. Here you can see Mule runtime HA clustering, how the workload sharing in more details in cluster runtime instances in Mule runtime. Because all nodes in the cluster of Mule runtime engines process messages simultaneously, clusters can also improve performance and scalability. Compared to a single node instance, clusters can support more users, so improve application performance by sharing their workload across multiple nodes or by adding nodes to the cluster. Following figure illustrate the workload sharing in more details. Both nodes process messages related to order fulfillment. However, when one node is heavily loaded, it can move the processing for one or more steps in the process to another node. Here, processing of the process order discount step is moved to node 1, and the processing of fulfill order step is moved to node 2. Beyond benefit of such as high availability through automatic failover, improved performance and enhanced scalability, clustering Mule runtime engines offer the following benefits. Beyond automatic coordination of access to resources such as files, databases, and FTP resources, the Mule runtime engine cluster automatically manages which Mule runtime engine will handle communication from the data source. Automatic load balancing of processing within a cluster. If you drive your flows into a series of steps and connect these steps with a connector such as VM, each step is put in a queue, making it cluster enabled. The cluster of Mule runtime engines can then process each step in any node to better balance the load across nodes. Raised alert, you can set up an alert to appear when a node goes down and when the nodes come back up. Not all Mule runtime engines in a cluster activity process messages. Note that each Mule node is internally scalable. A single node can scale by taking advantage of Mule cores. Mule operates as a single node in a cluster even when it uses multiple cores. Here you can see the message 1 path of the message 1. Here you can see the path of the message 2. Here the message 1 is connected to receive order. Order is connected to process order discount, and process order discount is connected to fulfill order. Here the message 2 is connected to receive order, and my receive order is connected to process order discount, and process order discount is connected to fulfill order. Here the receive order, process order discount, and fulfill order in the node 1. Here receive order, process order discount, and fulfill order are in node 2. Here node 1 and node 2 are in the cluster. Here you can see the cluster design and management. In cluster runtime instances in Mule runtime. Anypoint runtime manager enables you to set up a cluster of Mule instances and then deploy an application to run on the cluster. You can also monitor the status information for clusters and individual nodes. When clustered, you can easily manage several servers as well. Mule cluster consists of 2 or more Mule runtime engines or nodes grouped together and treated as a single unit. With the initial configuration, MuleSoft recommends that you scale a cluster to more than 8 Mule runtime engines. With the Anypoint Runtime Manager, you can deploy, monitor, or stop all the Mule runtime engines in a cluster as they are in a single Mule runtime engine. All the nodes in a cluster share memory as illustrated below here. Mule users an active model to cluster Mule runtime engines. The benefit of this model over an active passive approach is that your Mule application run in all nodes, splitting message processing with other nodes in the cluster, which expedites the processing. Here, incoming messages are connected to a node 4 cluster here. Here, the nodes and shared memory are inside the cluster here. Node 1, node 2, node 3, and node node 1, node 2, node 3, and node 4 are interacting with shared memory here. Here the 4 node cluster is connected to outgoing messages. Now we are considering here the cluster can potentially process a single message on the multiple nodes as it passes through a VM points in the application flow as illustrated here. In queues in cluster runtime instances in Mule runtime, you can set up a VM queue explicitly to load balance across multiple runtime engines nodes. Thus, if your entire application flow contains sequence of child flows, the cluster can potentially process a single message on a single child flow to whichever Mule runtime engine happens to be available at the time. The cluster can potentially process single message on multiple nodes as it passes through VM endpoints in the application flow as illustrated here. Here you can see the Mule application deployed to 4-node Mule cluster. Here flow this interaction with flow A. Flow A is connected to flow B async. Flow B is connected to flow C async, and flow C is connected to flow D async, and flow D is connected to flow A. Here the flow node Mule cluster designed for load balancing across nodes. Here the node number 1 available and is connected to node 2 number 2 available, and is connected to node 4 4 available, and he is connected to node number 3 available. Other nodes are BC here, and here these nodes are in the cluster. Now here you can see the deploying Mule for HA and DR strategies in cluster runtime instances in Mule runtime. You can deploy the Mule runtime in many different topologies to address your HA or DR strategies. One method is through the use of clustering, which is described. One method is use of clustering. Mule high availability clustering provides the basic failover capability for Mule. When the primary Mule runtime becomes unavailable, for example, of a fatal JVM or hardware failure, or it is taken offline for maintenance, the backup Mule runtime engine immediately becomes the primary node and resumes processing where the failed instance left off. After a system administrator recovers the failed Mule runtime server and puts it back online, that server automatically becomes the backup node. Seamless failover is made possible by distributed store that distributed memory store that shares all transient state information among clustered Mule runtimes, such as SCADA, service event queues and in-memory message queues. As you build your Mule application, it is important to think critically about how best to architect your application to achieve the desired availability, fault tolerance, and performance characteristics. Here the incoming messages are passed to cluster. Here the Mule and distributed shared memories are in the cluster, and distributed shared memory mules are connected to mules interacts with the distributed shared memory. Mule and distributed shared memory are in the cluster, and cluster is outputting outgoing messages. Here you can see cold standby in high availability options in cluster runtime instances in Mule runtime. The Mule environment is installed and configured. However, one or more operating systems are not running. This can be a backup of a production system or virtual machine. The environment of the operating system plus the Mule runtime has been started after an outage is detected. Downtime sum the time it takes to start the environment and direct traffic. Here this running one and here the down one. Here you can see the worm standby in high availability options in cluster runtime instances in Mule runtime. The Mule environment is installed and configured. However, the Mule runtimes are not running. Only the operating systems. Mule runtime is started after an outage is detected. Downtime a little. The time it takes for the Mule runtimes to start and to route traffic to the environment. Here it's running and here the Mule is down here. Now we are considering hot standby, active, passive. The Mule environment is installed and configured and fully running. However, it's not processing request until an outage is detected. Downtime minimal to none. Time to route traffic to an environment. Here you can see it's running here. Here you can see active model. Active in high availability options in cluster runtime instances in Mule runtime. The load balance clustering environments, there are 2 or more Mule environments, and each environment has its own cluster that are fully operational. The load balancer is directing traffic to all of the environments. There is no service downtime, and downtime is none. There is no service downtime. Here you can see the load balancer is connected to the Mule and OS here. Mule and OS interacts with the Mule and OS here, and the here you can see the Mule and OSs are in the cluster here and in the cluster here. Here the load balancer load balanced single clustered environment. There are 2 or more Mule environments. However, they are part of the same clustered environment. To achieve this scenario, the network latency between the environments must be less than 10 milliseconds. Downtime none. There is no service downtime. Here load balance is connected to the Mule environment, 2 Mule environments. Mule environments are in the and the OS are in the cluster here. Here you can see the active clustering deployment model in high availability deployment models in cluster downtime runtime instances in Mule runtime. It is possible that 2 nodes in a clustered or load balanced environment can support 1500 TPS with the 1 second responses. In this state, the normal operation of the SLA is being met. If a node fails, the service is impacted. However, the impact does not breach the SLA because the node is able to handle 700 TPS with 1 second responses, well above the agreed upon the accepted impact level. Distribute the load evenly among the multiple Mule nodes. All nodes have the same capabilities. All nodes are active at the same time. Cost vary depending on the SLA requirements. This model needs 2 nodes to satisfy SLA. If the SLA acceptable service impact changes to the terms stated in the normal operations, and then at a minimum the environment will need 3 nodes to accommodate 1 node failure. More nodes may require depending on the probability of not having the last 2 nodes running. Here the consumer interacts with the load balancer. Load balancer interacts with the Mules here, and Mules and the OS are in the cluster here. Now here you can see active clustering fault tolerance deployment model in high availability deployment models. The basic definition of fault tolerance is a failure within the system does not impact the service at all. This differs from the high availability as service impact and downtime is tolerated. Fault tolerance differs from the high availability by providing additional resources that allow an application to continue functioning after component failure without interruption. Fault tolerance environments are more costly than high available environments. The degree of fault tolerance requires the probability of the system failures. Take the SLA example highlighted under the high availability and makes the minimal acceptable service impact level match the normal operation requirements. The new overall SLA now requires the system to be able to handle 1000 transactions per second with 1 sec response times, 0 downtime, and 0 service impact time. Zero service impact. It is if the probability of having more than one node fails is low, then the architecture would simply require 3 nodes. However, the probability of probability of more than one node is higher than acceptable. More than 3 nodes are required to accommodate the multiple failures here. More costly due to required redundant in order to meet the defined SLA. Here consume interacts with the load balancer, load balance interacts with the mules here, and here's this mule is fails, and here the redundant replacement node here, and here you can see the nodes are in the cluster, and here you can see the 0 downtime deployment model. The 0 downtime deployment model in high availability deployment models in cluster runtime instances in Mule runtime. The goal is to be able to quickly make changes to the environment without impacting SLAs, including upgrading infrastructure and applications running on the infrastructure. Typically, 0 downtime deployments leverage a side-by-side deployment where the old and new coexist for a short period of time. This is in contrast to an in-place deployment where the service may experience reduced capacity to complete downtime. Gartner defined the continuous operations as those characteristics of data processing system that reduce to eliminate the need for planned downtime, such as scheduled maintenance. One element of 24-hour a day, 7-day-a-week operation. Baseline production environment is the current operating system. A new environment is created with the changes, upgraded times, configuration, new application, etc. A small percentage of traffic flows to the new environment and creates as the confidence in the new environment increases. Baseline production environment continues its use until the new environment is fully operational. It is handling 100% of the traffic. Once the new environment is accepting all traffic, it becomes a new baseline production environment. Environment and the previous baseline production environment terminates. This example below here, this is assuming that each environment is using the same number of Mule runtimes and cores. It is possible that the new environment may have more or less number than the baseline environment. Here the deployment step. Here the new production environment deployed, and a small percentage of traffic is routed to the new environment. Here the consume is connected to the router, and router is connected to here 94 route considered here this baseline production current environment via 90% of traffic. You can see the mule here, and here the route is connected to a new production environment via 5% of the traffic here. The mule and OS are here. In the deployment step, the confidence in the new environments continues to increase and more traffic is routed to it. Here the confidence of the environment is continuous and continues to increase and more traffic is routed to here. Here the consume interacts with the router. Here the router is connected with baseline production current environment with 5% of the traffic, and here the route is connected to the new production environment with 95% of the traffic. And the here the after traffic has been routed to the new environment. Here the after traffic has routed to the new environment. Here the route is connected to baseline production current environment with 0% of traffic, and here the route is connected to the new production environment with 100% of traffic. The all traffic here, the all traffic has been routed to the new environment, which has been promoted to the baseline production environment. The previous baseline environment has been terminated. Here you can see the consumer interacts with the route, and route interacts with the new baseline production current environment with 100% of traffic, and there's no the connection is terminated with the between route and the new baseline production with the baseline production current environment. The cost, this deployment method may temporarily add capacity to service, can be a few minutes, hours, or days. Here you can see a Mule event and message. The Mule 4 in Mule runtime, Mule 4 includes a simplified Mule message model in which each Mule event has a message and associated variables. A Mule message is composed of the payload and its attributes, metadata such as file size, variables was which hold the arbitrary use information such as operation results, auxiliary values, so on. In general, operations do not automatically propagate variables to other components like a listener. If you use the flow reference component, it does not propagate variables within flows. This is simplified message model takes it easier to work with data in a consistent way across connectors without overwriting information. Here you can see the Mule event and the message. Here you can see the Mule flow. Here the variables and Mule message are in Mule event, and attributes and payloads are in Mule message. Here you can see to use a new API instance for configuring an independent Mule runtime instance on Mule 4 in migrate using a new API instance. In migrating API gateways in Mule runtime, to use a high-level proposal illustrated in this diagram, to use a new API instance for configuring an independent Mule runtime instance on Mule 4 here. If your Mule application is not a proxy, the same proposal applies to your migration procedure without backend component. To migrate your Mule 3 API to Mule 4 using new API instance, from the API administration page in API Manager, select API, then create new API. Use an instance label to identify this new API instance. On the endpoint configuration window, select Mule 4 in Mule version and save. In the left navigation pane in the API Manager, apply alerts, SLA tiers, and policies to your API. If your API uses contract-based policies, for example, client ID, enforcement policy, migrate the contract of the API instance. If you completed configuring your API, start your Mule 4 application and try sending it request. After successfully validating your application, undeploy your Mule 3 application. Here you can see API Manager. Here the audit log instance A and audit log instance B are in API Manager. Here the API Manager interacts with Mule 3 proxy, and here the API Manager interacts with the Mule 4 proxy via connects to an instance. Here the load balancer is currently here the load balancer is connected to Mule 3 and Mule 3 proxy, and Mule 3 proxy is connected to backend. Here the load balancer is connected to Mule 4 and Mule 4 proxy is connected to the backend. Here you can see Mule message structure in Mule runtime. Here, not here. This here we examine the Mule message in the context of the flow rather than a batch job. If you please see batch processing in the documentation for more information about how messages in the batch jobs are broken up and processed as records. The Mule message is the data that passes through an application via one or more flows. It consists of two main parts: the message header, which contains the metadata about the message, the message payload, which contains the your business specific data. A Mule message is itself embedded within the Mule message object. Some Mule message objects may contain variables, attachments, and exception payloads. However, as attachments and exception payloads are not frequently used or manipulated, this overview is does not include the details about much about them here. Here the tip: if you have ever in depth about the structure of the message in a given step of the flow, you can easily check by using the Data Science Explorer. Here the inbound property and outbound property are in the in header. Payload and header are in message. Attachment variable and exception payload are in the message object. Here you can see the inbound properties. The inbound properties the inbound properties are immutable, are automatically generated by the message source and cannot be set or manipulated by the user. They contain metadata specific to the message source that prevents scrambling of data formats or other processing mishaps later in the message lifecycle. A message retains its inbound properties only for the duration of the flow. When the message passes out the flow, its inbound properties do not follow. See the image here. Here the inbound property prop1 is equal red is in the header and payload is in the message and message is in the message source, and the message source is connected to the next message connected to the message processor. Here the inbound property prop equal red and is in the header and payload is in the message and message is in the message processor, and message source and message processor are in the flow A here. Here the message processor is connected to the message source in flow B. Here the header is in the message and payload is in the header and the payload is in the message and message is in the message source and message source is connected to the message processor. Here the header is in the header and the payload are in the message and message is in the message processor. Here the message source and message processor is in the flow B here. Here you can see the outbound properties. Outbound properties are mutable. They are set during the course of a flow and can become inbound properties when the message passes from the outbound endpoint of one flow to the inbound endpoint of the different flow via transport. They contain metadata similar to that of the inbound property, but an outbound property is applied after message entered the flow. Outbound properties can be set automatically by Mule, a user can set them by manually inserting one or more transformer and elements in the flow. Note that if the message is passed to a new flow via flow ref rather than a connect, the outbound properties remain outbound properties rather than being converted into inbound properties. See the image here. Variables are defined metadata about the message. Variables have three scopes. Flow variables apply only to the flow in which they exist. Session variables apply across all flows within the same application. Record variables apply only to record process as part of a batch. Here the header is header and payload are in the message and message in the message source. Message source is connected to message processor. Here the outbound property prop1 equal blue is in the header, and header and payload are in the message, and message is in the message processor here. Message source and message processor is in the flow A. Here the message process is connected to the message source here in the flow B. Here the inbound property prop1 equal blue here, and it's in the header, and header and payload is in the message, and message is in the message source, and message source is connected to the message processor. Here the inbound property prop1 equal blue, and it's in the header, and the header and payload is in the message, and message is in the message processor. Here the message source and message processor are in the flow B here. Here you can see what is ESB, and here the ESB is there, and request service request is connected to ESB, and here service provider is connected to ESB. Here you can see point-to-point connection. Here the S1 is connected to S2, S3, and S4. Here S2 is connected to S1, S3, and S4. Here the S3 is connected to S1, S2, and S4, and S4 is connected to S2, S3, and S3 and S1. You can see ESB architecture. Here you can see the enterprise service bus, and messaging systems is connected to enterprise service bus. Here service bus is connected to legacy system mainframes are connected to service bus. Here here you can see the web services through web services. Here the web service connected to enterprise service bus via web services, and here the media service connected to enterprise service bus via web services, and here the e-commerce is connected to ESB via web services, and here the mobile DNS set is connected to ESB via web services. Here the legacy system mainframes are connected to ESB via web services, and here the mail server is connected to ESB via web services, and here the data bank is connected to ESB via web services, and here the FTP service connected to ESB via web services, and here the service connected to ESB via web services, and here the messaging systems are connected to ESB via web services. Here you can see the ESB, and ESB is a basically integration of a new and old new and the old, providing a central place for services, applications, and services, applications, and IT resources in general that you want to connect. Here you can see the enterprise service bus, a reliable asynchronous secure messaging here, and here the JMS here. So in the here the reliable asynchronous secure messaging, and JMS is inside in enterprise service bus. Here the ERP interacts with ESB via transformation XLX SLT and JCA. Here the .NET interacts with Enterprise Service Bus via SOAP and HTTP. Here the web services interacts with the ESB via SOAP and HTTP. Here the C and C legacy application interacts with the ESB via SOAP or HTTP. Here J2E interacts with the ESB via JMS. Here you can see microservice architecture versus legacy monolithic architecture. Microservice architecture versus a legacy monolithic architecture is an approach to developing software application as a series of small services, each running autonomously and communicating each other. For example, through HTTP requests to their APIs. Microservices have called it into question the future of ESB, but how does the new architecture trend really affect Enterprise Service Bus? It seems that microservice has arrived to stay. More and more CEOs want to install this type of architecture in their projects. Microservices are perceived as a future of doing business. Many believe it is a general change promoted by digital transformation and think that ESB is becoming obsolete. Are they right? Are microservices the new era of SOA? Definitely, you have to take them into account. But for ESBs, no, they are still available, still alive. We must adopt our concept of this. We must adapt our concept of this architecture and can no longer understand the integration bus as a centralized and inflexible concrete structure for the whole company. When we talk about them today, we should think flexible, scalable and well distributed infrastructure in which we can incorporate, implement and monitor any type of service in an agile and efficient way. The ESB must fulfill a function of integration, coordination, routing and monitoring of business activity. Understanding ESB is in this way we can build application through services and microservices to solve the requirement and needs of the company. The services must be treated in the individualized way with the standard interface to a platform with automatically scalable execution time. Thus, these services are decoupled and scaled in the linear fashion on non-specialized hardware. This is the best way to understand Enterprise Service Bus today. Microservices do not mean the death of ESB if the latter is used to be suitable way. That is to stay focused on the architecture where services are protagonist and not in the centralized architecture towards the integration bus itself. About this here you can see a monolithic application puts all its functionality into a single process and scales by replicating the monolith on multiple servers. Here the microservice architecture puts each element of the functionality into a separate service and scales by distributing these services across servers, replicating as needed. Here you can see a Mule ESB architecture. The Mule plays a special role as it is not a full JBI implementation, but only provides external JBI connectors, which can be used to integrate with other JBI environments like Service Mix. It is also not a typical ESB as is often stated. For example, in because it does not provide common messaging backbone as an associated back-end services, but more of a freely combinable mediation layer where components are not plugged in but stick together as needed. This is seen as an advantage over traditional ESB, stating one difference between Mule and traditional ESB is that Mule only converts data as needed. With typical ESB, you have to create an adapter for every application you connect to the bus and convert application data into single common messaging format. Mule increases the performance and reduces the development time over traditional ESB. As a result, Mule uses a proprietary API and message format and does not embrace JBI or SCA as its underlying integration model. Service components, previously called Universal Mule Objects or UMO, implements custom application logic and operate on the content of the message on a logical level. Similar to JBI service engines, they are decoupled from specific messaging or protocol formats required for communicating with other components or external applications. This is performed by transformers, which converts between different data formats and wrap them in Mule messages, whereas the transport handle protocol conversions as needed, bridging between communication protocols such as JMS, SOAP, HTTP, file or proprietary protocol similar to JBI binding components. Finally, routers are used to deliver incoming messages to service component and for sending outgoing messages to the target component according to the configuration. In JBI, there is a central shared router that handles messaging the messaging and connection in all endpoints. The normalized message router routers can perform additional logic such as filtering or message composition or decomposition, implementing a message routing patterns. The basic architecture and message flow is illustrated in this figure here. Mule uses a compact XML format for describing the configuration and these are the inbound and outbound routers. The Mule uses XML-based XML format for describing the configuration and supports the Spring for lightweight specification of the desired integration. Development support is provided by the Ant and Maven scripts. There is an also Eclipse plugin, Mule IDE, for basic configuration and deployment within the IDE. Recently, the Mule IDE has been extended to provide visual editor for designing integration maps, but this has not yet been ported to the Mule, the new Mule 2.0 release. Compared to the full JBI solution, Mule is easier to get started with the and provides a more lightweight configuration-centric integration model with little restrictions on architecture or message format. Components may have be simple Java object or Spring Beans, which can be directly integrated without code changes by writing suitable configuration. This simple approach allows to quickly set up the prototypes and reduce the time to market or for small to medium size projects, but allows solution to grow enterprise scale when needed. Because of the clustering support in Mule, especially in the small or performance critical settings, Mule provides an advantage by transforming messages only when it is needed at the last possible moment, which is sometimes compared to late binding in programming languages. Mule has recently been integrated into an integration stack with various components working together called Mule Gateway. Integration into existing environments is possible in several ways, either as a component inside JWA application server or by connecting to an existing message bus over JMS or similar protocol supported by Mule. The deviation from Open API's common messaging format and core ESB principles also has significant disadvantages and bears the danger of vendor lock in. Mule is the only implementation available, and spaghetti integration as component is still tightly coupled and statically configured, which can result in high complex and transports. In this way, Mule really only realizes component integration and not service-oriented integration, which would require the consistent usage of standard-based interfaces such as WSDL, which is utilized in JBI. Also, because the endpoint have to explicitly specify, there is no real location transparency, which is the core principle behind SOA. Moreover, Mule does not support hot deployment or reconfiguration on the fly. This has been the long-standing point of criticism and will be addressed in upcoming version by using OSGI as underlying component model. Much of the Mule's unique advantages proclaimed in Mule's advantages are there and can be realized with JBI in the standard compliant manner without incurring disadvantage of Mule, as shown here. Any component type is supported in JBI. Components can be easily wrapped into service engineer or engines or binding components. Service mix also support POJO, plain old Java objects, directly through API extensions and provide lightweight configuration model using XBeans. JBI 2.0 will also support OSGI components. Better component reuse and less API overhead. JBI components can be reused across different runtimes, which is out of scope for Mule. This comes at the price of the added API complexity, which is why the many JBI implementation introduce more lightweight API layers that allow easy development of JBI component, but are not always fully JBI compatible, restricting use across JBI containers. JBI 2.0 will, however, refactor the API. It is overly complex or restrictive and make the specification more developer friendly in general. Recording is also not necessarily in JBI, as service units provide rich ways of reconfiguration even at runtime. No restriction on the message format. JBI requires transformation into normalized but non-canonical XML format on the purpose, and its distributed complexity of the integration solution minimizes the risk at tight coupling and point-to-point integration, which can easily happen at the Mule implementation. Are free to optimize flow where possible, so transformation is not performed when the communication endpoints use the same protocol. Also, binary formats and proprietary extensions are supported all through attachment and metadata respectively. Support for various topologies beside ESB. The JBI specification does not restrict implementation to an ESB topology, but allows the implementation to choose any topology that makes sense in the target environment, which has been already shown the target environment. And next version of OpenESB will support peer-to-peer messaging using JXTA, and other JBI implementations support various messaging and clustering forms such as JMS, SEDA, and proxying. The disadvantages identified above and restriction imposed by the proprietary Mule API make it unusable for sustainable tool integration, especially when comparing against the requirement and alternatives outlined before. Also, Mule 1.x has been previously tried for the toolnet redesign in a case study, but was found to be too restrictive with regards to endpoint addresses, as it did not support dynamic endpoint. For example, when tools come online or go offline, this limitation to static configuration impedes dynamic tool reconfiguration and agile workflows. Mule does not fully apply best practices in SOI and enterprise integration, which may result in complex solutions that are easy to build initially but hard to maintain later. However, this straightforward approach to integration, easy configuration, maximizing reuse of existing service component, and low API overhead, maximizing performance and ease in development, they are the key advantage that should be allowed in JBI 2.0 where possible. Here you can see a message sent to http:// here myfirm.com/mule, and it's interacts with the HTTP message here, and it's connected to HTTP transport, and HTTP transport is connected to the service here. Here you can see the inbound router, and here the endpoint http://myfirm.com/mule is there, and here the outbound route is connected to the endpoint JMS://myq. Here the customer data service component and endpoints are in the service here, and here the service is connected to JMS transport, and the transport is connected to JMS message here, and it's connected to service here. Here you can see the inbound router and endpoint JMS colon 47 MyQ, and here the order fulfillment service component, and this endpoint are in the service here. Here you can see Mule ESB service framework. The service framework in Mule has existed for building integration solution. Design is simple and highly scalable. One, the message flow in the channel to an inbound endpoint. To the transformations and filters are applied if necessary. To the service component processes the messages. And finally, for the outbound router, send them to their way to the desired outbound endpoint. Again, applying the transformations or filters as necessary. Using the basic concept, many integration patterns can be solved, and since it is based on SCADA architecture, when processing its asynchronous Mule engines, Mule ensures high performance and scalability. Here you can see the Mule ESB service framework. Mule's service framework. Suddenly the Mule 3 trots along, and you hear about this new concept called flows. Why change your deployments to use the new and what seemed like a different framework? First of all, good news, and if you are existing implementation based on the services, nothing has to change when moving to Mule 3. Services are still valid patterns for implementing integration solutions in Mule, and your application will run and scale just to fine on Mule 3. In fact, we will here you can see application is connected to endpoint via channel here. Here the inbound routers, service component, and outbound routers are in service. Here the endpoints are in the inbound routers, and endpoint interacts with the transformers. And here the inbound routers are connected to service component. Service component is connected to outbound routers here, and here the transformers endpoints are in the outbound routers, and transformers interact with the endpoints, and endpoints are connected to application here via channel. Here you can see an example of Mule flow. In taking to Mule users and reviewing numerous Mule implementation, we discovered that the many implemented patterns just didn't fit the clean it into a strict service-based framework. They are not simply wrapping a single component with endpoints to decouple it from the protocols and routing requirements. Often they were performing service mediation and light process orchestration, attempting to automate business process, or replace a point-to-point integration solution with a more decoupled mechanism that can be reused or changed as systems or business needs change. Some common use cases that flow is well suited for include simple integration tasks, scheduled data processing, connecting cloud and on-premises application, event processing where multiple services needed to decouple. When we implement the new message processor in architecture in Mule 3, this allows us to offer new patterns to implement service mediation and orchestration in Studio. You even can see the visual representation of the flow. Most of the use cases supported with services continue to be supported in Flow, along with many new ones based on the Flow specific routers we are implementing. Some key advantages of Flow: create and reuse subflows, chain together multiple components in one flow, integrate endpoints or cloud connectors anywhere in the flow. Here you can see HTTP request is connected to CXF SOAP, and CXF SOAP is connected to create summary, and create summary is connected to here. And here the choice is connected to small order, medium order, and large order, and it's connected to async echo is connected to create tweet, and create tweet is connected to Twitter, and here the echo, create tweet, and Twitter are in async. Here this is connected to SOAP, and SOAP is connected to response. Echo is in the response, and response is connected to here the HTTP. So about as an example, we can consider these steps. This is about deploy an application from Runtime Manager. Here to deploy from Runtime Manager to CloudHub. Step 1, sign in to Anypoint platform. Step 2, select Runtime Manager. Step 3, in the application page, click Deploy Application. Step 4, provide a name for your application. Step 5, in the deployment target menu, select CloudHub if it is not already selected. Step 6, specify the application file. Import a file from Exchange. Click choose file, then import file from Exchange. B, select application for the type. Then enter the name of your application in the search box. Select the application to deploy. Select a version from the version menu and then click select. Next point, upload an application archive, zip or jar file. Select choose file, upload file. Select the file to upload and then click open. The application file size limit is 200 MB. Next point, copy an application from a non-production environment. Step 7, click tabs to configure application options. Step 8, click deploy application. Here you can see the step 3. In the application page, click deploy application. This is the deploy application page. You can this screenshot shows one here, the application name field, to the choose file menu, and 3, the deploy application button on the deploy application page. As an example 2, we can consider this code segment. This is CloudHub connector 1.0 Mule 4. This is a minimum CloudHub configuration. The Anypoint CloudHub connector for CloudHub connector enables you to connect to a CloudHub API from your Mule application. The basic CloudHub configuration has following properties: username, the user of the Anypoint platform account, password, the password of the given user, and the environment, the CloudHub environment used by default. This is the environment defined as the default Anypoint platform. As an example 3, we can consider this CloudHub API example. This following example shows how to retrieve schedules for an application. The CloudHub API, the CloudHub public API allows you to deploy and manage application in CloudHub. You can deploy your application manage schedules and queries within an application, and view logs pertain to an application. You can also view memory and CPU usage and get statistics about Mule messages sent using application. This is the request. And this is the response. As an example 4, we can consider this code segment. Following is then introduction to configuring Mule ESB via the Spring XML file. Following is an example of a simple Mule configuration file. A Mule ESB configuration file is a tree. Each of these elements provide access to configuration objects within Mule. Custom message processors observe a message or modify either a message or a message flow. Example include transformers and filters. Flows use message processors to define message flow between source and target. Mule global configuration, global settings such as default transaction timeout that apply to the entire Mule configuration. Connectors, non-default configuration of any transports use. Endpoints, define the channel and address or path where messages are sent or received. You can define them globally and use them in multiple flows. Transformers convert data from one format to another. You can define them globally and use them in multiple flows. Filters filter out the messages that don't match specific criteria. You can define them globally and use them in multiple flows. And other more advanced things you may configure at this level is Security Manager authenticates requests based on one or more security providers. Agents are typically used for cross-cutting concerns such as logging or management. Notification allow you to be notified upon certain lifecycle events. Transaction management, Mule transactions are configured in inbound on inbound endpoints, or where an endpoint can be configured to start a new transaction or join existing one. Properties, property placeholders, message property, system, and system properties. There are Configurations in Mule configurations are set when Mule context is created. The object becomes immutable after it is started and can be accessed using following, like here get configuration. Interface Mule configuration info, which can be set when creating the Mule context, but becomes immutable after startup. This is in package org.mule.api.config, and this is implement Mule context aware to have the reference injected. Considering login to Anypoint platform from IDE. Here we are considering in the Anypoint code builder. Here we are considering logging from the IDE through the status bar. The status bar in the desktop and cloud IDE shows your logging status. Not logged into Anypoint platform indicates that you must log in to perform tasks that require a connection to Anypoint platform. You can log in by clicking the notification and following the prompt to login. The link to your username indicates that you logged in. You can log out by clicking the username and following the prompts. Now we are considering login to the login from the IDE through the command palette. In logging to Anypoint platform from IDE in Anypoint platform builder, you can use the command palette to log in to the Anypoint platform. To log in to the from the IDE to the command palette, open the command palette. Show me how. Select the following command: the MuleSoft login to Anypoint platform. Tip: you can log in and use the filter in the result to select command you want. Then 3 to select allow when prompted to sign in to the platform. Alter login. After logging you in Anypoint platform display, you can close this page now message. To verify you are login, ensure username replaces the not login into the Anypoint platform. Now we are considering install the core package and default plugins in installing Anypoint CLI 4.x in Anypoint CLI. Run the following command to install the Anypoint CLI core package and all the default plugins. Here npm install -d -g Anypoint CLI v4. Now we are considering account user described in Anypoint platform accounts in Anypoint CLI 4.x list of command in Anypoint CLI. Account user describe flags returns your account information including your username, your full name, and your email address and creation date of your account. Use the --output flag to specify the response format. Supported values are table, default, and JSON. This command accepts the default flag --help. Now we are considering a summary of changes in Anypoint integration, Anypoint platform integration overview in RPA. After your organization is integrated into the Anypoint platform, users log into RPA Manager, RPA Builder, and RPA Recorder using the Anypoint platform account. Administrators configure RPA users, teams, and permissions using access management instead of user management module in RPA Manager. RPA Manager deprecates roles and user groups and start using teams from the Anypoint platform instead. RPA Manager supports using connected apps to connect to Anypoint platform, which provide more secure and improved authentication mechanism than API keys. RPA Manager supports deleting users who have assigned processes and reassigning those processes to other teams. For non-federated, MuleSoft automatically creates teams in Anypoint platform to match the existing roles and user groups in RPA Manager. Teams names are restricted to alphanumeric characters, hyphens, underscores, and spaces. If your role or user group contains unsupported characters, these characters are omitted from when creating the new team name. Roles migrate to teams using the following naming convention: RPA role dash existing role name. User group, these new teams have the same Anypoint permission for RPA pages that the role had in the RPA Manager. User groups migrate to teams using following naming convention: RPA user group dash existing user group name. Users assigned to roles and user groups in RPA Manager migrate to the corresponding team in Anypoint platform. Now we are considering choosing a hosting option in Anypoint platform hosting overview. Anypoint platform is designed to enable the control plane and runtime plane to be hosted independently. Depending on your requirements, you can choose from the following: use Anypoint platform in MuleSoft manage control plane and runtime plane. Host and manage runtime plane with your own infrastructure while connecting it with the MuleSoft manage control plane. Host both the control plane and runtime plane locally with your infrastructure. See the control plane and runtime plane support metrics in the documentation for more about running which runtime plane hosting options are supported in each control panel option. Now we are considering why we deployed on CloudHub 2.0 in CloudHub 2.0. CloudHub 2.0 provides for deployments across 12 regions globally. Dynamically displays the infrastructure and built-in services up or down to support elastic transaction volumes. Built-in security policies protecting your services and sensitive data with encrypted secrets, firewall controls, and restricted shell access. Encrypts certificates, password, and other sensitive configuration data at the rest and transit with Anypoint platform. Provide a standardized isolation boundary by running each Mule instance and service as a separate container. For CloudHub 2.0, pricing information, contact either your account executive or your account deployment representative. Now we're considering August 25, 2023 CloudHub 2.0 release notes. What's new? When you attempt to delete a private space that has apps deployed, the warning appeared confirming you want to delete the private space and the apps that are deployed to it. If you continue to deletion, private space and all its deployed apps are deleted. Now we are considering technical enhancement from the CloudHub 1.0 to 2.0 in CloudHub 2.0 for CloudHub 1.0 users in features of CloudHub 2.0. The following improvements have been made to features that are also available in CloudHub 1.0. With the added functional vCore offerings in CloudHub 2.0, you may no longer need to bundle multiple listeners in the same application to reduce your resource usage. In CloudHub 2.0, private access functions has improved VPC from CloudHub 1.0. You can automatically assign private network from the application in private space. You can also configure private ingress load balancer that auto scales to accommodate traffic. By default, VPNs allow high availability. Applications now have public and private endpoints. By default, you can also configure multiple public endpoints. You can access the endpoints addresses in Runtime Manager. You can make namespace edits and updates to the TLS context and infrastructure of ingress layer. In CloudHub 1.0, application names had to be unique per control panel plane. In CloudHub 2.0, application names must be unique per private space. Custom log4j.xml is supported by default to enable streaming logs to external log collectors. You no longer need to contact support to enable or disable this feature. You can disable log streaming using Runtime Manager. You no longer need to contact support to enable or disable this feature. Self-service logs for dedicated load balancer and ingress are available via the private space. Titanium users can also download logs through Anypoint Monitoring. Users using ports 80 and 443 applications inside the private space can communicate using internal load balancer via the private endpoint. This depends on the application protocol. Now we are considering update the runtime version manually in monthly date patch updates in CloudHub 2.0 operating system patch updates in CloudHub 2.0 architecture. Login to Anypoint platform, navigate to the Runtime Manager. In the Runtime Manager navigation menu, click Applications, select the application you want to update. In Settings, in the Deployment Target tab, click the Runtime Version drop-down. Select the latest build for your version. Click Deploy. The application redeploys with the new runtime version. Now we are considering creating a private space. Create a private space in creating private spaces in extending your network to Anypoint platform with private spaces in CloudHub 2.0. From Anypoint platform, select Runtime Manager, then private spaces. The page shows any private spaces associated with the selected business group. Click Create Private Space. Enter the name for your private space and click Create. You cannot rename your private space after you created it. Now we are considering deploy an app to a shared space. In deploying apps to shared space, in deploying apps to CloudHub 2.0. From Anypoint platform, select Runtime Manager, then Applications. Click Deploy Application. Then on the Deploy Application page, enter the name of the application. Important, you cannot change the name of the app after you deploy it. You change the name, and you must delete and redeploy the app using new name. Then select an application file. To upload the Mule jar file from your system, choose File and then Upload File. Choose an example app from Anypoint Exchange. Select Choose. Then import file from Exchange. Then you get in the Get from Exchange page, enter hello in the search assets by name. Click the hello world and then click select. Then they select CloudHub 2.0. Then the shared space for the region from the deployment target list. For the list of regions, select shared global regions. See shared global regions in the documentation. If you have global deployment entitlement, all regions are available. If you have a region restriction based on the subscription, only regions that are available to your organization appear. Configure options for the deployment. Specify runtime options. Change app behavior with properties. Configure logging for the app. Then click Deploy Application. Now we are considering update app settings in updating the apps deployed to the CloudHub 2.0 and managing apps deployed to CloudHub 2.0. From Anypoint platform, select Runtime Manager, then Applications. Then click Runtime. Click the app name. Click in the navigation name. Click Settings. Click Configuration to display the app configuration history. Config tab, Changes tab, display the changes to successfully deployed application configuration and includes the last 10 configuration deployments in order by configuration date. A unique hash identifies each configuration in the history. All changes tab display the history of versions created from the configuration deployment and the actions performed on each version. 5. Here depending on the deployment target, shared or private space, change the deployed configuration. Specify the name runtime options that such as uploading new application file or changing the deployment target and resource allocation. View the app's current version. Change the public endpoint for the app. Change the app behavior with properties. Disable or enable the app logs and specify log event levels. Click Apply Changes. The message appears at the top of the page indicating the configuration is on progress. Click view status to view the status for each replica in the deployment. When the configuration is successfully applied to the deployed, a message appears in the top of the page, and with the application status, configuration identified, date, and replica status. New configuration appears in the config changes list. In the configuration updates fail to deploy, the message indicates that the CloudHub 2.0 didn't apply the configuration. Configuration status is update failed, and the configuration appears in the config changes history without a label. In failure cases, the deployment attempts to roll back to the last successful version of configuration. In some situations, the rollback might not succeed, and the configuration status is update failed. Now we are considering view logs in viewing log data for deployed apps in monitoring apps deployed to CloudHub. To view logs for applications deployed in the into a private space, from Anypoint platform, select Runtime Manager, then Applications. Click the app name. In the navigation menu, click Logs. The logs page displays all logs for all replicas for the selected config with the latest messages at the bottom. The config represents the deployment since the last update. When you update application, new configuration is created. In this case, the logs page might be empty. The page stream logs messages as they occur unless the last deployed action is closed. Log from the before and last updated time appear in the drop-down containing previous deployment. Each message includes the severity, time, relative and absolute, and replica name. To view logs for different config, click the config drop-down list and select the config. Config label indicates the relative time of deployment, such as 10 hours ago. Now we are considering enable the monitoring agent in CloudHub setup in Visualizer. In order for your app to appear in Anypoint Visualizer for metrics to be displayed, you must manually enable the Anypoint monitoring agent for the following Mule versions. Mule version 3.8.7 patch releases available after August 14, 2019. Mule version 3.9 patch releases available after April 5, 2019. Mule version 4.1 patch releases are available after March 22, 2019. Mule version 4.2. To enable the Anypoint monitoring agent, log into Anypoint platform using the account that has the Anypoint monitoring permission. Navigation bar or main Anypoint platform screen, click monitoring. In the Anypoint monitoring navigation menu, click settings, select CloudHub. From the environment drop-down list, choose environment. In the list of resources in the environment name, search for the app to visualize. Next to the app, click enable and apply to enable visualization and monitoring for the app. Now we are considering CLI for CloudHub applications. In CloudHub in Anypoint CLI, runtime -mgr CloudHub -alert list. This command lists all assets associated with your current environment. This command has the --output flag. Use the --output flag to specify the response format. Support values are table, default, and JSON. This command also accepts the default flag --help. Now we are considering CLI for CloudHub dedicated load balancers in CloudHub in Anypoint CLI. The command here the CloudHub : balancer list. This command lists all the load balancers in your Anypoint platform. It displays the load balancer's name, domain, its state, and the Anypoint VPC ID to which the load balancer is bound. This command has the --output flag. Use --output flag to specify the response format. Support values are table, default, and JSON. This command also accepts the default flag --help. Now we are considering CLI for Anypoint virtual private cloud in CloudHub in Anypoint CLI. CloudHub : VPC : list. This command lists all the available Anypoint VPCs. It returns ID, region, and environment of the network, and where it is the default Anypoint VPC or not. This command has --output flag. Use the --output flag to specify the response format. Supported values are table, default, and JSON. Now we are considering deploy an app to CloudHub. In deploying Mule apps to CloudHub, we are developing integrations in Anypoint Code Builder. When you deploy an application to CloudHub, Anypoint Code Builder configure the default deploy.json file in your source main resources directory. If you need to configure the properties at deployment time, for example, create SQL properties, Anypoint Code Builder prompt you to modify the deploy.json during the deployment process. To deploy your app to CloudHub, in the activity bar of the IDE, click the Mule Anypoint Code Builder icon. To the open the configuration XML file for the Mule app. To deploy, click the deploy to CloudHub icon. Alternatively, open the command palette and select MuleSoft deploy to CloudHub. For the if prompted, click allow to sign in the using Anypoint platform and select the business group. If the project doesn't already have deploy.json file, Anypoint Code Builder prompt that deploying configuration file has created and opens it from it for you to review. For example, the application name property define the part of URL that you use to access your application on the CloudHub. This name must be unique across all applications deployed to CloudHub. After reviewing the deployment configuration, click deploy to deploy the application to the CloudHub. At the prompt, select the environment to deploy. At the prompt, then Anypoint Code Builder packages the application and deploys it to the CloudHub. The output panel opens the Mule Maven output. After deployment is complete, click open in Runtime Manager. Your app opens in the Runtime Manager in Anypoint platform. The domain name of the application varies, but it follows the similar structure such as app with 40 schedulers for schedulers.us w1.cloudhub.io. Open the preset preferred REST client and make the get request to your domain name as displayed in the Runtime Manager. For example, http:// app with 100 schedulers.us w1.cloudhub.io/API/flights. Now we are considering configuring OAuth 2.0 connectors on CloudHub. You can deploy your OAuth 2.0 enabled connectors to the Cloud Use Service. Configuring OAuth 2.0 for connector on the CloudHub is the same as the configuring OAuth 2.0 for the connector locally, except for CloudHub. The Mule application is behind an extra server. Consider the following when configuring OAuth 2.0 for the connector on the CloudHub. Connector listener. CloudHub manages some properties for you automatically, such as http.port and http.port. These properties when configuring your HTTP listener. When deploying on the cloud, the localhost 0.0.0.0 and 127.0.0.1 hosts are no longer publicly reachable. When configuring your OAuth provider, you must replace all links contained in those hosts with actual CloudHub provided public addresses. For CloudHub, this address is in the format chname appname.region.cloudhub.io. For example, HTTP appname ch example app deployed in the Europe London region has public address http:// ch example app.uk.e1.cloudhub.io. OAuth provider setup. If you set callback path to /callback, your public callback URL is chappname.region.cloudhub.io /callback. This is the callback URL to use as your direct URI when you configure your auth provider. Logging sign in direct URLs. Allow wildcard in logging URI direct. This must be configured to your connector as the external callback URI. You can use full domain property that CloudHub configured for you to automatically obtain the property hostname. If you are deploying to multiple regions or have some other gateway configured, use your hostname of the load balancer or the gateway in your auth provider callback URL and external callback URI. In the auth 2.0 configuration, user not auth provider reaches the callback endpoint from the browser. Ensure that your region is configured correctly and you create a CloudHub app in the US region and users connect to the app from the Europe. Request is blocked by the gateway. Now we are considering enable monitoring on CloudHub important CloudHub settings in configure and enable endpoint monitoring for Mule apps in CloudHub and in monitoring. You can enable monitoring for your CloudHub apps on the supported versions of Mule by adding a property to an application deployed to CloudHub. Log into the Anypoint platform. In the navigation bar or the main app, Anypoint platform screen, click Runtime Manager. And in the list of applications, select the application for which you wish to enable monitoring. In the application must be deployed to CloudHub and running on the supported version of Mule. In the navigation menu, click settings. In the properties and add the following property. Anypoint.platform.config.analytic.agent.enable equal true. To disable monitoring, change the value to false. Click apply changes. Now we are considering WebSockets connector in CloudHub version 4 in WebSocket connector in connectors. If you have you can deploy Mule apps that contain inbound WebSockets endpoints and outbound WebSocket endpoints, or both to CloudHub. If your app has inbound WebSockets endpoints only, to deploy the app in the CloudHub, you must configure an Anypoint virtual private cloud VPC. Set up the dedicated load balancer to route WS and WSS traffic through the Mule app. Now we are considering deploy to CloudHub. In deploy a Mule application to CloudHub in Studio, right click the project folder on your package explorer view, select the Anypoint platform and then deploy to CloudHub. If you don't have your Anypoint platform credentials configured in your Anypoint Studio, you will need to provide your login information before to continue. Configure to CloudHub instance to which your application is being deployed. Now we are considering deploy an application to CloudHub EU control panel in EU plane. The procedures for deploying an application to CloudHub in EU control plane is similar to those in the US control panel. However, consider the following the differences when deploying to EU control panel. EU control panel supports a smaller number of Mule runtimes than the US control panel. The domain of the CloudHub workers is appname.de.eu1.cloudhub.io. You can only deploy to Frankfurt and Dublin regions from the EU control panel. Application deployed in the EU control plane use object store version 2. Now we are considering deploy API to CloudHub. In step 5, we deploy the API to CloudHub in built an API from start to finish. To deploy an API in the form of Mule app from the studio, in the Mule design perspective, right click the Hello World app project in for example in your Explorer, package Explorer, and then select Anypoint platform, then deploy to CloudHub. If prompted, enter the Anypoint platform username and password and click sign in. You must be in your account sandbox. you must be in your account sandbox to deploy the API. If you see the design instead of sandbox, click the design to launch the switch environment dialog and click sandbox, then click switch. In the deployment application, enter the deployment application, enter the hello world greeting, first name, last name. Every app and API name must be unique across the Cloud Hub. This example uses hello world greeting Sandy Kim. For the deployment target, select Cloud Hub. Don't change any of the other default values. Click the deploy application. After a brief pause, Windows displays the status of the deployment. Click open in browsers to see the status displays in in Runtime Manager. When the project is successfully deployed, Runtime Manager display the status started. To test the API deployment, send the request from advanced REST client. Click started to display the app URL. Copy the app URL, which in this case the hello world greeting.sandykim.use2.cloudhub.io plus this URL is also be used later when configure the proxy API .plus. In advanced REST client, send the request to the base URI that you just copied. Be sure to add the API endpoint /API/greeting. And if you get the 200 OK, then the greeting you specified today is greeting hello, for example, and then you can have successfully deployed the API you created. Now you need to create API proxy application for this API to restrict access and keep service protected. You will add a rate limited policy, which you can do while the API is running, for example. Now we are considering steps to follow in Runtime Manager. In deploy a Mule application from Runtime Manager to a Cloud Hub by using a Java file. In deploy a Mule application in Flow Design in Design Center. Switch to the Cloud Hub environment in which you want to deploy the app. Click the deploy application. On the deploy application page, select file, upload file, then upload file and upload the Java file. Follow the instruction in deploying to Cloud Hub. Now we are considering CLI for Cloud Hub 2.0 in Anypoint CLI. Here the runtime-manager application, runtime-manager application deletes the running application is specified in the app ID. To get this ID, run the runtime-manager mgr application list command. Warning: this command does not prompt twice before deleting. If you send a delete instruction, it does not ask for confirmation. This command accepts only the default tag --help. Now we are considering create notification in Cloud Hub connector 1.1 reference Mule 4. Cloud Hub create notification creates a new notification. Now we are considering deploy application to Cloud Hub using the Mule Maven plugin. In deploy Mule applications in Mule runtime. Inside the plugin element in your project's pom.xml file, configure your Cloud Hub deployment, replacing the placeholder values with your Cloud Hub information here. With the command maven clean deploy -d mule deploy here. Now we're considering configure the Cloud Hub 2.0. Here the deploy applications to Cloud Hub 2.0 using the Mule Maven plugin. In deploy Mule application in Mule runtime, here the Maven MEN clean deploy -d Mule deploy. Um, as an exception example, we can consider this one. This is occurred during our API call curl -x get /https any / anypoint.mulesoft.com /cloudhub /API /applications /supported Mule versions here -h authorization bearer and with an 16e6 etc. The root exception struct trace com.mulesoft.cloudhub.client cloudhub exception forbidden at etc. As an example 2, we can consider this error while deploying the project: unable to create plugin from class com.mulesoft.muleesb.datamapper.plugin.datamapper plugin org.mule.api.lifecycle.initialization exception. And etc. As an error example, we can consider this error occurred in the environment with Anypoint Studio. Deploy to CloudHub application deploy has failed. Recent application deploy has failed. As an error example 2, we can consider this build failure in the environment with Anypoint Studio 5.2.0 and Mule ESB 3.0 3.70 warning the POM for COM 46 MuleSoft 40 Mule ESB Mule core EE jar is missing, no dependency information available. Warning the POM for COM etc. the modules Mule module spring config jar is missing, no dependency information available etc. Here this we can consider as an error example 3. We can consider this code segment. Expect an error in your test. The key is taken from the payload. And if the key is null, the object store connector will throw an error with OS invalid key error type here. To the test to validate this case would be something like this here. The here the Munit 2.3. The Munit is a Mule application testing framework that allows you to easily build automated tests for your integrations and APIs. It provides a full suite of integration and test unit capabilities and fully integrated with Maven Surefire for integration with your continuous deployment environment. Now we are considering Enterprise Manager and Insight. Enterprise Manager. Insight is a troubleshooting tool that provides in-depth visibility into business transactions and events on your Mule apps deployed to CloudHub and on-premises servers. Servers. Insight tracks everything your data does in an app, so you can find and recover from errors that occur during message processing. Following image shows where to find transactions, events, and metadata. Transactions, events, and metadata on Insight dashboard. This screenshot shows now the transaction level, 2 the event level, and 3 the metadata level on the Insight dashboard. With regard into search and filter transactions and events, the Insight dashboard displays the information at 3 tracking levels. The first point is transaction, logical groupings of related events that often correspond to a business view of the system. Events, low-level details of a transaction. Events map to message processors and endpoints and reveal information about exceptions and any custom business events you might have configured. Metadata, customized key value pairs that you specify as part of custom events in your application. The details that Insight tracks at this level provides information about high-level business events. The business data, if configured, appears in metadata area, number 3 here of the dashboard. As an example, we can consider this. This is how to disable business event on Insights. When you enable Insight in your CloudHub application, all business events from all flows are going to be tracked by default. You may not want to track events from certain flows. For example, one that is not totally related with the business event you want to track. If you do not want to track the business events from example flow 2, with an ID, we have to add the property tracking : enable default events equal false to the flow declaration here. Now the only the business events from example flow 1 are going to be tracked, and that is not shown here. That flow is different. As an example 2, we can consider how to enable Insight via the CloudHub API. The response should be here, and here the objective of this is to show how to use CloudHub API in order to enable Insight in a Mule app on a Mule application. But here with this command, especially here the app name being the relevant application name, and envid and bearer token, the information gathered. and this is a put request. The response should be HTTP 200 OK, and you should see the response body that tracking settings attribute here was changed from previous from the tracking setting attributes is tracking level : is metadata. The nested tracking level attribute is used to set the level. Valid values are disabled metadata and metadata underscore and underscore replay. To enable or disable Insight, to enable Insight to track the events your Mule servers generate, you should follow these ones. Step 1, sign into your Anypoint account, Anypoint platform account. Click Runtime Manager. Step 3, click Applications in the menu on the left and click Application in the menu column to open the management panel on the right side of the page. Step 4, in the management panel, click Insight. Step 5, click Settings in the menu on the left and then click the Insight tab. Step 6, select one of the tracking options. Disabled to disable Insight, metadata to track only events, metadata and replay to track events, and enable ability to instantly replay a transaction from the console. The metadata and replay option is available for Mule 3 apps with flows that have inbound endpoints deployed to CloudHub. This option is unavailable for Mule 4 apps or for free or trial user accounts. Step 7, select the checkbox to confirm that you want to enable Insight and click Apply Changes. And step 8, click Apply Changes to save the application settings. This is step 4, click Settings in the menu on the left and then click Insight tab. The arrow shows the Insight tab on the settings page. Here you can see tracking options, disable to disable Insight, and metadata to track only events, and metadata and replay to track events, and enable the ability to instantly replay the transaction from console. As an example 4, we can consider status stalled. The event has been put on hold due to an exceeding the maximum number of events to be processed per transaction, 10,000. Any event above this number is set as stalled and then processed after the number of events to be processed is no longer exceeded. As an exception example, we can consider status failed. The event failed while being processed and has an associated exception. As an error example, we can consider Insight service unavailable. Please try again later. When trying to enable Insight for a hybrid deployed application, this error occurred, and this is in the environment with Runtime Manager. Now we are considering Anypoint Service Registry, now part of API Manager. Built for the new Enterprise Anypoint Service Registry is SOA, a governance platform that ensures compliance with internal standards and best practices as well as regulatory mandates. Moreover, Anypoint Service Registry make it easy to manage and monitor services, keeping you apprised of the performance and usage patterns of all of your services. You can focus on innovation and optimization and not governance. As an example, we can consider this code segment, storing objects in the registry. Here you can see the this produced the interface get registry provide interface Mule registry adds lookup register unregister methods for Mule specific entities to the standard registry interface. This is in Java, and this is in package org.mule.api.registry. If you need to store runtime data that is available across the application, you can store data as objects in the registry. You can get a handle to the registry from anywhere that you can access the Mule context as in the Mule entities. So for example, you can store objects as follows here. As an example too, we can consider interface service registry in org.mule.runtime.co.api.registry. Locates and returns all registered instances of a given provider class. Advantages of using this interface instead of hitting something like service loader directly are ability to inject a different lookup mechanism and to facilitate testing. As an error example, we can consider this error occurred in the environment with Mule core endpoints 3.4.0, deploying application key issue test, reading plugins from C:\Mule/Mule Studio for Win, etc. And here also registry plugin Anypoint, and here you can see com.mulesoft.habitat.agent.anypoint agent utils Anypoint service registry agent is disabled. Property anypoint.agent.token is missing or empty, and etc.